Hey everyone, I welcome you all to the Intellipaat's YouTube channel. In today's session, we will be learning about cybersecurity. This session is conducted by an expert having more than 15 plus years of industry experience. But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us. The world is moving at rapid pace. The speed at which the current world is progressing and becoming highly dependent on mobile computing and the internet for most of the processes. Cybersecurity is a field of IT and is among the most sought after career options today. Cybersecurity analysts are professionals who monitor computer networks, database, computer infrastructure, etc. of an organization and make sure that they are safe and protected from malicious activities and external threats. This in turn allows the organization to maintain its reputation and integrity by keeping its own and its clients' data safe. Cybersecurity experts are in huge demand and are highly paid. So, if you wish to learn cybersecurity and make a career in it, then this video is the best start for you. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to Cybersecurity. In that, we will tell you what is cybersecurity and why do we need it. Post that, we will be learning about different cybersecurity threats. After that, we will give you all the information about network security and cryptography. Then later on, we will be explaining you about data security and how to bring data security in the organization. Post that, we will be learning about CIA, assets, integrity and IEEE concepts. Then later on, we will be learning all about cloud security and its principles. After that, we will tell you how to design and implement cloud storage. Then we'll move on to the difference between ethical hacking and cybersecurity. Then finally, we have covered how to become a cybersecurity expert in 2021. So guys, this is the agenda of the video. Now let's begin.
So what is cybersecurity? By definition, cybersecurity is a field of computer science that deals with the protection of networks, devices, programs, and data from attack, damage, or unauthorized access. You can think of cybersecurity as a set of protocols which are just there to save the integrity of your data, to make sure that no one else can have it, and make sure that in between when you are sending the data, no one else gets to tamper it. So it's just basically a security against any kind of threat to the digital information that you have. That is what basically cybersecurity is. So let's move along and talk about the average salary of the cybersecurity specialist. So these people who are working in this field for protecting our data, their average salary in numbers looks like in USA, if you are a cybersecurity specialist, you're looking at a figure of around $102,000. And if you're in India, you're looking at an average base of 8.25, although this number seems very less right now. Most of the cybersecurity specialists are paid a lot more than that, and the job roles which you get decide what kind of an average salary you're getting. So as you go along with more experience, you get more money. The more skills that you have, the different kind of job role that you have, and the different responsibilities that you get you the bigger numbers and get you in the bigger field for that matter. And if you are in UK, you are looking at a figure of around 78,000 pounds. So that is the figures. And the companies which are hiring for cybersecurity specialists in this time of quarantine as well are the industry giants, and you must recognize almost all of these images which are there on the screen, all of these logos. So you can start from the left hand side corner, all of your social media websites, everybody, may it be LinkedIn, Instagram, WhatsApp, or Twitter, or anyone else whoever has an online presence in terms of business are looking for people in cybersecurity. So those are the companies there, and there are other big names who again hire for cybersecurity. Top names would be Mu Sigma, IBM, Oracle, Siemens, Skype, Google, Adobe, Ola, or basically any app which you see on the internet, or which is basically a company who is posting some kind of an e-commerce or anything of that sort, will be having cybersecurity specialists to protect their business and protect their consumers from any kind of cyber breach, may it be their data or may it be their conversation or anything that anyone is eavesdropping or anything like that. These are the companies who will be looking to hire cybersecurity specialists. So you can imagine the amount of openings which are out there, because they're almost all of the every day that you live, day-to-day life, everything that you use is some way, some form related to internet anywhere. From you ordering food online through Swiggy, Zomato, or any other food chain or food app, to you buying groceries from Big Basket or Grofers. Every company will have cybersecurity specialists, and it comes down to texting to your loved ones through WhatsApp or any other app that you're using, or Facebook, or watching your YouTube videos. Everything comes for cybersecurity. So everybody is hiring for cybersecurity. That's why it is a very much in demand field. So far we have discussed about how much money you will get and what cybersecurity is. But the major thing that we wanted to discuss here are the different job roles which are there in cybersecurity, because as you know, there is no linear path to a successful career in cybersecurity. Most of the people enter the security field straight out of college, or they might do a transition from another IT or another job role that they have. But no matter where you start, all cybersecurity career begins with a general IT experience, and you need to understand basically how the technology works before you even can begin to secure it. You must understand how you have to work with how that particular technology works. Only then you can go about, okay, this is how it works, and this is how it might be vulnerable, and this is what we can do to protect it. So before even you start protecting it, you need to understand about the technology that you are going to protect, and that's why you must have some IT presence in order to work for any of these job roles that we are talking about, right? So let's quickly jump on and talk about the different job roles which are out there. So there are several job roles, and we are going to be classifying the four of the major roles which are out there. So we'll be beginning with security architect, and then we'll move on and talk about security consultant, and then there is ethical hacker, and then there is security analyst. So a security architect is basically someone who is tasked with designing, building, and implementation of network and computer security for an organization. Security architects are responsible for creating complex security structures and ensuring that they function very properly. They design the security systems to combat different kinds of malwares, different types of hackers intrusions, or maybe DDoS attacks. So basically, these people are the people who design how the your application will be interacting with different things through different protocols. They decide which protocols has to be there, which subnet to go, and everything. So the entire architecture of your security domain is done by the security architect. And in United States, these people earn an average salary of around $118,000, and with more experience you get better at it. So if you are working as a cybersecurity architect, you will be required to plan, research, and design durable security architects for various IT projects that you have. You will be developing requirements for networks, firewalls, routers, and different things related to the network devices. You will be performing vulnerability testing, security assessments, and risk analysis. And finally, you will be tasked with a research and implementation of the latest security standards like 256 SHA, and different security standards are there for different things. So you need to research upon how to implement those and the new security standards which are there, and you have to follow the best practices and stuff like that. And every part of it is basically the job of a security architect. The next job that comes is the security consultant. Now, the security consultant is basically is a catch-all cybersecurity expert, right? These people assess the cybersecurity risks, problems, and solutions for various different organizations, and they guide them in protecting the security of their physical as well as physical capital and the data that they have. So you can think about it as it is similar to the word consultant is there. So these people basically are the people who are called by different organizations to look at their preemptive or primitive given security standards which they have, and they are asked to tell if they see any vulnerabilities, or they are asked to consult about how we can go about in creating our own and what are the different standards that we need to have. So these people have to be the experts in the field of cybersecurity to in order to deliver the best knowledge to various different organizations which are working. Not all the organizations which is out there are very expert in cybersecurity. Some are very some people have very small businesses. They don't really care about that much in depth about cybersecurity. They don't know it, so that's why they hire security consultants who come up and help them set up the networks that they need in order to have their own environment very safe. So these security consultants need to be very flexible and savvy, as they deal with a wide range of variables when they're assessing this security system across various diverse companies and the industries, because they're working with different kinds of industries, different kinds of companies. There will be different security standards involved, so they need to be flexible and they need to understand the whole picture at once, so that they can consult in those people in a better manner, so that the end result is um, a secure one for that matter. So, as a security consultant, your daily tasks may include determining the best ways to protect the computers, networks, data, and information systems from potential attacks. You'll be performing again the vulnerability test and security assessments. You'll be interviewing staff and department heads to uncover the security issues. So, you'll be talking to everyone about if they know about some potential breach or how did that happen, and you will interview across the people to understand what your security system looks like and how vulnerable it is. And then you will be testing security solutions using industry standard analysis methods, and you'll be providing technical supervision and guidance to a security team. As a consultant, your task is to guide them through the way of reaching cyber security, right? Then the next job role which comes on the hand is of the ethical hacker. Now, ethical hacker is basically someone who is a penetration tester, you can call him as well. So basically the job of these people is to find the weakness in your IT systems, right? May it be your networks or applications, whatever. Using the same knowledge and tactics that a cyber criminal hacker would do. So their job is similar to someone who is trying to hack you, but they are doing it for ethical reasons, so that they don't hack you for the reasons that they want money from you. They hack you and find the vulnerability of the system so that your company can work upon it and make their entire infrastructure more secure. So these people find the bugs or the different things which are vulnerable inside system and report it for you, so that you can be more secure. So penetration testers generally use a series of tools to simulate real life cyber attack. They identify the weak spots and they help the organizations improve their security posture. The average salary of a penetration tester in USA is around $80,000, and many penetration testers and ethical hackers uh, uh, have a very similar job role. So, as a penetration tester, you will be expected to perform penetration analysis on the web application, networks, and computer system. You'll be asked to uncover the security holes and pinpoint the methods of attackers and different things that they can use to exploit the weaknesses in your system. So you have to uncover those things as well. Then you will have to research, document, and discuss the findings with the management and the IT team. So whoever is there, you need to tell them about your findings. Okay, these are the vulnerabilities which we saw, and this is the way you might be able to improve it. And after that, you will be tasked with designing and the implementation of new penetration tools and tests, so that you can check for more vulnerabilities. And if there is some new kind of attack of if anyone has created, then you need to be well versed with it, so that you are ready for those kinds of attacks as well. And then finally, there is a job of a security analyst. So these people are basically the people who are involved with your IT infrastructure. They go through the logs and everything, and they tell you if there is some potential breach which has happened right now. So they can tell it through various different ways. They can, for example, if there is a DDoS attack on your system, so your uh, uh, CPU usage would plummet or it will go high, and the CPU usage will go high, or there will be some storage problems causing or something like that. So the job of the security analyst is to go through the system, look through the details, crunch the numbers, and find out if there was any potential breach at some given point of time, or if someone tried to breach you at some point of time and fail. So the both of those things, and how they were trying to do it. So the analyst is job is to find out if there was anything happening which was fishy. So that is basically the job of the security analyst. So these are the various different job roles across the domains that you can apply for if you're looking to become a cybersecurity specialist. So let's see a job description stating the same. So this is a job description of a penetration tester given by Cisco. So basically, the job description includes performing of penetration tests on web applications, uncover the security holes, and pinpoint the methods used by the attackers to exploit the system, research documents, and discuss the findings with the IT department. And the same thing as I mentioned before. So these are the job in the job description of the penetration testers. You'll find the similar things across the domains, because these people will be expected to uh, find different ways to get through your system, so that when, let's say, a potential hacker someday tries to attack you in a similar fashion, they won't be able to do it because you have covered your tracks before by doing penetration testing. So that is the job description, guys. Let's move on and talk about the skills that you will be needing in order to become a cybersecurity specialist. So, in order to become a cybersecurity specialist, the first and the foremost thing that you need to have is some IT background. And for having that IT background, you must understand programming and scripting. So, as you would have seen, a lot of people do in various web series. Although I would say that is not a very accurate representation of what how lives look like as an ethical hacker or penetration tester, but the programming part remains. So you need to have a very good understanding of how programming works, how algorithm works, how different systems are designed, how scripting is done, and basically the basic understanding of the infrastructure of IT is very, very, very important if you are looking to become a cybersecurity specialist. Then you need to understand different network protocols. So there are different standard protocols which are out there, and many different protocols work in different ways. There is aloha protocol, there's a lot of different things. Then there are hashing standards which you have to follow, and a lot of different things. So in by network protocols, I basically mean you must understand the different security standard things which are out there, different network protocols which are out there, how systems communicate with one another, and how you can make them secure. So understanding the different layers of protocols which are followed as well is also very important when it comes to cybersecurity. And understanding those will basically allow you to understand how the system is communicating with one another, because not many times you just need to penetrate the system. Sometimes people can hijack your data midway. Like for example, if I send a packet from my end to the other end of the server, there could be someone listening on the way and they can tamper with the data. So you need to be secure that while even transferring the data in the pathway, there is no one listening or no one trying to gain some data from the information which is being sent. So that is why it is very important to understand different network protocols as well. And then you will be expected to do penetration testing, and there are various different tools that you can do for doing so. Nmap is a good example of it, and they use various different variety of tools are out there. So depending on the use case, different kinds of penetration testing can be done, and sometimes as simple as DDoS attacks sometimes work. So you need to be well versed with that as well. And once you understand how the penetration testing works, you need to be ready for these attacks. So there's one job where you prepare your system for it, and then there is another job to detect if anyone is trying to attack your system, right? So the penetration testing, network protocols and everything, you do it beforehand to make your system secure. But let's say if we were attacked, in those case we need to find it as soon as possible before they do major amount of damage, right? So before they hit us with the damage, we need to detect their intrusion beforehand, before they get very deep into the system and extract very valuable information from us. So for doing that, also for doing intrusion detection, there's a lot of different things which are out there. A lot of softwares are available, and you can use various different kinds of metrics to understand if they have intruded your data in some form or the other. For that, again, you need to understand intrusion detection. And then there is something called as a malware analysis. So basically, there's a lot of lot of softwares which are out there which can infect your system, and infecting one system can even infect your entire network security standards. And to understand how these malwares work and warn your team beforehand, okay, these things might affect your system, and you have to be ready for it. So an understanding of how they can attack your system is also very important before you go ahead and secure your system, right? So understanding of those different softwares which basically infect your system is very, very necessary if you're aiming to become a cybersecurity specialist. So that is about the skill, guys. So let's quickly jump on and talk about how you can go and learn about cybersecurity. So the learning path of cybersecurity is fairly straightforward. So you can learn about programming and scripting first and foremost, and then you learn about the network security protocols. Then you understand the common security threats which are out there. Then you learn to develop a security scheme which can save you from the common security threats and stuff like that. And once you are ready with all of those, then you get certified yourself. So you go ahead and you get yourself certification. So there are a lot of different certifications which are out there. You can apply for those and you can get yourself certified. And a certified personnel is more likely to land a job than in cybersecurity than someone who does not, because this field is again about getting the people who are best in securing the systems and who is more better or qualified than people who are actually certified in certain domains to lead that part, right? So once you get certified, you can go ahead and apply jobs and land yourself a cybersecurity job and be in the world where you protect people from getting attacked.
What is hacking? Hacking is defined as gaining unauthorized access to a computer, system, or a network. So, hacking essentially alludes to when a person tries to hack into a system or gain access to a system by unauthorized means. Basically means that if you go on to Facebook, the legal way of logging into your account would be simply entering your email and password. But what a hacker will do is that he will bypass that measure and get direct access into your account, which he is not supposed to do. So that is what hacking is. So you have a hacker and you have a target system. So this is how it generally works. The hacker has a target in sight, and the systems in today's world are always protected. So there are security measures in place between the hacker or any unauthorized person and the target system. So there are two ways in which the hacker can access this target system. The first way is bypassing the security measures. So as I discussed before, that is the easier way to go about it or the smarter way to go about it. And on the flip side, the hacker can implement some sort of algorithm to basically crack the security of the system as well. There are two ways in which the hacker can accomplish his task. So let us take an example of one such cyber attack. So in 2012, the Shamoon computer virus, also known as the W32 disk track virus, because it affected W32 Windows NET systems, was used against Saudi Arabia's national oil companies. So a group named the Cutting Sword of Justice claimed responsibility for this attack, and it affected about 35,000 Saudi Aramco workstations. Now, Saudi Aramco is the petroleum company in Saudi Arabia. And this caused the company to spend more than a week restoring their services. So, because of the sheer loss that was incurred by this organization due to this attack, this was termed as the biggest hack in history, right? So fuel trucks needed to be fueled up, and the business systems were not essentially working for the fuel trucks to operate, and that basically halted the entire business for a week until the systems were restored. So by this alone, we can understand the sheer scale of how big these cyber attacks can be. So there are a few types of hackers. So earlier we discussed in the Shamoon attack, a hacker that can be an anarchist group. There are other forms of hackers as well. So there is the black hat hacker, and there's a white hat hacker, and there's the gray hat hacker. So the black hat hacker is the hacker with malicious intent. Now, this hacker can be a thief. He can be hacking into systems for money. He can be hacking into systems to steal your personal information and sell it online. And he could be hacking just to have fun, basically, disrupt your day-to-day activities, disrupt your systems, or take your system on ransom. So this is basically what a black hat hacker is, a hacker with malicious intent. Now, polar opposite to that, you have the white hat hackers. Now, this hacker hacks with permission. So this hacker is usually a hacker that is working for an organization that does not want to be hacked. So the organization hires this hacker, tells him to basically hack into their own systems and find out the flaws and vulnerabilities in their system. So that is what the white hat hacker will do. And then there's the combination of the gray hat hacker and the white hat hacker. Now, the black hat hacker has malicious intent. The gray hat hacker most times will not have malicious intent. The gray hat hacker essentially does everything that the white hat hacker does, but without permission. Now, this could result in two things. What would happen is the gray hat hacker can take all of the findings that he has found to an organization and say that you have these flaws and vulnerabilities, you can fix them, and the organization can pay the gray hat hacker, or the organization can file a case against the gray hat hacker because of accessing their systems without the organization's permission. Now, naturally, the black hat hacker is absolutely illegal. The white hat hacker is legal because you're doing all of this with permission. And the gray hat hacker is obviously in the gray area itself because sometimes it could be legal and sometimes it could be illegal, but it's generally recommended to always go for the white hat hacker profession because it's the legal one. So please make sure you keep these things in mind whenever you're getting into the field of cybersecurity. So what is ethical hacking? Right now, just now we discussed what a white hat hacker is. Now, white hat hacking is a profession in itself and it's called ethical hacking. So, ethical hacking is the authorized and legal process of finding out vulnerabilities, threats, exploits in a system or computer network through penetration testing, right? So, penetration testing essentially refers to when you try all kinds of hacks and exploits onto a target system and find out in what ways you can access a system that is not supposed to be accessed by those means. So you're a white hat hacker and you've taken up the job of an ethical hacker in the cybersecurity domain in an organization. So you will hack a system with permission, and whatever you find, whatever your results are, whatever you're able to hack and whatever you're not able to hack, you'll log up a report for that, and then you'll send that report to your employer. So all of this information is then sent to the employer. Now it's up to the employer to apply the necessary security patches in order for these hacks to be basically ineffective against the target system. So next up, we can discuss some common hacks that are prevalent in today's world. So firstly, malware. So malware is the most common type of hack, and everybody I'm sure who's watching right now has come across this particular entity at one point or the other. These are essentially termed as viruses. For starters, these could be of three types or four types depending on the threat level that it carries. So we have Trojan horses. So Trojan horses pretend to be something else in our computer systems. They disguise themselves as something else, and they could be doing something like accessing key information about our computer, sending it online to some hackers. They could be doing that. They could be monitoring our system. Other than that, they could simply be installing ad scripts onto your web browser. So whenever you open up your web browser, I'm sure some of you have noticed the installation of some toolbars that were not supposed to be there. So these are essentially the tasks of the malware. You must have also seen some viruses that auto-replicate themselves and take up a lot of space in your system, and then you have to format your system entirely. So all of this comes under malware. And then you have phishing. So phishing is a sort of hack that basically alludes to taking the user's information, the login credentials of that user, for starters, for say their social media accounts or their bank accounts. So basically what the hacker will do is he'll send you a link for a dummy website with all of these space areas, these input areas for your email ID or your username or your banking credentials. And if you're vulnerable enough to actually believe that link and you don't actually verify the link, what that link is in your URL, if it's the correct one or not, you might enter those details, and what will happen is your details will essentially go directly to the hacker. And if the hacker is smart enough, what he'll do is he'll actually make the effort to redirect you to the correct page so you never suspect what has happened in the first place. So that is what phishing is. And then we have SQL injection. Now, MySQL databases earlier and even a little bit today are very susceptible to hacks because once the hacker gets direct access to your database, he can simply run a select script to get the information that he needs. Now, this could be about passwords. Say, if your database contains usernames and passwords, and the hacker is able to get the correct SQL statement into that database and is able to query your database with those credentials, he can get that information. And same goes for sales data or customers' private information as well. And then you have cross-site scripting. Now, you may have noticed if you went on websites that are not HTTPS secured or certified, you might have noticed some pop-ups that suddenly spring up.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Onto your web browser when you click on a certain link or a download button. Now, these are cross-site scripting hacks. So basically, these are hacks that are not running on the target system. The target system is you itself, who is actually trying to access a website. So your web browser will essentially run some JavaScript code, because in today's day and age, all web pages are almost dynamic. So what will happen is this JavaScript can be used to the hacker's advantage as well. So what the hacker will do is that he will write some malicious code in that JavaScript, and then your browser, in order to run the website, will run that code, and then your web browser or your system can get hacked due to that result. So it's always safer to basically browse websites that are certified and HTTPS secured. Then we have a high level of hack, which is called denial of service attack. So you must have heard about DDoS attacks. So basically what happens is you are running a website, right? You have a server that is equipped to deal with 1,000 requests every minute, say. That is the server's hardware capacity, right? Say if if a hacker gets wind that you have this particular website and he wants to inflict some damage onto you, what the hacker will do is essentially he'll virtualize 1,000,000 requests or 100,000 requests at once and send those requests onto your server. Now your server, if it's not properly equipped to deal with these DDoS attacks, what the server will do is that the server will try to process all of these requests at once. But the server is only equipped to deal with 1,000 requests at once, right? So the server will crash and your website will go down. And if you're running a successful website, that will result in loss of business as well. And you'll have to pay your maintenance team or your server maintenance team or installation team to basically fix that. So all of that is there. And that is what a denial of service attack is, so that any other user who's trying to access that website will not be able to access it because of slow response times or basically the crashing of the website's server itself. And then we have a man in the middle attack. So this involves mathematics and cryptography. So basically, if you use WhatsApp or Facebook Messenger or any kind of online messaging tool, you'll see this new notification that has come up in the recent days, which is this chat is now end-to-end encrypted, right? So end-to-end encryption basically means that whenever you send your string message to your recipient, the message is not sent as plain text, right, over the internet. The message is encrypted first using some sort of an encryption algorithm. That encrypted message is then transferred over the internet to the recipient of your message, and then it's decrypted at the recipient's end, right? So what the man in the middle attack is basically taking that encrypted message in the middle, using a decryption algorithm to decrypt it and find out the real meaning of that message. Now, this might not be that important for personal messaging and whatnot, but it's certainly a very damaging thing to happen if you're dealing with government agencies, and the risk of espionage and national secrets being revealed is very high. So it's especially important to ensure that these sorts of attacks do not happen in those organizations, and they have strong encryption algorithms. So let us now look at the importance of cybersecurity as a profession and field. So why do organizations need ethical hackers? Take an example. In short, the summary of this, and the source is Bloomberg Law, $7.5 million had to be paid by Google because of a vulnerability in their systems. Some information about their users were leaked. So information of up to 500,000 users were leaked and exposed due to the software glitches that the Google Plus website had. It is now defunct, but earlier it was existing there. You must have heard about Google Plus. So informations about those users were leaked, and the users basically sued against Google, and the settlement was about $7.5 billion. So you can see how costly it could get for organizations if they do not maintain cybersecurity in the services that they provide. So it's essential that these glitches do not exist, and an ethical hacker will do exactly that. The ethical hacker will test the databases, will test the website and the services, and ensure that these exploits do not exist. So hiring ethical hackers can save millions, if not billions of dollars for these organizations. And these ethical hackers can keep businesses securely afloat with the user privacy of that particular service under complete lockdown. So how to get a job as an ethical hacker? Right now, we've discussed all the basic terminologies and what the entire backspace is, the background is for this particular profession. How to get a job? So the best way to go about it is getting a certification. So you may be extremely skilled, you may be an amateur, but the best way to get an ethical hacking job is to get an industry accepted certification, a certification that is endorsed and accepted by the majority of companies all around the world when they're hiring for this particular profession. So a certification will essentially ensure to your employer that you have already been tested as a candidate. So you've already done your homework, you already know about the profession, you already know how to do your job tasks. And that naturally decreases your training cost. The employer doesn't have to train you in anything particularly. And then you can essentially get your job easier and get a competitive edge over other candidates. So how to get a job as an ethical hacker? What certification should you go for? And certification that I would recommend to you is the Certified Ethical Hacker Certification. So what is this certification? Let us get into that. So essentially, the CEH certification, the short for Certified Ethical Hacker, is an industry accepted accolade by the EC Council. Now, the EC Council is an organization which issues these certifications. So similar to the CEH certifications, it issues other certifications as well. So by demonstrating the knowledge of hacking skills to access or assess security and vulnerabilities in a target system, in a lawful and legitimate manner. So definitely you're getting a certification for ethical hacking. So you obviously have to be lawful. You cannot be a gray hat hacker in order to get this certification and get a job in it. You need to be legal and legitimate in your ways. So once you've gotten the certification, what does it certify? What can the employer be assured about, right? So the employer can be sure that the candidate knows how to approach the target with a mindset of a skilled hacker, right? So it's important whenever you're penetration testing or testing the flaws of a system that you know the best ways to hack into a system, right? Because a hacker will use the maximum means possible to him in order to get into a system. So you need to be one step ahead of the hacker in order to hack your system first and know how the hacker can hack into your system and not let it happen in the first place. The candidate knows how to detect vulnerabilities. The candidate should be proficient at utilizing all of the hacking related tools in the exam syllabus. So the syllabus for the CEH certification exam contains a bunch of tools, and you need to be proficient at them in order to pass the certification, and you need to be proficient at them in order to get a good job in this particular cybersecurity domain. So let's continue now. Let us talk about the exam itself. Because we are on the road to become a certified ethical hacker. So what should we know about this exam that we have to pass in order to get this certification? So let us look at the exam details straight from ecouncil.org. So CEH is an MCQ exam. It contains 125 questions. The test duration for this particular exam is 4 hours, and the test delivery method is online. The exam prefix, you can see the code is 312-50 and 312-50 for view. So these are two platforms where you can give this test essentially. And the passing score differs from time to time. So depending on the cutoff for that particular year, your passing score can vary, but it's right around 60 to 80%, somewhere in that corner. And it depends on the cutoff. So this is directly from the website itself. You can look more about it on the website. So what are the skills required in general in order to pass this exam? What is the background that is required? So you need to know about your operating systems because operating systems are installed on virtually every smart device like laptops, mobile phones, your smart TVs and everything. These are all running on operating systems, whether it is Windows or Linux or Mac or iOS or Android. So you need to be able to navigate your way around the command lines of these particular operating systems really well. Then you need to have networking knowledge because hacking often alludes to hacking devices inside the network. So you need to have your network terminologies clear and how data packets are delivered within the network in order to exploit it. So networking knowledge is very important as a prerequisite for this particular exam and profession. Then you have hacking knowledge. So all of the things that we discussed earlier on, you need to be proficient and well versed with the linguistics related to these particular hacks, and gaining and maintaining access. So essentially getting into your target system and ensuring that you have access to that target system for a continuous period by installing a backdoor onto that system. Then wiping traces. So as a hacker, you need to be able to make sure that whatever traces you have that you've ever accessed this particular system are not there when there is an investigation or something. Otherwise, you will be caught, right? So you need to ensure that there are no traces of you in that particular system. And then cryptography and password cracking. So you need to be well aware about cryptography methods in order to execute man-in-the-middle attacks, password brute forces, basically create an algorithm in order to decrypt passwords or messages itself. Code of ethics. Now, this is the aspect of ethical hacking, and that is the paramount aspect because it deals with ethics itself, right? As a hacker, as an ethical hacker, you cannot go about your profession without any rules. You have a certain bunch of rules, and everything that you do has to be documented and done in the right way. So that is the code of ethics. So you need to know all of the laws and policies and acts related to cybersecurity or cyber crimes in your particular region. And according to that, you have to execute your day-to-day tasks as a certified ethical hacker. And there is a section related to ethics in the CEH exam itself. So you need to be aware of these things in order to solve those questions. So next up, what about the advanced skills that are required for higher positions, right? So we discussed earlier on the basic skills that you need to be proficient in. Now the advanced skills that you need to be absolutely proficient in, like have extensive knowledge about, right? Those are operating systems, scripting. Now, scripting comes in when you're dealing with more advanced hacks, right? So for SQL injection, you definitely need to know SQL. For cross-site scripting, you need to know JavaScript. For operating system related hacks, you need to know your C language, and Python essentially is an all-rounder in this particular domain. So if you know Python, you can essentially execute a lot of good hacks as well. So scripting knowledge is a must when dealing with advanced or higher positions in this particular domain. And then networking knowledge. Definitely 100% networking knowledge is required. So let's talk about the weightage of the topics. So let's look at the different things that come in this exam. Firstly, you have your background. So the background accounts for 21.8%. So this is some background knowledge that is required. Analysis assessment, 12.7%. Then you have security, which is about 23.7%. Tools, systems, programs related to ethical hacking, 28.9%. Procedures and methodology, 8.8%. Regulation policy, 1.9%. Then you have ethics, which is about 2.2%. So let us look at all of these. So the topic that comes first is background. So you need to know your network and communication really well, the information security threats and attack vectors. So you need to know the pattern of attacks or the types of hacks that you're dealing with. So you need to know about all kinds of prevalent hacks really well and how they function.
Just a quick info, guys. Intellipaat provides CISSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Information security technologies, you need to know how your antivirus works, you need to know how your JavaScript blocker works, you need to know how your web browser detects whether a JavaScript code is malicious or not, whether a website is safe to access or not. You need to know about these things because these deal with information security. Then you have analysis and assessment. So information security assessment and analysis deals with whenever you're tasked with penetration testing a system, you need to assess all of the security vulnerabilities in that particular system. So that is related to assessment, and the processes that are required in order to assess this. All of this is basically comes under the assessment processes. Then you have security itself. So information security controls. So you need to know about the countermeasures against security attacks. Then there's information security attack detection. So in order to do that, you need to know if your system is under attack. So the methodologies that deal with detecting this particular attack is called information security attack detection. Then you have information security attack prevention. So measures that are put in place to deter information security attacks are called information security attack prevention. So an example for that would be a firewall. Then you have tools, systems, and programs. So these essentially deal with the specific tools that are used on a day-to-day basis in the cybersecurity domain in order to deter these attacks. So these deal with information security systems. So essentially, whatever security measures are built inside operating systems itself and other software components, information security programs. So within those operating systems, you can install some programs as well in order to basically protect your system or detect any attacks or viruses in your system. So an example for that would be Malwarebytes and information security tools. So these tools essentially provide you with a dashboard to monitor and maintain the security measures on your system. Then you have procedures and methodology. So now we deal with the more complex science and study of dealing with the different types of attacks that can happen, right? So there are procedures that are to be followed. These exact procedures can help us deter most of the attacks. So we have to study these procedures. And there's also assessing the software's feasibility itself. So say you have an antivirus software, which is an information security tool, essentially. You have that software. And you need to assess the feasibility of that software against modern hacks, right? So in that case, you will use these predefined methodologies in order to basically understand if the tool is usable or not for your particular organization. So what is regulation and policy? So as we discussed before, the code of ethics. So this regulation and policy essentially refers to that itself. You need to be aware about the information security laws, acts, and policies in whichever region you are, and for whichever region's organization you're working for. And then finally, ethics. So all of the laws, policies, and acts aside, there are ethics of your own as well. So you need to have that clear in your head, because sometimes, even if the law says one thing, your company might be doing something that is on the wrong and might be expecting you to assist them in their wrongdoings. So, despite being employed by the company, you are not supposed to do that as a certified ethical hacker. So, some things you should know for yourself as well, and these also are included as questions in your ethical hacking exam.
So we're going to be talking about data security now. Now, the branch of cybersecurity that deals with the protection of data in specific is called data security. Now, every application, every organization that is operating has a database, right? That may be for a website, that may be for a web application, a mobile application, a video game, a social media website, or just an organization to keep track of its employees, right? So everywhere there is a database that is situated that keeps track of all of that. So data security essentially deals with securing that data, right? So that is pretty common. And let us look at the use cases for what data security covers, right? So data security covers cloud data security. Now, a lot of databases, a lot of online services, ETL services, online processing services are situated in the cloud these days because nobody wants to buy hardware and store it in-house to basically have their servers and have their utilities in the office itself. A lot of people use cloud services like Amazon, Google Cloud, or Microsoft Azure, and it is very important for the data that is there in the cloud, whether it's in storage or it in a processing pipeline, to be secured. So that particular branch that deals with the data security in the cloud is cloud data security. So that is covered under data security. And then one of the most common ways of data security is definitely data encryption. So basically that means any file that is there, any message that you're sending, you can basically encrypt that message through the means of cryptography, have a key for it, and then send it to your recipient. And the recipient would use that key to decrypt it and see its original meaning. This is basically done so that anybody who actually is able to access your system, your storage, is not able to access the actual content of the data without the key or the password. So that is data encryption. Then we have hardware security. So hardwares also have vulnerabilities which hackers can use to exploit and get into the systems. So that should be secured as well. You should use hardware that is secure on a firmware level so that nobody is able to exploit it. Then we have a very critical aspect of security, which is password management. Now, it is very important that you keep a password that is very tough to crack, right? It does not have commonly used words. It has a combination of capital, small letters, numbers, special characters if possible. So that is how your password should look like. Because the more complex your password is, the harder it is to actually crack it due to hashing methodologies. Password management is incredibly critical. Then we have payment security. So payment security deals with the aspect of actually performing online transactions, which involve bank accounts or online money deposits, right? So you need to have measures that ensure the security of those payment methodologies from any external attackers. So say for instance, you're making a payment for a product you've bought online, so it should be incredibly secure as well because it is involving your bank account, and anybody else who is actually able to access that network shouldn't be able to see the credentials that you're using for your bank account, or the actual transaction workflow that is happening between the website or you and the bank. And then we have email and messaging security. So emails within organizations are incredibly confidential as well. Then we have mobile application security. So a lot of you have Android mobile phones, right? There are other options as well, like iOS for the iPhone. In Android specifically, since there is not a strong regulation policy of applications on the Play Store, it is very crucial for the user of the device to ensure that the applications that he is installing onto his mobile phone are safe in nature. They are not asking for any overreaching permissions. So he needs to ensure all of that. And specifically when you're installing the application and you're trying to run any feature of it, if the application is asking for permission to have read access or write access to the contents of your phone, be sure that that application actually needs it and can be trusted. So it's very important to be aware of the security threats and to implement security measures on your web browser as well. Be sure that you're using a trusted web browser like one of the common ones like Google Chrome or Opera or Firefox for that matter. Be sure that you're not actually installing any sort of malicious toolbar or any malicious extension onto your web browser because those could be really harmful. And be sure when you're going to a website, you're not clicking on random links that install some scripts onto your web browser because obviously web browsers are using JavaScript to run the dynamic elements of the website. So these are some of the most common ways of ensuring data security because obviously if you're working for an organization, it is very important to secure your data as well as your private information. So, moving on, let us talk about the need for data security from an enterprise standpoint, from an organizational standpoint, right? So, let's talk about an example. So, let's talk about the Google data leak that happened in 2018. So, essentially, what happened was the information of up to 500,000 users was exposed due to software glitches, and this gave third-party applications access to the private data of those users. While nothing of harm came from this, but it was still incredibly irresponsible on the part of Google. So this happened on the now defunct Google Plus service. And Google also had to pay $7.5 million as a settlement for the users that had filed a lawsuit against Google for the data leak, right? So it obviously cost them money. And we can talk about the big basket data breach if we are talking about the more recent ones. So this is an article from India Today. So basically, when you're shopping for any e-commerce organization like Flipkart, like Amazon, you're essentially entering your card details as well so that your future transactions do not require you to enter them again. So Big Basket is one of those websites. It is essentially used for grocery items to be delivered to your doorstep. So what happened was due to a data breach, the information of over 40 million users was leaked. Big Basket has now acknowledged this breach and has filed an active police complaint against the hackers. So these are some of the two large-scale examples of what can happen if there is no data security or inadequate data security in these large organizations. Now, let us talk about what is at stake here. So, say for instance, we're talking about Amazon, for example. So, Amazon must have a user database and must have a sales database where they record all of the transactions that happen on their website. Amazon also uses a server, and Amazon is also using a proprietary algorithm in their recommendation engine. So these are essentially four things that Amazon does not want any hacker to have access to. But what if a hacker gets access to all of these four things? It could lead to a monetary loss. So this monetary loss could come from the proprietary algorithm being leaked to the hacker, and then that hacker selling this proprietary algorithm to a third party, and that could basically mean that that third party could get into the e-commerce industry and perform as good as Amazon from a technological standpoint, causing Amazon to lose its market share because it is their proprietary algorithm. Secondly, it could also lead to a lawsuit, right? So that means if a lawsuit happens, Amazon would obviously take have to take responsibility for the data leak of the user, and then Amazon would have to pay a certain amount of money to settle that lawsuit. And overall, if any of this does happen and it becomes public knowledge, it could lead to public distrust. It could lead to investors not investing in the stocks of that company. It could lead to a lot of other things as well that isn't a good look for the company in general. So it is incredibly critical for any company to ensure data security because data is the most valuable commodity today and you need to protect it as at all costs. So moving on, let us talk about the measures that can be implemented for data security. So the first that we discussed earlier on is data encryption. Now, through cryptographic means, there are a lot of data encryption algorithms available for emails, for messages, for the data that is shared between the server and the user whenever the user is transacting with a particular web application. Then we have data masking. So data masking essentially happens on a static level. So that basically means that whenever you're entering your card details, whenever you enter the number of your card details, whenever it is stored in the database, it is actually masked in a way where any external entity cannot actually see the first digits of your card number. And then we have data erasure. So the data that is not required to be stored anywhere should absolutely be erased. So for instance, you have your CVV number on your card, on the back of it, the three-digit number. Now, this three-digit number essentially authenticates transactions from your account. Now, Amazon or any other e-commerce website, when you're trying to buy a product from that website, asks you for that number. And if you enter that number and that number gets stored in the website's database and the website's database gets breached, obviously your CVV number is also leaked, right? And then the attacker can use your card number and your CVV number to basically take money out of your account. So that sort of thing should never be stored. It should be a one-time use only. Whenever they take your CVV number, it should be used and then it should be erased. Then you have data resilience. So data resilience exists for the odd case of when an attacker attacks your database in such a way that your data is lost. So this could be through causing a hardware or software failure or by simply deleting the data. Now, data resilience is obviously ensured by ensuring backups of that data on other devices as well.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let's talk about endpoint security now. Now, as the name suggests, endpoints are basically entry points or end user devices. So these could be laptops, these could be tablets, these could be mobile phones, these could be servers, essentially anything that is existing as a node in the network of things or the internet of things, right? This could also be your smart TV, your smart air conditioner, your smart refrigerator, right? Anything that is connected to your Wi-Fi router or your network. So anything that ensures security on these endpoints is called endpoint security. So if we look at the definition, endpoint security or endpoint protection is an approach to the protection of computer networks that are remotely bridged to client devices. These connections could exist between laptops, tablets, mobile phones, Internet of Things devices, and other wireless devices. So let us look at how endpoint security is important. So say for instance, you have a home network of devices. You have a Wi-Fi router, you have a server, you have a smartphone, and you have a laptop that are present in the network that you have, right? So the reason that you need to ensure that your endpoints are secured is that if the attacker gets access to any single one of the components in your network, he can potentially get access to all of the devices that are present in your network. So that is the reason you need to secure the endpoints as well. Because these days everything exists on a network, and if something can get access to one node of your network, it can get access to multiple nodes on your network as well. So ways to implement endpoint security: educating and briefing personnel on cyber threats. So if you have a family, if you have employees in a business, you need to educate them on how to uh, ensure that they are not victims of cyber attacks or any sort of cyber threats, right? We're going to be discussing these cyber threats in the next slide, but right now let us understand the remaining ones as well. Next is antivirus with event logs. So on all of the endpoint devices that we have, we need to install security measures if we are especially connected to the internet for that matter. So these could be through the default antivirus that your operating systems come with if they are adequate for the time, or these could be through third-party antivirus softwares as well. Just make sure you go with the antivirus that is popular in nature and actually keeps its antivirus database updated with the recent times. Then we have network security. So in order to ensure that no harmful messages or packets are being sent within the network, it is very important to ensure network security as well. It is also important to ensure network security to monitor if any endpoints on the network security are unknown in origin or are not supposed to be in that network. So that is why network security is important, because once you ensure network security, it is very difficult for an attacker to get access to the devices that are present in the network. Then strong passwords. So definitely use a password that is incredibly strong in nature. And then secure device policies. So you need to ensure that the installations, the software installations happening on your devices are secured by device policies. So that basically means softwares of unknown origins or of origins which could potentially lead to a data breach or an endpoint breach by any means should not be installed and should not be given administrative privileges at any cost. So these are the ways to implement endpoint security. The introduction to cyber threats. So, what is the definition of cyber threats? Now that we understand examples of what cyber attacks and cyber leaks can be all about, cyber threats are defined as the dangers present in the digital world that can potentially take advantage of the security vulnerabilities present in the target system, network, application, or server and cause disruption, damage, or theft. Cyber threats have a very common place in today's digital world. Almost every application that you're using, almost every operating system that you're using has some vulnerabilities, right? So if you're not aware of these things, if you don't operate safely online, if you don't use the proper security measures, if you don't use the proper firewall, the antivirus that you need, you are very, very susceptible to these cyber threats, right? Because they are endless in nature. They are always being created on a daily basis. The antivirus databases are updating on a daily basis based on the new sorts of threats that are appearing in the market that can affect your systems. So let us now see how negatively these cyber threats can affect us if we are not careful about them. So firstly, the effect of cyber attacks. Firstly, we have as a business, if you're running a business and you're a victim to a cyber attack, these are the possible liabilities that you can face. So, firstly, litigation. Most of all, because you're protecting somebody's private data or you're working for an organization that has some privileged data, right? And you need to protect that in your databases, in your server, wherever you're protecting it. If somebody gets access to that data, the suing party, the party whose information has been leaked, can sue you essentially for the damages that they have faced because of that. Right? It could be in monetary value, it could be in reputation as well. And if it's in reputation, you lose your customer base or your clientele because of it. So, as a business, if you're not careful about cyber threats, you can face litigation, monetary losses because of those litigations, and monetary losses because of your clientele leaving you. And on a personal basis, as an individual, your privacy could be compromised. So that means if you're using social media and you're sharing some private messages, some privileged conversations, right? Your data could be compromised and that could cause you some harm. And other than that, if you're frequently using bank accounts online, if your information is leaked, if your session is hijacked, then what could happen is you could lose all your money as well. So these could be the negative impacts of cyber attacks on your day-to-day life. So let us look at the side. So let us look at the types of cyber threats that exist out there. So firstly, let us look at malware. Now this I'm sure a lot of you guys have heard about. So theoretically, malware is defined as any software intentionally designed to cause damage to a computer, server, client, or a computer network. The most common types of malware are Trojan. Now, Trojan is something that pretends to be like an innocent file, right? But it is actually a virus that is present on your computer. So if you by any chance try to execute it, what will happen is some negative things can start happening with your computer. Some files can start multiplying, some files can start deleting themselves automatically. Your folders could get encrypted. So essentially, anything that pretends to be like an innocent file but actually turns out to be malware is what a Trojan is. Trojans are hard to detect. So if your antivirus database is not up to date, you're very susceptible to Trojans. Adwares, on the other hand, are not as malicious as other malwares. So adware essentially is something like that installs on top of your web browser, that installs on your operating system, and basically promotes a software that you don't necessarily need, unwanted softwares, if we were to call it. So adwares are usually installed when you're tricked into downloading a software that you think is for some other purpose, but you're actually downloading a software that is for some other purpose. These usually happen when there is some negligence when you're installing something and you forgot to uncheck a tick mark which says it is going to install this particular software. So that is what adware is. And then we have spyware. Now spyware is a more dangerous sort of malware. So what this does is that it installs on top of the operating system that the target is using. Now this could be in the form of a key logger, which means that it is logging every keystroke that you're entering on your keyboard and is sending back that information to the attacker. Or it could be recording through your webcam. It could be logging all your web information, whatever which site you're going on and whatnot. So this is what a spyware is. And then finally, we have a more recent virus, so to speak, which is called the ransomware. Now, ransomware is something that if it is installed on top of your system, it'll essentially encrypt your file system, right? And encrypt all of your data with a password, with a passphrase, so to speak. And then after the encryption has happened, you'll get a message on your screen that if you want your data to be decrypted and you want the key phrase to decrypt it, kindly send X amount of money to this Bitcoin wallet or X amount of money to this particular bank account. So usually Bitcoin wallets are used because they are untraceable in nature. These sort of attackers do not use their actual bank accounts. So until you send them that money, you will not have access to your files present in your system. And even if you send them that money, you still have no guarantee whether you will get your access or not. So you can see the severity of these threats that can happen. So they could range from normal annoyances like adware to these superior viruses like spyware and ransomware, which could potentially cause you a lot of harm as well. And then we have phishing. Phishing is something that can cause you a lot of harm as well, although it is not that prevalent today, but it's still a very common threat that exists out there for websites with low security factors. So, for instance, phishing is the social engineering process of tricking the target into revealing their information. So, for instance, you create a clone of Facebook. So, facebook.com is the actual website. You create something like facebook.xyz. You send that link to your potential victim. So when the potential victim sees that facebook.xyz link, he clicks on it. He gets access to a website that looks identical to Facebook. So if the person is not fully aware of what he's doing, he might enter his actual login credentials in the login fields of that particular cloned website. So what will happen then? In that case, what will happen is you'll get access to his email account and his password in plain text format. So that means you'll get access to the email and password in the default format without any encryption, right? And then if you're smart enough, what your cloned website will do is that it'll actually redirect this individual to the actual website so that the person does not suspect anything. So the person will log into facebook.xyz and he'll log into his original account and he'll not suspect anything, but you'll have access from then on to his email ID and password. So if you want to log into that Facebook account anytime, you can do that as well. So this is what phishing is. It essentially depends on the person being dumb enough to basically uh, be fooled by a cloned website by not checking what the website is and what the name of the website, the URL of the website is. This is also very preventable these days with the use of two-factor authentication, where even if you enter the password correctly, it will still send an OTP to your mobile phone. So until you enter that OTP, you still cannot have access to the account that you're trying to get into. Cross-site scripting. Now, this is also one of the most common sorts of cyber threats that exist, and you must have encountered it as well. So, on good websites, on authentic websites, this does not happen. But if you're going into some shady website, right? So, what will happen is every website essentially will send some JavaScript code onto your web browser for execution if it has dynamic elements to it. So within those JavaScript code blocks, if somebody embeds some malicious code, right, that would also run on your web browser in order to render that website or to basically execute the functionality, the dynamic functionality of that website. So if your browser security is not good enough, what could happen is you could run some script on your web browser that could cause potential harm to your system. It might install some sort of a backdoor to your particular web browser where the attacker can have access to the information of whatever you're visiting or whatever you're typing on the web browser. So this is what cross-site scripting is. So never click on links that you don't know about. Never go to websites that are not secure. Don't click on a random download links, right? So that is the reason uh, your browser could get infected with cross-site scripting. It could also install adware onto your web browser, or it could do much worse activity as well on your web browser. Then there is denial of service. Now, denial of service is the process of overloading the target server with so many requests that the response time becomes unreasonable or the server crashes. So basically, in this attack, what happens is the attacker will send thousands and thousands of requests to a web page or a web server. And once those requests have been sent, if the server does not have the appropriate resources to deal with those many requests, the server overloads. And when the server overloads, it becomes extremely slow or it crashes. And because of that, no other user who's trying to access that website or server can access it, essentially denying them that service. And this sort of attack is called denial of service. So there are a lot of countermeasures to it. You can IP block that particular attacker, right? If the attacker is attacking from multiple IPs, there are other countermeasures for that as well. One of the countermeasures is using a service log like Cloudflare, right? So this is what denial of service is. And finally, we have man in the middle. So man in the middle refers to an attack where the hacker intercepts a message between the sender and the receiver and deciphers its meaning, right? So if you're a sender, you're sending an email to a recipient. If an intruder gets access to that email between you and the recipient, then the intruder has access to the privileged information that you were sending, and this is what a man-in-the-middle attack is. This usually refers to the attack of cryptography, where the intruder is also able to decrypt of the information that you're sending because emails are encrypted. These days, modern emails are encrypted. So if the intruder can decrypt your email by simply accessing the encrypted files in between the connection line of the sender and the recipient, it is called the man in the middle attack. So with those cyber threats out of the way, so firstly, we'll talk about the network security concepts that you need to know before we actually get to the tutorial part. So network security is quite a broad field of study, right? So we need to understand firstly what is a computer network, right? So we are protecting something, we need to understand what we are protecting. So a computer network essentially is a group of computers that use a set of common communication protocols over digital interconnections for the purpose of sharing resources located on or provided by the network nodes, right? So imagine you have a lot of computers in a particular office space together, right? You take LAN wires, you connect all of them to a server, right? So what will happen is essentially all of those computers can share their resources, can share data files, can share other things as well, such as processor resources, server resources, RAM, and whatnot, right? So when you connect all of them together, you're creating a network of computers. So that is called a computer network, right? And if the server has access to the internet, all of the computers will have access to the internet if configured properly. So now that we understand what a computer network is, we need to understand network security as well. So network security essentially is defined as the implementation of technologies, processes, and protocols designed to safeguard an individual's or organization's communication and information. So naturally, if you have a computer network, there is a possibility of the data being circulated around that network being leaked or some other interruption that happens within the network, and you need to prevent that, right? So you implement these protocols, these technologies, which come under network security, right? So this is an entire field that deals with this particular issue. So there are types of network security. So firstly, there's network access control, or the NAC. So, network access controls is exactly what it is named. It's basically to prevent other users from getting into the network who don't have the proper certificates or policies, right? So, if your network has a policy for not allowing strangers to basically visit your network without the proper authority, so you're implementing network access control. It is used to implement endpoint security on the nodes of the network. Then we have antivirus and anti-malware softwares. So if you're running a computer network, naturally malwares, trojans, and worms are a threat to your network as well, because they can basically expose your network to outsiders, to intruders, to attackers, right? So you want technologies that can prevent that. So these particular softwares would prevent that. You can basically create your own computer network and deploy this software on all of the nodes that are present on your network, and you can effectively stop the spread of viruses or the spread of malwares through that means. Then we have firewall protection. Now, firewall protection basically means that your computer basically deals with two network activities. The first is outbound activity, the second is inbound activity. So basically, that means that your computer has a particular number of ports that are open for application interactions with the internet, with the network, with the rest of the network. You can go ahead and basically uh, create some rules that restrict your private network or restrict you from basically being exposed to the public network as well, from mostly where you're concerned is inbound activity. So basically any external network, any external server, any external website or application that tries to ping your network, ping your particular node, and try to get some information out of your particular node, or try to install something onto your particular node, if your inbound rules of your firewall do not allow anything other than the particular things that you actually allow, your firewall will effectively stop that. So that is what the firewall essentially does. It also does the same for outbound activity. So basically, if you're restricting your employees from basically accessing anything outside of their office work, or your school students from accessing anything outside of their study material, you can impose that onto the firewall as well. Then we have virtual private networks. Now, virtual private networks essentially help people to hide their original identity on a network. So basically means that they tunnel in a network and basically come through different nodes, attached to different nodes, and basically mask their original IP and their original MAC address and get access to the network without actually having to reveal any information about them. This also ensures a end-to-end encrypted setup. So that means that anybody trying to access the information being shared to and fro outside of a VPN tunnel cannot actually access it. So, what is the need for network security? So, the need for network security is quite prominent. So, if you're a sender and you have a message that you want to send to your receiver, right, the recipient, and you're sending that message through email, so naturally, your first course of action would be to simply send the email. This is what you think the email diagram looks like. You simply send it to the recipient, but there's a problem. If there's an intruder and your network is basically compromised, if somebody else has access to that network, right, and they can basically track your email, so they would get the email as well. Now, if this email contains sensitive company relevant information, this could be extremely harmful for your organization, so you don't want that. So your intruder is able to read your data. You do not want that. So this liability could be small. It could not mean anything if somebody else gets access to the data, or it could be really huge as well, right? So this could lead to monetary losses if the competitor company gets access to your sales information, your customer information, your strategies. It could lead to monetary losses. If somebody basically files a case on you for basically allowing their data to be leaked to the public or to the hacker, the court can also a court can also rule against you in that regard, and then you'll have to pay damages in monetary revenue. So that could also lead to loss, and at the end of the day, it leads to employee and customer dissatisfaction and distrust in your organization if your organization does not have network security and intruders and hackers are able to get the data. Right. So all of this is something that you entirely don't want, and that is why you need network security almost certainly. So what you'll do is you'll basically lock your line of connection between the sender and recipient so that intruders cannot access it. So this lock, essentially this metaphorical lock, is what network security is. So let's talk about the CIA principles. This is not to be confused with the intelligence agency. These CIA principles basically means confidentiality. That means secrecy. So the data that is being transferred to and fro, or the data that is being contained on the network, should remain confidential if needed, right? So that is the first principle of network security. The second is integrity. So the data should be whole. The data shouldn't be less than what it was, and it shouldn't be more than what it was. The data should be exactly identical to the original data that was there. Nobody should have been able to manipulate it. The data should not have been lost. To verify this, we use checksums. To verify this, we use a lot of other methods as well to check the sender, to check the basically the contents of the file, whether they are the same or not. So this is integrity. And finally, we have availability. So the data that has to be accessed should be available to the intended recipients at all times at a very short notice. So this data obviously needs to be accessed by the relevant people for the organization or the business to continue. So the data should be available as well. So aside from confidentiality and integrity, you cannot keep this data stored away securely forever. You need the data to be available as well on demand. Next up, we have network security application layer. So there are layers involved in the TCP/IP model of network security. So the relevant layers would include firstly the application layer. Now this is the topmost layer of any network layer model basically. So application layers basically means where you're interacting with the computer with the application. So that is the application layer, right? So application layer is an abstraction layer that specifies the shared communications protocols and interface methods used by hosts in a communications network. So application layer refers to the endpoint data, right? So the endpoint data should be secured when it reaches the other end of anybody's node, essentially. So if any attacker or intruder gets access to the data, he should not be able to access that data. The application layer security measures deal with exactly that. So firstly, we'll see an example which is called pretty good privacy. Now, pretty good privacy is the de facto email security utility used today. So even in today's emails, it was discovered in 1991. Even in today's emails, we still use this PGP protocol, right? It is used to encrypt sensitive emails and sensitive files if files are attached in that email. So this basically means that you have a public key and a private key. So the recipient basically generates the public and private key. So what will happen is the recipient will send the public key to the sender. The sender will encrypt the file that he's supposed to send with that public key and then send it to the recipient. And the recipient will use their own private key that they generated to decrypt this particular email. Now, the private key is only housed by the recipient. The sender does not have access to it. Nobody else has access to the private key. If the public key leaks, it does not matter because the private key is needed to decipher the message that has been sent. So then the recipient will decipher the message and then the recipient will have access to the actual intended message. So this is how PGP works. It can work on symmetric security measures as well, but this was an example of an asymmetric email authentication system.
Just a quick info, guys. Intellipaat provides CISSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Next up, we have the network security transport layer. Now, transport layer is the second layer effectively in the diagram. So the transport layer is responsible for error-free end-to-end delivery of data from the source to the destination host. So this basically means the transport layer primarily deals with data integrity because it wants the data to be error-free, right? It's not particularly responsible for the security aspect of things, but it wants the second principle of the CIA principles called integrity, right? So that is what the transport layer essentially deals with. So let us see one of the examples of the transport layer called the secure socket layer.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So secure socket layer is now transformed into the transport layered security, which is the successor to the SSL protocol essentially. So the TLS is used today. So TLS is a cryptographic protocol designed to provide communication security over a network. So it basically tells you that the website has integrity. So any web server that you're trying to access, any web application that you're trying to access over the internet, essentially will have an SSL security certificate. If they don't have that certificate, your web browser will automatically tell you that this website is not secure and it is not recommended to proceed forward. I'm sure you must have seen that whenever you try to log into a website, some website you might come across once that has this message on Google Chrome, which says that the connection is not private because it does not have an SSL security certificate, right? So TLS is essentially that cryptographic protocol that ensures that the website has SSL certificate, right? So this is this is used to provide communication security over a network. So let us look at the diagrammatic representation of this. So the client, which means you, who is trying to access the website will send a hello message, right? The server will send a hello message and then the server will then send the certificate to your web browser, the SSL certificate that it has. Your web browser will then authenticate that certificate essentially by checking in the database if the certificate actually exists. Is it genuine? When the certificate has been authenticated, the server hello has been done. The client will then provide the key exchange to create an end-to-end encrypted transmission between the client and the website in question, right? So the client will essentially start the key exchange process. The key generation will happen on the client's end as well as the website's end. And once the keys have been exchanged, the cipher exchange has been finished on both ends, then the secure protocol has been established, because all messages, all security communications from then on will be encrypted and they will not be decipherable by any outside attacker or intruder. So essentially all the interactions that you have from within the website are encrypted in nature and nobody else can have access to it, unless of course your ISP is tracking you, unless of course your employers are tracking you. That is a different case because they are tracking you from the client's end, they're not tracking you from the website's end. So let's look at a network layer, the last layer in this particular tutorial. So the network layer essentially deals, in the TCP IP model at least, the network layer deals with the combination of the physical layer and the data link layer of the OSI model. Now here, the physical layer refers to the actual physical connection between your host and the recipient host. That is the actual physical connection. And the data link layer essentially refers to the data synchronization layer, where it is ensured that the data that you're sending is actually sent to the receptive layer in the receptive host or the receptive node in a particular order, right? So both of those functionalities have been combined in the TCP IP model, and it is called the network layer. So it is responsible for mapping IPs into physical addresses. So in a particular network, you have your IP addresses, your local IP addresses, and then you have the MAC addresses, which are also called the physical addresses, right? So in any particular network, once the pinging has been done, once the network has been mapped up, right? So the IPs are mapped to their devices' respective MAC addresses, right? So whenever you're trying to send a packet over a network, the network layer ensures that the IPs are mapped to their appropriate physical addresses. So they're sent to the correct physical address when they're sent. Next up, they are mainly responsible for transmitting data between two devices on the same network by encapsulating IP datagrams into frames. So each layer as we go lower in the network diagram, each layer adds a little something to the packet that is being sent. So the application layer will deal with the most minimum amount of information. That information is then wrapped up in the transport layer, and then it is wrapped up further in the network layer into datagrams, essentially. So the datagrams are wrapped up into frames essentially when they reach the network layer. So this is what happens. Now these frames can be sent over the physical layer, the physical connection between these two particular nodes that are transferring data to and fro. So lastly, we will deal with IP security with IPsec. So this is a example. This is an example of the transport layer protocol applications. This is called IPsec. Now, in computing internet protocol security, IPsec is a secure network protocol suite that authenticates the and encrypts the packets of data to provide secure encrypted communication between two computers over a internet protocol network. It is also used in virtual private networks as well, the VPN, and it is used to encrypt application layer data. So whatever application layer data is being sent to the transport layer, it is used to encrypt that. It is used for router security as well. So you have a lot of routers and switches present within your network to properly route the communications. It is used to maintain router security as well by the applying the protocols that it has. And then it is used for authentication purposes. So it adds authentication clauses to your particular datagram. And when it reaches the recipient checks those authentication clauses to verify whether this particular packet is being sent from the right person or not. and then virtual private networks through IPsec tunneling. So IPsec also provides tunneling in order for you to create virtual private networks and the tunnels that are required to initiate them. And encapsulating security payload ESP is one of the components of IP security. So it provides data encryption, data integrity, authentication, and anti-replay. It also provides authentication for payload. So that means that data integrity is ensured with the help of IPsec, which means data that is sent is maintained in its original format. Encryption is an optional feature. You can also implement encryption when you're dealing with encapsulating security payload, the ESP part of IP security. Authentication, which means that if you're the intended recipient, then only you can open up the message. You cannot open the message otherwise. And it is also used to ensure that the message that is being sent from the right person. And anti-replay, so that means that the message once seen gets automatically deleted. Right, so this is also implemented in Telegram if you're aware of that particular application. So once the message has been seen, it gets automatically deleted so that that message cannot be shared further, and the intended recipient can see it, and then the message is done. Nobody else can see that message. It also provides authentication for payload. So whatever the contents of the message is, that is also authenticated, whether that is correct or not. Authentication header. Now, this is the second part of IP security. It's also abbreviated as AH. It also provides data integrity, authentication, and anti-replay, and it does not provide encryption, right? So if you don't want to implement encryption in your particular message, then you can go with the authentication header method. The anti-replay protection protects against unauthorized transmission of packets. It does not protect data confidentiality. So that means that since this particular protocol does not implement encryption, it cannot ensure data confidentiality. So these are the two aspects of IP security, IP security. So we have reached the part where we're going to be implementing the Nmap demo of network security. Let us understand what Nmap is first. So Nmap is an open source and free utility for discovering network elements and security auditing, compatible with all major operating systems like Windows, Mac OS, and Linux. So essentially, you can use Nmap to understand the topology of your network, how many devices are connected, if there are any strange devices that are connected. If you're a hacker, if you're an ethical hacker or an hacker, you can use it to discover hosts on the target network as well. So that is the function of the Nmap application, right? So we'll look into that as we move and proceed with the tutorial. So currently I have my Nmap GUI open. So firstly, we're going to understand how we can detect all of the ports, all of the services that might be open, or to confirm whether a particular host exists on a network or not. So firstly, I'll ping a particular IP, which is of the Windows Server 2016. So I'll ping this IP by typing the IP address in the local network, and I'll write the nmap command that I want. So in this particular case, I'll write SN and capital PU, right? And then I'll put in the IP address again. I think I have to put it over here again and then put it over there, right? So when I click on scan, it'll first check whether the host is there or not. And then as we can see, it also says after scanning the network whether the host is up or not. And we can see that it is up, right? So next up, we can do something else with it. We can convert this particular into an ICMP echo ping scan. So by doing PE instead of PU, we can initiate that as well. So 10.10.10.16. We type that and we click on scan. So it does that. And this is another way to basically detect if any particular host with a particular IP address of that sort exists or not. We can also see the MAC address for this particular IP address. Then the next thing that we can do is if we want to detect all of the IP addresses that are present within a particular range on a network, we can simply type the starting parameter of the range and then give a dash, and then we can type the end parameter of the range and click on scan. So when we do that, we can see all of the hosts that are present within that range. So if any intruder exists within that range in our particular network, we will be able to spot that particular intruder. So we can see that Nmap will help us with network security with the various options and commands that it has, especially when we are trying to track down if any particular suspicious activity is present on the network or not, if any suspicious host is present on the network or not, or if there are any security vulnerabilities on the system. So if any of those exist, we can simply see it over here in the Nmap application and go fix them so that they don't exist anymore. So this was it for the Nmap tutorial. We can see how well we can provide network security with the help of Nmap. There are a lot of other applications as well that lie in the cybersecurity domain to help us with network security, such as Wireshark and NetScan as examples, right? So if you go ahead with the cybersecurity course or any course with that matter, you'll be introduced to these applications as well and see how they implement network security on a network and how they can be used for ethical hacking as well and preventing hacking as well. Introduction to cryptography. So, firstly, let us understand what the term cryptography actually means. So, cryptography is theoretically defined as the study of the various processes which are implemented to protect information and communications through the use of mathematical concepts and rule-based calculations. So, essentially, you have data. So, this data could be a static message that you're trying to send to somebody. This data could also be a communication bit that you're actually trying to send to someone in a streaming format, right? So what will happen is if you want to protect that data, you pass it through some mathematical operations or rule-based calculations, and then that data becomes protected, right? So essentially, if somebody else were trying to actually access that data, they couldn't. Right, so this is what cryptography is. It is the study of these processes that help achieve this. Now, the question comes up, why can't we simply send data to our desired recipient without actually having to implement this? So, let us understand that as well. So, why do we need cryptography in the first place? So, imagine that you're the sender of the message, you're the originator of the message, and you have a message, you have a data file, right? So the blue icon over there represents the data file, and there is a recipient, right? So you're sending this data to the recipient via the use of email, say for example, right? So you send that to your recipient. This is what happens if the message goes normally and nothing bad happens at all, right? But there's an off chance that there is an intruder that has access to the actual connection between you and the recipient, right? And your email line is essentially not secure, right? So this could be in the case when you're trying to send data over a local area network, right? And the local area network is compromised to give the intruder the access to all of the traffic that is present in that network, right? So you send this data file, it goes to the recipient, but it also goes to the intruder. Or worse, what could happen is it could go to the intruder first, the intruder could make some adjustments to it, and then it could go to the recipient, right? Either way, this is not something you want, right? So how do you fix that? The intruder is able to read your data. uh, we need some method to make this data unreadable by the intruder. So this data that the intruder also gets access to, even though he has access to the email line, we need to do something with this file that makes it unreadable by the intruder. So we do this with encryption. So what is encryption exactly? Encryption or enciphering is a cryptographic process where we convert plain text, which means the text that we directly enter onto our keyboards or raw data, to unintelligible information or cipher. Right, so unintelligible information means random gibberish, or so it appears to somebody who looks at it from a third person's perspective, random data essentially, by processing the data with an algorithm, right? So you're the sender, right? And you have some data in the plain text format, right? What will happen is you'll convert that plain text data into a cipher by passing it through an algorithm or some sort of a processing framework, right? And once you've done that, you pass that cipher on to the recipient, right? So even if the intruder gets the access uh, between you and the recipient, the person will not be able to understand the original meaning of the message because it has been converted into something else. It has been converted into unintelligible information. And so, what is decryption essentially? Decryption or deciphering is a cryptographic process of converting the plain text, converting the cipher back into the plain text by processing the data with an algorithm. So once the cipher reaches the recipient over the email line, now the recipient needs to actually get the actual information that you're trying to send them, right? So they need to convert that cipher that you've sent them back to plain text. So this process is essentially called decryption or deciphering, right? So let us continue. There is another term that we need to familiarize ourselves with, which is quite prominent today. It's called cryptanalysis, right? So, cryptanalysis is the study of deciphering ciphers without knowledge of the encryption technique. So, earlier on, traditionally, decryption is done when the recipient's end knows how to actually decipher the cipher, right? They have a key or something, they have the algorithm to reverse engineer the cipher back into the plain text, right? So, cryptanalysis, on the other hand, is the study of deciphering ciphers when you don't have any prior knowledge of the encryption technique. So, you don't have any keys, you don't know the encryption technique, you don't know the reverse algorithm. So, cryptanalysis is the study when you try to convert ciphers by just looking at them and converting them back into plain text, right? So, that is called cryptanalysis. A cryptanalysis is what a hacker will do if he's trying to actually get information out of the cipher that he has access to. So there are some security goals that are involved in the process of cryptography. So we just go over them one by one. Confidentiality. So the first principle and the foremost principle, as we all can understand by now, is when you try to send data over an unsecure or secure line for that matter, and that data is only expected to be read by a particular amount of recipients or a particular recipient, you need to maintain confidentiality or secrecy with that, right? So in larger companies where data is sensitive, right, and data cannot be read by other people, data cannot be accessed by other people, or it could cause a massive blunder, right? So in that case, you need to absolutely protect the confidentiality of the data. So cryptography is the study that helps us deal with that. It helps us protect the confidentiality of the data. So the first principle that we actually deal with when we are implementing cryptography is confidentiality. The second is integrity. Now, integrity means that the data should have its original meaning, should have its original structure when it reaches the recipient. So if you write something in the beginning, right, and you convert it into cipher, when you send the cipher over to the recipient and the recipient deciphers it, converts it back into plain text, the plain text should represent exactly what the sender sent in the first place. So the data should have maintained its integrity. It should be whole, right? It should not have been manipulated by any attacker in between, or there should not have been any loss of the data in the encryption process itself. So this is another goal of cryptography, to maintain integrity in the data. And lastly, one of the other most important things is availability. Now, availability means that the people who require that data should have it basically instantly, right? They should not have any delay with getting that data. Nobody should be able to interrupt the process of them getting that data, right? So this particular aspect is called availability, which also means that the encryption techniques that we're using, the encryption and decryption techniques that we're using, should be fast in nature. So when it reaches the recipient should be able to decrypt that data fast, because time is extremely valuable, and the recipient cannot sit and decrypt that data for 1 to 2 hours. It should be decrypted in minutes if that is ideal, with the algorithms that are present to the recipient. Right. So these are the three security goals that we deal with when we're dealing with cryptography. So there are categories involved in cryptography essentially. So other than the examples that we're going to discuss after this, cryptography has been divided into particular categories. So let us look at that. So the fundamental categories are private key cryptography. Now, private key cryptography is also called symmetric key cryptography. It uses a single common key on the receiving and the sending end, right? So as a sender and the receiver, you use one key to encrypt and then use the same key to decrypt that data, right? So you're the sender, you have access to a key. Now this key is not shared with anybody at all except the recipients or the intended recipients, right? So this key is present to with the recipient. You have the data with yourself. You encrypt that data using that key, and you convert it into the cipher, and then you send that over to the recipient. Now the recipient has the cipher. The recipient will use the same exact key. Now this key is a private key. It has not been shared with anybody to decrypt that data, and that data is converted back into plain text. So even if an intruder accesses that cipher in between, since the intruder does not have access to this key, he will not be able to decrypt that data. Now this is called private key cryptography or symmetric key cryptography. Only one key is involved in the entire process. Now, on the other hand, we have public key cryptography. Now, public key cryptography is also called asymmetric key cryptography. Now, this exactly means that there are two keys that are involved. So, one is a publicly available key. Now, this key could be available to the intended recipients and senders, right? Or this key could be available to the world as well. It does not matter, right? So even if the public key is available to a lot of people who are not supposed to have that, it does not matter at all. So what happens is, in this particular case, the data is encrypted with this public key that may be available to a lot of people who are not supposed to have access to the data, right? With this public key, the only thing that you can do is encrypt this data, right? You cannot actually decrypt this data with the public key. You can only encrypt this data with that public key, right? So you basically go ahead and convert that data into cipher using that public key. You send that cipher over to the intended recipient. Now, the intended recipient has a private key. Now, the private key is only accessed by the intended recipients. Nobody else has access to the private keys. Everybody has access to the public keys. Nobody has access to the private keys. Now, what the recipient can do is decrypt that data with the private key and convert it back into the intended data or the plain text, right? So, the advantage of this is you don't have to keep access, you don't have to keep the public key secret at all. And even if the public key is available to everybody, uh, nobody can do anything with it. If an intruder gets access to the cipher in between the line of communication, he cannot use the public key to decrypt that data because the public key has been used to encrypt that data, and the data is meant to be decrypted only by the intended private key, right? So this uses a non-secretive public key for encryption and a secret private key for decryption. Now there are comparison points between the two. So public key encryption and private key encryption, the differences. Firstly, in private key, obviously single key required. In public key, there are two keys that are required. In private key, size of the ciphertext is less than equal to the plain text. In public key, the size of the ciphertext is greater than equal to plain text. Private key cryptography has fast encryption, less resources. So with only a single key, you don't have to worry about a lot of processing power. Essentially, what happens is you can encrypt and decrypt your data extremely fast and use less computational resources, while in public key, there is slow encryption and the usage of high resources. Private key is generally used for large data because of the fast nature of the encryption and decryption processes. So if you have a large data, you will generally go with a symmetric key cryptography method. And for small data, you will go with public key cryptography methods. Now, there is confidentiality, which is absolutely maintained in private key cryptography, but with public key cryptography, although slow, you get confidentiality, authenticity, and non-repudiation. So in public key cryptography, the data has confidentiality, which means that the data is secretive in nature and will only be revealed to the intended parties. The data has authenticity, which means that it can be verifiable where this data came from. It cannot be coming from an attacker or an intruder. We verify that with means, and there is non-repudiation, which means that the receiving end cannot deny that the data is authentic and has integrity. So there are ways to check integrity of the data, like checksum and other methodologies. With the help of that, the receiving end cannot deny that the data is authentic.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So examples of these in private key cryptography, we have 3DES, AES, DES, and RC4 algorithms. In public key cryptography, we have Diffie-Hellman, ECC, EI, Gamal, DSA, and RSA. There are also hash functions. So hash functions are pretty straightforward. I think the easiest to understand out of all of these algorithms. Functions that convert plain text into encrypted text are called hash functions. So essentially mathematical functions. So if you're aware of this, this is what it looks like. You have a function. Within that function, you pass in a variable called plain text, right? So this is your input, and then you get the output, which is the cipher, right? So functions work in exactly the same way as a lot of the other algorithms would work, except you have a lot of flexibility attached to them. You can essentially create any sort of function that you require for your particular use case. Let us look at the examples of cryptography now. So if we move on ahead and look at the easiest and the first example, so this is a sort of a substitution algorithm that we use for encryption and decryption. It's called Caesar cipher, right? So imagine you have the entire alphabetical list available to you from ABC to XYZ. You have all of these letters available to you, right? and say your message is fun. Now, this is the word that you're trying to send to your intended recipient, right? But you can't send that directly. You need to encrypt it, right? So let us take a value n. N is equal to 3. Now, this could be anything. N could be anything at all. It does not really matter what n is. It is up to the encryption algorithm or the encryptor to decide what the value of n will be. Now, this is the only value that is required to be known by the recipient, the value of n. So imagine the letters that come three sides or the value of n to the right. So with F, we have 1, 2, 3, we have G, H, I. So for F, we have I. For N, we have Q. And for U, we have X. So you can also see in the alphabetical list, the letters have been marked with green, which are present three positions to the right of the intended letters. So what will happen is we essentially convert it to that. So for F, we get I. For U, we get X. And for N, we get Q, right? So this is what happens when we use the value of 3 to encrypt our sentence or word with Caesar cipher, right? So our final encrypted text is IXQ. So by shifting the position of each alphabet forward by 3, we are able to hide the original meaning of the word, right? This is called a substitution algorithm because we are essentially substituting the original letters, right? So F has been substituted by I, U by X, and N by Q, right? So this is one of the first and simple algorithms for cryptography, but it gets you going with the idea. Now, next up, we have another category and type of cryptography. An example would be the rail fence cipher, which is a transposition technique. Now, this is an interesting technique as well. Say you have a sentence that you want to encrypt before sending to your recipient. It's called hello from Intellipaat, right? And what you'll do now is you'll imagine you have two rail fences. Now you can implement this using programming languages, but I'll give you the basic rundown of how the algorithm works visually. You have two rail fences, similar to the boundaries that you have on your home. That is why it's called a rail fence, right? And what you'll do now is simply start writing the letters alternatively on these rail fences. So firstly, you have H, right? So H has been highlighted in the sentence and H has been put on the first rail fence. Then the next letter is E. So alternatively, you'll put this on the bottom rail fence. Now, we are using two rail fences right now. You can use as many as you want, but it's generally preferred that you go with 1/4 the size of the actual string that you have, so that there is actual implementation of the rail fence cipher instead of you actually making as many rail fences as there are letters in your sentence. Then what you'll do is write E on the bottom rail fence, and similar to that, you'll alternate to the top rail fence once again and write L, right? So on and so forth. You'll fill it in a similar fashion. So it'll look something like this, right? So what you will do now is you will take the entire string that is present in the first rail fence, and then you'll append it to the string present in the second rail fence. And if you had multiple rail fences after that, you would have done the same thing with the consecutive rail fences as well. So now the final text will look something like this. It looks kind of like gibberish. Now, one thing you might be noticing is I haven't actually implemented the white spaces, so that is only for non-confusion purposes. You can implement spaces, but since we wouldn't have been able to see spaces over here to avoid any sort of complexity, I removed them. But you can definitely implement spaces as well when you're dealing with programming languages, right? So the final ciphertext will look something like this, right? And this particular algorithm is called a transposition technique because you're not exactly substituting anything over here. The letters are the same as in the original string, but they just have been jumbled up, right? So this is since the position of the letters have been changed, this is called a transpositional technique. The original letters have not been changed, only the positions have been changed. So this is what a rail fence cipher is. The only thing that your intended recipient is supposed to know in this case is the number of rail fences, right? And in the previous algorithm, which we were discussing, which was the Caesar cipher, the only thing that the recipient needed to know was the value of n, right? As to how many letters you're shifting to the right or to the left. That is only required to be known by the recipient. So these particular techniques, the rail fence cipher and the Caesar cipher, are extremely weak techniques. With today's computational technology, they can be broken almost instantly. So these are not ciphers that are used in today's environment, although we use other ciphers. So let us look at one of the ciphers that we can actually use. In this case, this entire process is called steganography, and we'll look at an example of that. Firstly, let us understand what this actually means. Steganography is the technique of hiding secret data within ordinary innocent looking files and messages, right? So what happens is you have your data, right? And the way you will hide this particular data is you'll simply embed it within an image, right? So whenever somebody looks at the image file, they will not see the presence of any data. They will not even see a trace of the presence of any data unless they have the required tool required to decrypt that data from within that image, right? So this entire process is called steganography. This can be useful if you're trying to hide information on your computer system, or if you're trying to hide information within an email. So say there is something that has been talked about between you and the recipient on the phone. You both have the same steganography tool, right? And then you decide to send an ordinary image file over the email to your intended recipient, right? So even if somebody is able to access that mail in between the line of communication, they will just look at an image and they will think, okay, it's an innocent file. There's nothing to worry about over here, right? So this is the entire point of steganography. So let us look at how this works. So we're using a steganography tool. Now this tool, the only people who would have this tool are the senders and then the recipients, right? So this is a tool which essentially helps you hide or encrypt some data behind image files, right? So if any normal person tries to access that image, they will only see the image, while the people who have this tool can actually see the hidden message behind that image, right? So the first thing, obviously, that we would do is actually select an innocent image where we can hide that data. So we have this image over here. This is a royalty-free image that I have selected. So I'll click on that and click on open. Now this image loads up in the application. It's a simple highway sort of image, right? And within this area over here, I'll simply write hello from Intellipaat. Now, this is the intended message. Now, this is the secret message that I'm actually trying to send to my recipients. Now, next thing I will do is click on hide text, right? Now we can see it says the text message is now hidden in the image. Now this application is called Quickstego. You can check it out online as well. It's a free to use application, right? And then we'll click on save image. Now we'll click on save, right? And we'll click on something like encrypted image. We click on save, then we click on exit, right? So the next thing I would do is open up the application again and then click on this open image, right? We find the encrypted image option, click on that, and we can see that there is a hidden message attached to it, right? So this is what we essentially get. We are distributing this application to the intended recipients. They use this application to scan through the image and they see our hidden message, while nobody who does not know about this particular case, that the image is not innocent in nature, will be able to see that message. So this is how image steganography works. So now that we understand steganography in action, let us look at another algorithm. Now this is called the one-time pad, right, or the Vernam cipher. Now the important thing to know about this particular example is that this is an unbreakable sort of algorithm. Like you generate a one-time sort of key that is uniquely generated for every instance of a new data transfer that you're trying to do, or a new communication instance. And it's called one time pad because it's only valid once. So it's sort of similar to the OTP that you have, like that you get in your mobile phones when you're trying to log into particular websites, or you're trying to confirm payments. So it's sort of on the same principle, that you get a one time key that you can enter, which actually helps you go through with your particular transaction, verify your transaction, to so to speak. So say you have a word hello, right? Now hello can be converted into their respective letters can be converted into their respective positions on the alphabet. So this is how it would look like if you convert them with respect to the positions they have on the alphabet. So the H is on the 8th position, 5 E on the 5th position. You have two L's, 12, 12, and 15 for the O, right? So you have converted it into that. Now the next thing that you would do, you would generate a random 5 letter key. So it depends on the length of your string. So if you say, if you have a 5 letter, 5 character plain text, you will use a 5 letter key essentially. Now this BXLKD and small can be anything. The only restriction that you need to have over here is that it needs to be of 5 characters, right?
Just a quick info, guys. Intellipaat provides CISSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
So once you've created your randomly generated 5 character key, you will then do the same thing for the key as well. So B is on the second position, X on 24th, L on 12th, K on 11th, so on and so forth. And the next thing that you would do is actually add these two particular numbers, right? So the 8 will be added to 2, 5 with 24, so on and so forth. You get 10, 29, 24, 23, and 19. You can verify this. This is the addition, this is the sum of these two particular individual numbers, right? So when you have that, then what you will do is you'll actually modulo it with 26. You'll find the remainder of these numbers, each of them by 26. So then you get, in that case, you get 10, which means that the number is less than 26. You'll get 10, obviously. When you have a number greater than 26, which is the case for 29, you'll get 3, because 29 is 3 greater than 26. So you'll get 3 for that, and then you'll get 24, 23, and 19, because those numbers are not greater than 26. Once you have done that, you convert them to their respective letters essentially. So if you consider them as positions, this 10, 3, 29, 10, 3, 24, 23, and 19, if you consider them positions on the alphabetical order, you convert them back into their respective alphabets. You get JCXWS. Now this is your Vernam cipher, right? You've successfully converted it into your cipher, right? So the only thing in this particular case that is needed to be known by the decryption end or the recipient's end is this particular key that you have, which is BXLKD. This is the key that is supposed to be known for that one particular instance of communication between you and the receiver, so that the receiver is successfully able to decrypt your key, right? So this is one time pad. So JCXWS is your cipher. Now, moving on, we have symmetric algorithms. An example of a symmetric or a private key algorithm would be data encryption standard or DES. Now, this is also used today. There are very few weaknesses attached to it, like weak keys and whatnot, but this is the encryption technique that is widely used today as well. So, it is a symmetric key block cipher published by the National Institute of Standards and Technology, the NIST. So, let us look at how this works. Now, this is a bit complicated, so I'll go through this in a sort of concise manner. This is the diagram of how it looks. So we are going from extremely easy to extremely complex in just a few seconds, right? So say you have plain text. You've converted that plain text into 64-bit blocks, right? So each of these blocks you'll pass through this particular algorithm. So the structure looks something like this. Firstly, the 64-bit plain text blocks is passed through an initial permutation, which means that when the 64-bit plain text block comes into the entire architecture, it is jumbled up. It is jumbled up using a particular permutation table that is there in that part of the algorithm. After that has happened, then you have the 16 rounds. So the DES has traditionally it has 16 rounds. What happens? Uh, each of these rounds gets a unique key, right? So this key is provided by the round key generator. Uh, where you actually give a 56-bit cipher key to that round key generator, and based on that 56-bit cipher key, it generates keys for every round, right? So round one gets a key, and based on that key, ciphering happens based on the Feistel cipher technique. In round two, the same thing happens after the data is transferred from round one to round two, and so on and so forth. It is transferred to round 16, and then the key works on round 16 for the ciphering, and then it is passed to the final permutation step. In final permutation, similar to the initial permutation, based on a particular table, the data is jumbled up, and then at the end of it, you get the same amount of data back, which is 64-bit. Now it has been converted into cipher. So the advantages that are associated with DES are each small change in plain text drastically affects the cipher. So this is also called the avalanche effect, essentially, which means that if there is even a small change in the plain text, the cipher changes dramatically, which means it is very difficult to deconstruct the cipher. So it will take a lot of processing power on the hacker's end to be able to deconstruct that data, unless the hacker has any idea about the key. And then each cipher bit depends on several bits of plain text. So this means that each bit that is there in the cipher depends on several bits of the plain text. So even if you change something very small, right, like we discussed earlier on, the cipher bits will be changed by a drastic margin. Then we have an example of an asymmetric example, which is RSA, Rivest, Shamir, and Aldelman. Now, RSA is sort of a mathematical operation that happens. It is also widely used today, but it is an asymmetric cryptography algorithm which requires two keys, private and public, obviously, uh, because it is asymmetric in nature. Asymmetric means public key cryptography. So, be with me on this. This is just the algorithm of how this happens. You might be confused by this, but just stick around. You take any two prime numbers, which are P and Q, consider them P and Q. Uh, N is a variable that is the multiplication of P and Q, so you have a variable N. And E is a derived number greater than 1 and less than Q minus 1 and P minus 1, and there should be no common factor between E and Q minus 1, P minus 1. So basically co-prime in nature. So now you have two particular characters or two particular variables called N and E. The public key that will be available to everyone is NE, the combination of NE. This is your public key. Now for the private key, The private key is actually calculated, right? So calculate D when ED equals to 1 mod P minus 1 Q minus 1. So E was previously computed, right? The algorithm to calculate D would be to evaluate D for this particular equation. ED equals to 1 mod P minus 1 Q minus 1, right? And then once you've calculated D, the encryption formula would be cipher equals to plain text into E mod n. So this is on the public end side. So anybody is encrypting that data will use this particular algorithm. For anybody who is decrypting that data, they need to know the D value, and that is the private key essentially. The private key is D. They know the private key. So they'll calculate the plain text by multiplying the cipher with D mod n. Right. So you can see how the private and public key concepts have been implemented in this particular algorithm, as we can see. Right. So you convert the plain text and the cipher into numeric format, and then you apply the mod operation to that with the private and the public keys, and then you essentially get your encryption and decryption. Next up, we have the password storage method. Now, an example of hash functions essentially, where we are actually using hashes in real life, right? So one of the examples for this would be bcrypt. Bcrypt is a hash algorithm. So you create an account on a website, right? And then the website asks you two things, among many things. It may ask you for a lot of other things as well, but the two primary things it asks you for are your username or email and your password, whatever you want to create your password as, right? So these are the two parameters. So whenever you actually create your account in most websites, in most secure websites, your password is converted into an encrypted password by passing through an hash function. So your password is in plain text format, right? And it is passed through a function, a hash function, and it is hashed into an encrypted password. So when it's passed through a function, you get your cipher. This particular cipher or encrypted password is stored in the website user database, right? So whenever you create your social media accounts, your encrypted password is actually stored in the databases of the target social media company or the company that you're or the organization where you're creating your account. So naturally, the next thing that you would do is at a later time, you will log into the website, right? So you've created your account and say one day later you log into that website. Then upon login, it asks you of two things. It either asks you for your email or your username, and it asks you for your password, right? So what you'll do is essentially enter the password, and what the uh, browser will do for you whenever you type the password, it'll use the algorithm that is intended by that website, and it'll convert your password into plain text there and then without anybody actually seeing it in the line of communication between the client side and the server side. The password is converted into encrypted format in the user end itself. The password is converted using bcrypt or some other algorithm, and it is converted into the encrypted password. So what is actually passed onto the website is the username and the encrypted password. The encrypted password is then compared to the password present in the user database. So firstly, the database will look for your username or email. Once it finds that in the primary key section, sort of, and then it'll match the password present in that row, the encrypted password that it has, with the encrypted password that it has just received during your login attempt. If the passwords match, if the encrypted ciphers match, you successfully log into your account because there is a match in passwords. If you don't have any two-factor authentication available or something, you'll successfully log into your account there and then, right? So the advantages to this, even if an attacker gains access to the user database, right? The attacker can't actually gain access to your account as the password in the database isn't in plain text format, right? So it's pretty straightforward. If you convert your password into Cipher, which is actually happening at your browser end whenever you're trying to actually enter your username and password and log into your account. It is converted into an encrypted password and then sent over to the server, right? But say a hacker actually hacks into the database of the company or the organization or the website that you have created your account on, and it gets access to the SQL database, say for example, that is present for users. So the SQL database will contain a column called the password, right? So the passwords present in that column will always be encrypted in nature, right? So when the hacker tries to copy that encrypted password and put it into the login tab where your username and passwords are supposed to be entered, we can see in the second image, in the second sort of block over here, that if we pass the encrypted password through that function, we get something entirely different. Now, this something entirely different is then passed on to the website, and it is compared with the already present encrypted password over there, and there is not a match, right? So, this essentially tells us that you can convert this password on, if your algorithm is good, essentially, the function is good, you can convert the password only one way. You cannot convert the encrypted password back into the password. You can only convert the password into the encrypted password. So this is a very good implementation used in password protection, right? So as you can see, this ensures a lot of security measures, because for the hacker to be able to reverse engineer that password would almost be impossible, and is impossible in most cases. So we've looked at a lot of examples and concepts. So let us see some of these things and how the real world implications of these things work in a practical environment with the cryptography demo with regards to ethical hacking. So currently we have our virtual machine environment open, and I have installed an application called HashCalc. Now this application actually converts text files or any other file into their respective hashes, right? So we have a lot of hashing algorithms available to us. We have MD5, MD4, SHA1, SHA 256, 384, 512, so on and so forth, right? So what we can simply do over here is I can go ahead and create a new text file, right? So let us call this plain text, right? And if I open that, I can write some words in it. So hello from Intellipaat, right? So once I have written that, right, I'll save this. So now I have my plain text, which has the message hello from Intellipaat. So in the data browser over here, I'll click on find file. And then the next thing that I would do is go to desktop and find my file, which is over here, plaintext.txt. I'll open that up, and then I'll simply click on calculate, right? So once I have clicked on calculate, we can see that I have my respective hashes available to me. So I have MD5 hash, I have SHA1 hash, I have my RIPE MD160 hash and CRC32 hash, right? So I'll just put it on the left hand side over here, right? And then I'll go ahead and open another browser of hashcalc, right? Now the next thing we would do is go to the plaintext.txt file, and within that I'll make some changes. I'll change the last letter to S, right? So when we do that and put an exclamation mark over there, we've only made one character change to the entire plain text. Mind that, and I'll save this over here. We've only made one character change. We've changed the T to S. So we will now close this up, browse again in the desktop, browse to the plain text.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We have our plain text txt over here. We click on that and then we click on calculate, right? So I'll put it over to the left hand side over here so we can do a side by side comparison, right? So we can now see that the MD5s are totally different. The SHA1 is totally different. In the beginning of the first SHA1, we have 4299866, and the next one we have completely different hash. We have for other hash algorithms as well, we have completely different hashes, right? So we can now understand that even changing the plain text slightly can change the hash so much that they are such good viable options for password storage or any other sort of encryption as well. In most cases for password storage, we want algorithms that cannot be decrypted at all. So they are one-way algorithms, and we make sure that they cannot be reconstructed backwards. So let us use another application called CryptoForge, which actually encrypts files and helps us decrypt them. So for instance, we have this text file over here, confidential.txt. We open that up. And we can see that there are some details over here, some fake details, Visa credit card number, bank account number, and card PIN. So some people like to keep this information on their computers. It could be risky if you don't actually encrypt those files. So be sure to encrypt them. So I'll close this up, right? So after I've installed CryptoForge, I get this option to right click on the file and get this encrypt option over here. So I'll click on that. So once I've clicked on that, I can simply enter in a paraphrase, right? So let us enter QWERTY 123 and confirm that and click on OK, right? So now we can see the original file has disappeared over here. We can see we have confidential.txt.cfe, but we don't have confidential.txt anymore. And this is essentially encrypted now. So I'll copy this file and then go to my network folder. I'll go to that. I have two options available. I'll click on server 2019. This is another virtual machine that is running in the background, right? I'll click on admin and then enter my server 2019 password. So once I have done that successfully, I'll go to the users folder, right? And then I can simply go to the public folder and then paste it over here, right? So it's currently in my server 2019 virtual machine. If I switch back to the server 2019 virtual machine, I can search for that file. So I have it currently available over here. We can see confidential.txt.cfe. So if I open it with Notepad++ or any other text editor, we can see that we can't actually see anything in this. It's all encrypted, right? We can't actually access the contents of this txt file anymore, right? So the next thing that we would want to do is actually decrypt it. So once I have installed CryptoForge, I'll simply go ahead and click over here. So once I click on that, it asks me to enter the paraphrase, right? So I'll type in QWERTY 123, click on OK, and we can see the file has been converted into a normal text file again. If I open that, I can see the information that was previously available, right? So that is about it with the hands-on section of how encryption and decryption work in cryptography.
First thing, I'm going to tell you like what is CISSP. So the simple thing is in this certified information security professional, they have only considered one thing, data security. Okay. When I say data security, there are different state of the data. There are three state of data. One is data at rest, data in motion, and data in use. There are three state of the data, and the CISSP will talk about how you can make your data secure in these three states. When I say data in rest, just understand data is not moving or data is not in use. It is constant. Somewhere static in nature. Data is static means you have kept your data into hard disk. You have kept your data into your file where it is not being used by anyone. Okay. Now data in motion means it is in transit. When I say transit, it is on motions. Means it is traveling from one to another. That is data in motions. Now data in use, very interesting. When I say data in use, like data is being processed. I can give you an example. Your computers, when your processor use your data to process it, that means data is in use. It has been used by your RAM memory. It has been used by processor. That means data in use. So CISSP will focus towards how you can bring security in this three consistent state of the data. That's all about CISSP. That's very simple definition like what we are going to do in CISSP. When I say data in rest, it would be staying in some kind of hard disk or somewhere you can keep in your data center somewhere, right? Then how you can bring the security? It will talk about in asset security. If you're keeping into any hard disk, how you can keep that, what would be your retention period, all this stuff they will talk about this data asset security mainly. Or in dominate in security operation, when you want to configure your dear site, how you are going to configure by seeing what are the states and what are the usefulness, by seeing that what you are going to design that. Now in data in motion, let's say I'm sending an email to Goms who is at US. That case, how I can make sure if data is leaving from my computer or the email is leaving out from my computer, it has to go to the internet pipe, isn't it? So in internet pipe, it is very easy, like it can be eavesdropped by anyone. When I say eavesdrop, anybody can listen that data, isn't it? So I can bring some kind of encryptions. I can change my email format into a different format. If a data which is having a value or meaning, if I'll change the meaning of the data to a non-meaningful data, then nobody is going to listen my data, isn't it? If I am sending, I'm sending you $1,000. It's a very sensitive information, isn't it? But I'm sending $1,000. If I'll send XYZ, then it is not a relevant information for any hackers or anybody, isn't it? So how you can bring the security in data in motions. Similarly, data in use. Your processor is processing various kind of data. We're processing various kind. When I say various kind of data, there are different type of data, isn't it? Like it could be your official data, it would be your departmental, it would be very sensitive, it would be your personal information. There are different kind of data, isn't it? What do you mean data? It's kind of information, isn't it? There are different kind of information the processor would be executing. When the processor would be executing different kind of data, it is kind of like he's playing around, playing with a 10 different different data type. There would be a high possibility there could be a chances of leakage of the data from one particular application to another particular application, isn't it? So when I say that the leaking or there are different kind of attacks. I'm going to highlight in next 30 hours about those things, like how you can protect your data when data would be in use. Now, how you can bring data security in your organization? There are three important pillars of the data security: confidentiality, integrity, and availability. This is not CIA, Central Intelligence Agency of US. This is all about data security. We are talking about this triangle: confidentiality, integrity, and availability. These are the three pillars of data security. If you will achieve data CIA, that means you are maintaining consistent security when data would be in motion, data would be in rest, or data in transit. Okay, is it clear, guys? So now let's understand what is CIA. When I say confidentiality, why I'm saying this is the three standard pillars in order to bring data security. If you are maintaining confidentiality, integrity, and availability of your data at any state of the data, then you are achieving 100% data security. Now, what is confidentiality? Confidentiality, please try to remember in this way. Unauthorized persons should not get a copy of your data. Means those person who is not authorized to receive the data, he should not get any idea of what you are sending to any authorized person. But when I say unauthorized person, that means it is like numerous, right? You don't know who is unauthorized person, right? So when I'm sending an email to anyone who is in US, there could be a possibility 1,000 of unauthorized person, right? So we should use certain kind of standards or certain kind of like encryption, authorization, accounting, some kind of jargon we should use, or some kind of technology we should embed it into our data so that nobody will get a copy of the data. I'll give you one more example. Let's say A and B. Now I'm sending a data to A to B. There are so numerous possibilities that there are numerous people are waiting in the internet want to listen what I'm going to send him, isn't it? Now, if I'll encrypt, like I have already given the example, let's say I'm sending a important message to B, like sell this here, this Tesla share, because it is going to be down next week. Okay, if I'll send this data by anyone who is in the internet, like hackers or anybody who has wrong intention, he can use that particular information and he can play around with, isn't it? But I want B has to receive this because he has paid to me. So in that case, I will change the meaning of this data into some kind of XYZ or some kind of different non-meaningful data. Then it is very impossible for the hackers to know what I'm going to send to that person. Now, this is very important to understand, guys. I'll take you the book quickly because this is the very important concept in order to understand. Now, see, there are different type of definition given in the book. If don't remember any concept, okay, only think like unauthorized person should not get a access to your data. Now, in order to violate the confidentiality of your data, there are numerous attacks. There are numerous attacks. Known attacks are there, already there. One attack is called shoulder surfing. Second one is port scanning, eavesdropping, escalation of privilege. All those attacks are focused towards your breaching the confidentiality. When I say shoulder surfing, I'll give a simple example. Let's say you are typing some kind of password into your important banking portal in your computer, and in office everybody sits very close by, isn't it? Somebody will look around, look over your shoulder, and he got to know your bank password, he can log in, isn't it? And he can do whatever you are doing, isn't it? That's a way of breaching the confidentiality, isn't it? Because that password, your banking password, is only, it should be limited to you only. If somebody else is looking into that, or somebody else who get who got access to that particular password in an unauthorized way, that means it is breaching the confidentiality. Now next one is eavesdropping. Coming back to what is eavesdropping, let me go back to my example. Let's say I'm sending the data A to B. I'm sending A, sell the Tesla share. The hacker is here. He can listen it. He can do the eavesdropping, overhearing, and he can get a copy of that. But if I'll send encrypted format, if he'll get that data, it is a non-meaningful for him, isn't it? Eavesdropping is simply just to get a overhearing of your data, or by any means, he get a copy of your data. Eavesdropping. Now, next one is port scanning. Port scanning means, let's say you have a firewall and you have, like there are several kind of applications are there. They can use that application to scan your firewall to find out the port which is, not, protected well. When I say protect, there are different kind of mechanism in firewall are there to, either you can shut down the port, or you can, put certain kind of restriction that nobody will able to log into that port, and no unauthorized person should get into that port. That is a mechanism of doing port scanning. Now next one is escalation of privilege. See guys, those attacks will come into our slide, but I'm just giving a overview, because this three pillar you should understand in order to move forward. Now escalation of privilege. Like I'll give an example. Let's say I have given a read-only access to you into the firewall. Okay. Now your intention is wrong, and you have figured it out how to increase your privilege to root level or super user level. That is called escalation of privilege. Any unauthorized way to increase your privilege level, that is called escalation of privilege. Don't you think that if somebody has increased his privilege level, don't you think he can breach the confidentiality? If I've given a read-only access to a particular system, but I have figured it out, how to increase my privilege. Now I'm a super user. I know everything of the system. Might be I got a read-only access to a particular system, particular domains, but now I have figured it out how to become a root user or super user. In that case, I have breached the confidentiality. Now, how you can, stop the, confidentiality attack? See, you can stop different means. You can encrypt it, or you can enable authentication, IEEE. I'm going to teach that. Okay. And you can, like, if you, in my example, I said like somebody is, doing a port scanning in your firewall. In that case, you can enable certain kind of what port, authentication into the port, certain kind of rules you can bring on. If somebody want to go into, somebody want to do a port scanning to firewall, then you will not able to do that. Okay. See, these are the countermeasures. So now when I say countermeasures, measure means prevention, like encryptions, network traffic padding. Network traffic padding is an important concept we'll be reading into domain 4. Okay. Now there is a concept called personal training. If this personal training will create a deterrence, there is an attack called social engineering, is also focused towards confidentiality breach. I will give an example. When I say social engineering, what do you mean social engineering? Let me give you an example. Like I teach CISSP for different people in different country, isn't it? Now, being a teacher, I can ask you 10 questions about your questions, about your company, saying which company you work, what are the firewall you are using, and what kind of rules you have, what are the load balancing load balancer you use, where is the load balancer, where is the IPS. All these things I can do a, information gathering. Social engineering is nothing but doing a information gathering, isn't it? Please note, social engineering is the toughest attack. When I say toughest attack, there is no technical barrier which can stop the social engineering. When I say technical barrier, you can't do such encryptions. You can't breach the social engineering attack through encryption. You can't put any kind of authentication, authorization, accounting in order to breach the social engineering attack. There is only way to breach the social engineering attack is personal training, or train individuals in your organization. People in the organization, they are the weakest element and they are the valuable element in the organization. I'll write here. We'll explain this. Employee or the people in the organization. Those people are biggest threat for the organization. And they are the most valuable. Why? Why do you think they are the most valuable things and they are the biggest threat for the organization?
Yes.
See, I'll give an example for this. Let's say hacker wanted to access or hacker wanted to breach your confidentiality of your organization. In that case, he has to breach your perimeter security. He has to breach internal security. Then he has to do information gathering. Where is the information lying? Like there are different kind of the different data center we have where it is the particular information is there. Until to reach the particular content by the hacker, it will take a lot of time for them. Until that time, it is very easy if you have designed your security system for organization correctly, you would be able to easily catch them, isn't it? But the easiest way to do the confidentiality breach is through social engineering. That's why who can give this information? Those people who were working in the organization, who were working into the project, in that project, they are the weakest link, isn't it? That's why there is no barrier or there is no technical training, there is no technical restriction you can put like encryption or any technical methods you can put in order to stop this attack. Now coming back to why they are most valuable. You can build a complete organization, but if your chief security designer is like he's leaving the organization, then you are not going to replace him by anyone because he knows everything. That's why people are the most valuable element in the organization. There was every company were crashing, like every data center, every valuable assets. So guys, now coming back to assets, I'll come to that. Assets are two type. One is tangible, one is intangible. Who can tell me what is tangible? Tangible means which you can touch, you can feel, you can see. Those are tangible assets like firewall, proxy, load balancer, people. Those are tangible assets in organization. Intangible assets, those assets you are not able to see, like your data, your information. Those are intangible assets. Your company's reputation is kind of intangible asset. Is it clear, guys? This, if you understand these two things, right, then risk management you will almost like 5-6% clear. Okay. Now coming back to employee are the biggest threat for the organization and they are the most valuable threat for the organization. Please remember this. Now, how the social engineering attack can be prevented? If you do like if you are working for a organization, they conduct certain kind of training every quarterly or monthly based in order to educate you, saying you should not what should be the right thing, what should be the wrong. Basically in that training they focus what you should do, what you should not do. Okay. If they will conduct a extensive personal training, it will create a deterrence in your mind so that before doing any wrong thing, you will at least think twice or thrice. Okay. That is called like that is the benefit of personal training. Is it clear, guys? Deterrence means some kind of barrier it will create, like the fence. I have a fence in my perimeter. The fence is 10-foot height. Then if somebody wants to trespass that or somebody want to climb that, We'll say 10 feet. It's doable. But if I'll make 16 feet or 20 feet, then he will at least think 3-4 times before climbing that, fence, because it's 20 feet. It's quite high, isn't it? While climbing the fence, somebody can see him. That is called a deterrence or fear in your mind. Now, confidentiality breach can be done in two ways by the employee. One is intentional, one is unintentional. When I say intentional, in company there are disgruntled employees are there. Do you know what do you mean disgruntled, guys? You can't make everybody happy, right? That's the slogan of the managers, right? Isn't it? Now, disgruntled people means those people who are not happy in the organization. They always try to, hamper or damage the organization, isn't it? That is called intentional way of violating the confidentiality. I want to show my manager that whatever appraisal he has given, it is not right for him. Me. Why I will show? How I will going to show him? I will not do the security policies which I am going to configure in firewall or proxy. I'll not do in proper way, so that the hacker will come. Somebody will come into my environment and it will do some damage. In that way, I can do a damage to my manager reputations, isn't it? That is what disgruntled people do, right? Isn't it? That is called intentional way of hampering the confidentiality. Okay, please remember, confidentiality and integrity, they are brothers. Means if you're not able to maintain confidentiality, then you can't guarantee that integrity is also still there or not. So in order to, if you are maintaining confidentiality and integrity, then you are doing good. But if you're not maintaining confidentiality but you are maintaining integrity, there is no value. Think about it, guys. So there could be a questions like, I have done this. Do you think I have done 100% security? I have followed 100% data security? No. These two are brothers. They'll always run each other, along with each other. Now coming back to what is integrity. Same definition. Unauthorized modifications should be prevented. That's the goal. First, confidentiality, I said, unauthorized persons should not get access to your data. Unauthorized integrity is simple. Unauthorized persons should not alter or modify your data. That means unauthorized modification should not be allowed. Now coming back to the concept of integrity. So when I say unauthorized modification, I'll ask one question. Let's say I have given a super user access to a firewall. Now you have done a mistake. Do you think integrity has been breached or not? You are an authorized person, but you have done a unauthorized modifications. That means you have breached the integrity also. Please remember, there are 3 golden rules of integrity. First golden rule of integrity: authorized person should not do any unauthorized modification. Second golden rule: unauthorized person should not do any alteration or modification. Third golden rules: you should maintain internal and external consistencies of the data. These are the 3 golden rules. There is a content, there is data. Now I have given A, B, 3 persons access to this data. Now he is a read-only user. He is also a read-only user, but he is a super user. Now this guy is a read-only user. He can't do anything, isn't it? Now this guy is a super user. He can do anything, but he has to do any, if he has to do any modification, he has to follow the change management procedure. But what happened? All of a sudden he didn't follow the change management, but somebody has approached him. He has done a rule by mistake, or he has added a rule. There was no record. Don't you think the integrity has been breached, guys? Now, first golden rule I said, like he is a super user, he can modify things, but he didn't follow the change management procedure, but he has done some modifications. It has not been tracked, so integrity has been lost. The first golden rule is authorized person shouldn't or must not do any unauthorized modification. Second golden rule, unauthorized person should not alter the data. This person doesn't have write access. B, because I said it's a read-only access, but he is doing some modifications. That means he is an unauthorized user, isn't it, guys? Third one is, if your firewall is behaving properly for some data, but improperly for another some data, that means it is not maintaining a consistencies. Okay, that means maintain internal and external consistencies. This thing will get in book. I'm just explaining. This is all about integrity. Again, integrity. How you can bring integrity, guys? There is a concept called hashing. This is the primary thing through which you can make sure that integrity has been maintained. Okay. Now I'll give you integrity can be breached again two ways, intentionally or unintentionally also. When I say unintentionally, like you are an authorized person, but if you have done a unauthorized modifications, either you have done intentionally or you have done a mistake. Do you think, guys, mistake by authorized person is also breach of the breach of integrity? Mistake, your mistake. So your mistake also lead to breach the integrity as well. There are numerous prevention again by the integrity, like how you can, these are the attacks I've already discussed, logic bomb, all these things. Okay, there are numerous things you can bring on, like hashing. Those are the countermeasure. I'll be discussing those things in detail in cryptographic domain. Now, confidentiality you can achieve in different means in organizations. You can, those are the things, if you'll follow, you can achieve confidentiality also. Now, sensitivity. Do you think, guys, or there are different kind of data in our organization, isn't it? Do you think
Yes.
all the data need to be protected equally? The main objective is, the goal of classification of data is save the money. How? There are different kind of data, isn't it? By value of the data, by the sensitivity of criticality of the data, I will classify into different areas. By seeing their value, I will put that type of restriction in order to protect their CIA. Okay. Now, if I will put a equal type of restriction to all of the data, then I have to spend hefty amount of money in order to protect all data, isn't it?
Yeah.
So the goal is, in private organizations, basically we do the classification in order to save money. Okay, I'll come to that later. Now, why did I bring this? Because in order to protect the confidentiality of data, you should know the quality of information, the value of the information, isn't it? So if I'll declare myself that this particular data is sensitive in my nature, then I will give more stress to prevent any unauthorized disclosure, isn't it? You have seen in your organization multiple hard disk or multiple computer. In front of the computer they have given a poster. It's like confidential data is being processed, don't touch this.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Do you think that is a standard practice? That's a best practice or not, guys? Yeah, have you seen like some of the in your work areas? You have seen some computer would be marked as different, like red, green, or yellow, or somebody has put some poster like there is a confidential information processed by this computer. Don't touch it. Have you seen, guys? It's kind of banner. Like if you are logged into any switch, this switch is being monitored. Don't touch it.
Yes,
Don't
I am
try to
aware of that.
impersonate. Why? So that it kind of deterrence in your mind. I have alerted you. You have seen like US, right? If you're living in US, like if you're going into somebody's perimeter or somebody's property, they would have given a notice in front of this is my
Correct.
property.
Yeah.
Don't do the trespassing, isn't it? Why? Because they want to alert you. They want to alert you saying, don't come here. I'll shoot you. Similarly, in our company organization, we mark some assets saying labeled properly so that that assets being monitored or there's confidential information is being processed. Don't touch that particular computer. So that's a one way of maintaining confidentiality in organization. Now, concealment, this is a very important concept. Concealment, I have given one example last. There was a hole in my wall. I have put some, you know, paste in order to look it. You know, if somebody is coming to my home, he should not see it, isn't it? So that is called concealment. Concealment is nothing but hiding of data. But please remember, if you're doing a concealment, this concealment of data will give a birth of a concept called security through obscurity. I have written here. You can see security through obscurity. Have anybody heard this? It's nothing but it will say that I have hide that particular data in my organization into a like into a place nobody able to find that. That means you are overconfident. You are underestimating the hackers. You are underestimating the intruder, isn't it? Security through obscurity is just a level of confidence you gained. I'll give an example. When we used to be kid, my example, my mother used to keep the keys under the doormat, and she will tell to my father like the keys is under the doormat. Okay, I think you only know this, and I know nobody else. My mother would be rest assured, like she will go to the market and she will do some shopping and all. She will always think that her house is completely secure. Nobody will able to get in because the key is under doormat. But she has underestimated the thieves, isn't it? Thieves can easily they know that these are the standard way of keeping the keys when they want to hide the keys. It should be in under the doormat or outside shoe rack under this or somewhere in the next to the front gate some port. You will put the keys over there. They will look into it. So security through obscurity means you should not, this is a bad thing, guys. Okay, it's a bad thing. You should not be overconfident that whatever you have created, that is 100% correct. Okay, now secrecy. Secrecy is another way of keeping your secret, another way of creating secret. preventing any unauthorized disclosure. So you can create your data secret. Similarly, if your privacy refers to keeping information confidential, that is. Now this is an important concept. Seclusion means out of path. Like, you should not keep your data where you're no if you should not keep your critical or sensitive data into normal transit path. Means there would be a standard path, right, for your user traffic, for your server traffic to go out to the internet, come into from the internet has to come to the users, isn't it? So if you are deciding some kind of data is very secret or very tough for the organization, or very critical or very secret in nature, you should not keep the data into that particular, standard path. You should keep the data out of path. That is concept is called seclusion. Is it clear or not? Now next
Okay.
concept, isolation. Isolation is like you can create a isolation wall in your company and you can keep your data. Again, this isolation also gives the birth of the concept security throughout security. I have isolated my data. Nobody is going to find that particular isolated area in my organization. There is no need of any physical security. Like nobody has to monitor that particular area. There is no need of any security camera, all this thing. Because I'm overconfident, isn't it? But hackers are 100 times smarter than those who design the organization security. Okay. Now, internal and external consistency, validity. Okay, this is validity is a way of check of internal and external consistencies of your data. So these are the factors which can make sure that data integrity is followed. Accuracy, correct and precise. Truthfulness, your data should be true reflection of reality. You should not give any malfunction data to anyone. When I say malfunctionless, let's say you are submitting your company's revenue record. Okay, you should not forge it. If you forge it, your company integrity is being lost if somebody will get to know that you forged that your company revenue record. Now, non-reputations. As John said, before understanding this non-reputation, you should understand what is reputations. Reputations means I will tell this thing, I will tell that John is very bad guy. Later moment, when you will go to John, Deepani is saying that you are really bad guys. Then when John will come to me, I'll say, no, I never said this. I have never said this. Do you have any proof? But that was a general conversation, right? Nobody records that, isn't it? I have ability to deny. Ability to deny as reputations. Ability to not deny. That is non-reputations. Your company is putting CCTV camera to everybody. Why? Because they said your activity is being monitored. Let's say you are pushing the lift button and you are very frustrated, it's not coming. You want to kick the lift button. It's being monitored. Later point, they can come to you. Why did you kick the lift button? Then you don't have any way to deny that. That's called non-reputations. You are logging to a firewall or proxy, load balance or router or any devices by your username password, and you have done some modifications. In that case, your logs been monitored by the monitored by Splunk or anywhere it has been recorded. Later point, your manager will ask you, why did you do this change? It create a P1. In that moment, you don't have any option to deny because it has been monitored, isn't it? That's called non-reputations.
Yes.
Now, accountability, responsibility, completeness, comprehensive, these are the standard words through which you can maintain the integrity. Now, the third triangle is availability. What do you mean availability, guys? Data should be available when it is required. Nowadays, you are seeing, right, these cloud providers, they give 100% or 99.99% of what? Availability. Yeah, that means, do you know, have you ever thought what even at that 0.1, what it would be the reciprocation of that 0.1? Have you ever thought that, guys? I'll tell you. Maintenance. That is a bigger game. I'll tell you what do you mean by that 99.1. It's really interesting fact. You should know that. I'll just have yes. If you are saying uptime of 99.9999 5 times 9% like this, if a cloud provider is saying, that means 3 seconds of downtime yearly is accepted. Means if you're using a computer or a banking system, then you can expect 3 seconds of downtime in your whole year. Now, if I'll reduce 10 here, that means you can expect a 31 second of downtime. Again, if I reduce 10 here, just think, guys, 99.9990, then you can expect 5 minute 15 second of downtime. Now, if you reduce one more zero here, you can expect 52 minute 35 second of downtime in a year. If I'll give 10, I'll reduce 99.9. That means you can expect a 8 hours 45 minutes downtime in a year. If I'll reduce complete zero 99%, that means you can expect 3 day 15 hours of downtime. Just think about it before buying any cloud solution, guys. Really important. Now, distributed DOS. I'll give an example. Understand this. This is your computer. Now, this particular, this is hacker 1. In case of DOS, you will try to initiate so many connection to you. Okay. In order to block your connection limit. In case of distributed DOS, instead of this hacker, he will use another medium. He will initiate the connection till here, and he will bombard it with this respective host to you. It will be very severe type of attack to you. That's called distributed DOS. So if you'll block this particular host, there are other 10 more or 15 more hosts would try to attack you. That is called distributed DOS. Now, other concept of IEEE, when I say other concept, so please remember, although I always say CIA is very useful in order to maintain the data security, but if you're not able to maintain or design your security in this IEEE pattern, then it's very difficult to maintain this CIA triad. Why I'm saying, if
Just a quick info, guys. Intellipaat provides CISSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
if I don't know your identification, who is accessing my data, then how can I maintain the confidentiality, integrity, and availability? Isn't it? If I don't know who is authenticating my data, or who is trying to log into my data, or who is trying to access my data, if I don't know his credentials, if I will not able to track his credential, then it's meaningless, isn't it? So IEEE stands for identification, A stands for authentications, A stands for authorizations, and A stands for accounting. Now, when I say identification, this is the first thing you need to understand. This is the most critical and crucial thing if when you are designing any type of authentication system. Why? Your identification should be unique, isn't it? When I say unique, let's say 10 people has to access a system, then there should not be any duplicacy in your identification. When I say duplicacy, there should not be two similar identification name in 10 people. So if Gomez is here and another Gomez is there, same with different surname or title, you can create different username like 1 or 2. You have noticed in your organization, if you are like John, if you join to your organization already, there will be some John with the same name, then John would have get some different ID like John 1 or 2 or something, because they want to make the username unique. So there are 3 concepts you need to remember when you create a identification of a identification part in your company. First thing is your identification should be unique. Second thing, your identification should not be descriptive. When I say descriptive, it should not be big lengthy identification you should create in your organization. Third thing, it should not be self-meaning. When I say self-meaning means, let's say your CEO. Your CEO, identification should not start with a CEO.com. CEO at the rate, like XYZ company.com. It should not like that, because by seeing that identification part, the hacker should not get a idea like whom or who is trying to access the system. Is it clear? Identification part. Now next thing is auditing. I'm just putting a auditing here, okay? Just think about it. Then now next is accountability. I'm discussing about 5A 4A now. Now when I say auditing, what do you know? Auditing means it will decide whether you have done correct or not. Now, see, listen, you have submitted your username. You have given your username plus password, okay, to authenticate. Now, after authenticating yourself, your authorization has decided like what you can do. But if you have read that concept of confidentiality, while you are having authentications, you can do correct thing. You can do also mistake, isn't it? The mistake are 2 types. One is intentional and one is non-intentional, isn't it? Now this audit will decide whether if you have done any mistake or not. Is it clear or not, guys? Audit purpose is to decide whatever the action you have done, is it correct or not? Clear? Yeah. Now you know whether you have done a mistake. If this person has done mistake or not, that will be triggered through the auditing. But in order to held somebody liable, whether he has done any mistake or not, we can held him liable through the accountability. When I say accountability, this accountability would be checked by in your log file with your what? Username. When I say username, with your identification. So accountability will hold you responsible if you have done any mistake. From where? From the log files.
Here we'll take a look at what are the concepts that are associated with cloud computing that we should know about. So let us begin. We'll begin by taking a look at what exactly is cloud computing. Let us begin by answering a very simple and key question in that regard. A question that comes in our mind very often when we're talking about cloud computing is, what exactly is it? Well, think about it in terms of what cloud computing provides us. If there was no cloud computing, as in we were living in an era where cloud computing was not a thing, think about sometime before 2006 or 7 when AWS was released. Before cloud computing was available, deploying an application was a massive task. This was really difficult. Suppose you have an application idea and you just want to try it out, just a proof of concept. But even for a proof of concept, you need some infrastructure backing it up. So if you're trying to build a web application, you want to see how it can be deployed on a basic infrastructure, you need to firstly create that infrastructure. And this was a massive undertaking. It required a lot of thought, it required a lot of capital, it required a lot of work. So as you can see in the diagram below, we would firstly have an application. We would have to set up an infrastructure, and then the deployed application can be accessed by the required target audience. It could be an alpha version, it could be a beta version, or it could be a fully deployed application. Regardless of the workload that you are trying to target, you still would have to be somewhere around an infrastructure component on which you can deploy the application. This involved numerous complicated tasks which made things really difficult. Let's understand them one by one. Firstly, you had to understand the hardware requirements. You would have to understand the specifications of the hardware that you're going to need. What are the servers, cables, what is the electricity charges, how these things are going to be set up, what is going to be the layout of the network that you're going to create among the servers, if there are multiple servers, how the internet is going to be connected to the server, how the ports are going to be exposed, and what is the specification to handle the workload that you're trying to create. Do you need to scale it vertically or horizontally? How far away or how much support do you get for the particular hardware, so on and so forth. Since there were multiple pieces of hardware that you needed to take care of, it became really difficult for us to firstly get over this initial hurdle of understanding what cloud computing actually means. Then we move on to buying the required hardware. It's not just enough for you to understand what the hardware requirements are. You would also have to buy the hardware which is needed for the deployment. And this requires capital. This requires a lot of money, especially if you're trying to deploy it on the web. In this case, you need to have a web server that could potentially run at least 10 to 15 concurrent requests, which is a little bit more than what usual, 10,000 to 15,000, I'm sorry. But even in those small constrained environments, you have to have very powerful machines, electricity components, ventilation, so that the electricity components can run for a little longer and have a longer shelf life. Racks for the server. If you have multiple servers, you have to have a load balancer. There's a lot of infrastructure complexity that you need to take care of, and that requires a lot of capital for you to buy these things. But of course, buying is not enough. You also need to set up the infrastructure. Setting up the infrastructure involves tasks such as the cabling, laying out the structure, laying out the network topography, how the entire structure is going to be done in a way that new hardware requirements can be accommodated, scaling can be done. Again, a lot of work needs to be done there. And by the way, this is all just for a simple application that you just want to try out. This isn't even for an application that needs to be live in production under certain deadlines. Then comes configuring the system. This is also a major source of problems. If the systems are not configured correctly, they might not work well together. If two hardware systems do not have the compatible drivers, if they don't work together well, then there could be a lot of issues with that as well. Then comes managing the system. Deployment is not enough unless you have some dedicated policies of managing the system. System management really refers to how you are going to manage the system if, for instance, something happens that shouldn't have. In one requirement, you can understand it this way, that you have some data and suddenly that data gets deleted. Do you have backup systems in process? How do you have those backup systems? What those backup systems do, how often these backups are taken, what is the restore policy, and there's just a lot of complexity with managing these systems as well. So that's how these are just a few of the problems that we have mentioned. Of course, there could be other problems as well, such as incompatibility in the hardware, refund policies, processing, and a lot of other problems such as ventilation, correctly choosing the facilities where correct facilities are available, and so on and so forth. So all of this needed to be accomplished before you can deploy any application. Now that was the problem, because you had to essentially give a lot of time, money, energy, manpower to this. Even if it was a small application, even if you just wanted to try something out for, let's say, for 2 hours, 10 hours, you just wanted to see if a new change that you are making to an application is going to work well. Is it going to, if you're trying to essentially, let's say that you want to speed up your application, you found a bottleneck. Now, to check whether or not it is going to work, whether the speed up is going to work, in a controlled environment, you need to set up some infrastructure where you create testing copies and deploy it there and allow access to some computer. This is really difficult, especially when there's no cloud computing available. So as it required significant amount of time, money, and manpower, it was not really feasible for smaller applications. So only if you had applications that could basically serve a lot of users and bring in some cash, essentially creating an infrastructure would essentially be burning the cash itself. you are not going to get any return until a specific workload is reached. And even when the workload is being reached, you need to keep the servers intact and working correctly. Any sort of major problems in the server end was going to be a really big problem, especially if you are a team of software developers who don't have much access to infrastructure components and you don't know much about setting up these components yourself. So cloud computing simply removes all the roadblocks that we have discussed thus far. These are the roadblocks that you come across when you need access to some extra computing resources. As you can see in the diagram, you can create an application, deploy it on the cloud, and then it will be deployed and will be accessible by applications. We simply removed the on-premise infrastructure components to cloud computing components. To put it simply, cloud computing refers to the delivery of computing services over a network to a remote customer. So if you are the customer, you want to build an application and deploy it on servers, instead of you having to create the server yourself, that is buying the required hardware, setting up the layout structure, networks, so on and so forth, you can use cloud computing services over the internet to create your own remote systems and connect them together and then deploy application there. This requires significantly less money. Cloud computing offers several advantages. These are the advantages that it offers, or these are some of the advantages. I'm sure you can find more, but these are the major advantages that are important for the concepts that we're trying to cover. Let's take a look at them one by one and understand what they are. The first one is on demand. Anyone can access cloud computing services anytime they need to. Doesn't matter what time zone you are in, doesn't matter where you live, doesn't matter whether it's 10 o'clock or 12 o'clock in the morning, in the afternoon, it's 4 o'clock in the morning, whatever the time it is, you can still access the cloud computing resources that you need in order to get the job done. If this was something that this was like a privately leased hardware system where someone else has created the hardware and given you access to the resources, this would be a problem because at 4 o'clock in the morning maybe they are asleep and they don't want to run up to the server and see what the problem may be. Here you can diagnose the problem yourself anytime you want to, or create new resources anytime you want to. Before cloud computing, anyone who needed computation resources had to buy the resources and configure them, which took time. Here, if you need them, you create them. You don't need them, you can delete them, you can create them, and it works very fast. You don't have to worry about take the time that it might take for all these disposing all these resources. Scalability is also an important aspect. Cloud computing allows us to increase the capacity of resources and services, which are done quite easily. This can be done by either horizontally scaling the server or vertically scaling the servers. Now, horizontal scaling and vertical scaling are two different kinds of ways you can scale a system. Before that, scaling basically means if you have higher workloads and you want to create systems that can essentially handle that workload, or essentially you want to increase the power of the systems that you're using. There are two ways of doing that. There are two ways of essentially creating systems or increasing the power of the system through which they can handle higher workloads. First one is horizontal scaling. Think of it scaling on the x-axis. This is a scaling in which we add more servers to our pool of servers. So for instance, let's say we had 3 servers before, all were managed by a load balancer, and as new requests came in, these were distributed evenly throughout the servers. Now 3 servers were working at the full capacity with the traffic that we're getting. To reduce the workload there, we add 5 more servers on these 3 servers. Now we have 8 servers and they can handle the workload quite easily. The advantage here is that you can easily add or remove servers. That if you don't want to add more servers, you can stop doing that. If you want to remove the servers, you can do that as well. Then comes vertical scaling, which is basically you add more resources to an existing server. You add more RAM, you add better processing chips, you add solid state drives instead of the hard disk drives. Instead of magnetic tapes, you now have a solid state drive which does not have any moving capability, so it is very, very fast. It's expensive, but it's really fast. So you can do it either way. This depends on the use case that you have. If you only have a single server and a monolithic application, then maybe using vertical scaling is a better option. If you have a microservice application that needs to be deployed on multiple servers, then horizontal scaling might be more up your street. This depends solely on your work requirements and how you want to solve them. Then comes elasticity. With cloud computing, we can grow or shrink compute capacity as we need them. This is especially useful during the times of high traffic when we need more computing power only for a short period of time. So in cloud computing, there are ways of setting up parameters where you say, okay, in this pool of clusters, I want 2 computers to be running all the time, and at max there can be 8 computers. So 2 computers are running all the time, but as the traffic increases and the load increases on the servers, new servers should be added to the.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Pool of servers that we have. That's basically what elasticity means. You can grow and shrink the size of your clusters quite easily. You can add or remove more servers quite easily. There's broad network access. Cloud computing services are available to be accessed anywhere using the internet. So you only need internet services to be working on a system through which you can access the cloud computing services you need to. You do not need to be on a special on-premise network to access these services, as you might need to if you are working on an on-premise system. Then there's measured services. This is by far one of the most important concepts in cloud computing. In cloud computing, all service usages are carefully measured and monitored. This allows you to pay only for services that you have used and only for the time that you have used them for. So if you used some server to be you spun up some server and used it for 10 hours, you only have to pay for those 10 hours. Sometimes it's a little more granular than that. Some services charge you per request basis. So even if you created a server that runs for 10 hours, but only 5 requests came in, you only have to pay for those 5 requests. Now, depends on the services that you're availing, and we'll take a look at that, but everything is measured and you are charged according to that. Then comes multi-tenancy. This allows different users to have access to the same cloud computing resources. This allows cloud service providers to use a single machine to service the needs of multiple users. Although these may have access to the same resource, they do not have unauthorized access to each other's data. This is done using virtualization, in which you have a very powerful machine. You break the power of that machine into multiple small virtualized machines, and one virtual machine should not be able to access other virtual machines. That's usually done using hypervisor, and we'll take a look at that as we go along. And then comes resource pooling. The provider's computing resources are pooled to serve multiple customers using multi-tenant model. Different resources are dynamically assigned and reassigned according to the customer's demand. If the customer needs more cloud computing services, let's say they need more servers, the new servers are spun up immediately and added to the pool of your servers. Instead of you having to buy new servers, add them to your remote location automatically, new servers are created out of the already existing places and new servers are added there. So it's quite useful for you in that regard as well. So these are some of the advantages that we have discussed. These are the core cloud computing concepts that you should be aware about, the core advantages. I'm sure you can add more to them, but these are the things that you should be aware about. Be aware about the terminologies that we have used here, such as on-demand, scalable, and elasticity, broad network access, measured services, multi-tenancy, and resource pooling. These are important for you to understand because these are broadly the nomenclature that is used inside the cloud computing world. Now let's move ahead and see what else we can learn. Cloud computing roles. These are the roles that you can take on when you're working in the cloud computing industry. There are 4 main cloud computing roles which you need to be aware of. These are provider, customer, partner, and broker. These are the terminologies that are usually used in cloud computing, and you should know what the person means when they are using these terminologies. Let's take a look at them one by one. Firstly comes provider. Provider offers cloud computing services for sale to third parties. So if you have a third party provider through which you can think about this way, if you have a provider which can provide services to the third party consumers, so essentially things like Amazon Web Services, Azure Cloud Computing Services, Google Cloud Provider, IBM Cloud, Oracle Cloud, these are the providers. They provide you services and they charge you for those services. Then there's customer. Customer purchases the cloud computing service from one or more providers. So a customer could be a software developer, could be an organization, could be the DevOps team, could be any other kind of team. What they do is that they purchase these resources from the cloud computing providers, and then they pay for the things that they use, and they set up the infrastructure and so on and so forth. Then there's cloud partner. These include service monitoring, etc. There are several services that offer to essentially note the incoming traffic on your cloud computing providers. And if there are some bugs, if there is some error that is logged and it is appearing more times than often, then an email is issued to you saying that your website has been facing some sort of an error. Please check. And these services are usually very famous with working with large infrastructure based software. So for instance, if you are running on a huge cloud computing infrastructure where the chances of errors are quite large, then these services come in quite handy. Services like dashboard services, visualization services, so on and so forth, are all part of cloud computing partners, which are the third party companies that we have just referred to. And then comes cloud computing broker. A broker basically manages the cloud services and negotiates the relationship between the cloud providers and the cloud consumers. If you don't want to deal with all the hassle of getting the cloud computing companies understanding and comparing their services, and you want to offload that task to someone else, a broker is the person who you can contact for that. So these are the different roles that you should be aware of. Cloud computing building blocks. We'll take a look at what are the building blocks that allow us to build things in cloud computing. These are the bare minimum things that you need to understand to work with the cloud. Many services are built on top of these building blocks, so it's important to understand them. To understand cloud security, what is the most important thing to understand is that we understand the basic building blocks of cloud computing. These building blocks are nothing but the infrastructure services that make up the various cloud computing platforms. These platforms are built on top of these services. That's why they're called building blocks. Let's take a look at them one by one. So these are the five major building blocks: compute, storage, networking, databases, orchestration. Let's take a look at them one by one and how they are different from each other and what do they entail. The first one is compute. Compute services refer to the creation and management and usage of virtual servers, which we then use to perform computation tasks. These servers can then be used by users to offload some resource-intensive tasks, such as calculation or application deployment. An example of this is Amazon Web Services EC2 servers. EC2 stands for Elastic Compute Cloud. There are two C's after E, so that's why it's called EC2. It could have also been called ECC, but EC2 sounds better. What this basically means is that you can spin up your own virtual servers and you can either offload some important tasks, such as install a system software that you want to test out on a virtual server, so that even if the server gets destroyed, some things happen that make the hard drive corrupted, you don't really have to worry about it since it's a virtual server in the web. So anything that happens, not your concern. Similarly, if you want to offload some heavy computation tasks such as machine learning tasks and so on and so forth, but you want to do it on a raw virtual machine and want to go through the entire process, you can set up a computation server for that. Or if you want to set up the infrastructure to deploy an application, you can do so as well. Once you have created a virtual server, you specified the parameters that you want to create the virtual server with. That is the operating system you want, the version of the operating system, the drivers you want to install, the RAM, the hard disk, so on and so forth. Once that is done, then the server is yours. You log into it, you do whatever you want with it, then you log out with it. You shut down the server, you start the server, you manage everything about that server yourself. So these are the computation resources that you can use. Then comes storage. In cloud computing, storage is broken into two categories: block and object. First one is block storage, in which we get a chunk of storage space allocated to us, which is then partitioned into drives and managed by the operating system. This is called for example, it is the AWS Elastic Block Store. Uh, a good way of understanding is when you have worked with a hard drive yourself on an operating system where you partition it into simple drives, simple logical partitions, such as the C drive, the D drive, and the E drive in Windows. That's essentially how you can work with the AWS Block Store, Elastic Block Store. You can create a block of your own size, of your own specifications, and then you can use it to store some data. Second one is the object storage. Now, the object storage is a storage which abstracts the fine details of file storage and management. All these details are handled by your cloud service provider. All you have to do is upload and provide the parameters that provide the access to a file. So for instance, if you want a certain file to be accessed only via the internet, certain files to be accessed only via the file transmission protocol, and certain files to be inaccessible to anyone within a specified IP range. All of this is available using AWS S3 and other services like that. S3 stands for Simple Storage Service. Essentially, you can store all kinds of files and things as you would store inside uh, an entire hard drive. The only thing that's different is that how it is stored on a hard drive, how the hard drive is managed, all of those concerns are not yours. You just need to add these things on a particular storage bucket that you create, and that's about it. You don't have to worry about much else. Then comes networking. In cloud computing, networks allow users to connect several other systems together in the cloud. If you have two servers and you want them to be able to connect to each other and have some sort of back and forth in a secure environment, networking is something that is needed then. Networks in cloud are highly virtualized to provide high degree of flexibility in designing the networks to suit their own unique business requirements. So, for instance, if you're working on in an organization where you have come up with a very unique and a very different kind of a structure for your networks, but you want to connect different systems to each other with a lot of complexity, of course, these complexities cannot be expected to come out of box in any kind of cloud computing service, since these are specific to your own use case. Virtual networks allow you to do so. You can create your own routers, you can create your own systems, you can create your own layout, topology, so on and so forth. And all of that is done using cloud computing, which is very useful for you. Then comes databases. In cloud computing, users may choose to either build and manage their own database servers on top of existing infrastructure provided by cloud service providers. However, it is more practical to use a managed database server. A managed database server is basically where you don't have to worry about the database server's management yourself, but the server is managed by the cloud service provider. These are example in which you don't have to worry about you just have to specify the preferences such as the database vendor, server capacity, version of the software, etc. A good example of this is AWS's RDS. RDS stands for Relational Database Service. There are other kinds of services that provide non-relational databases. Even in AWS, there are services that can allow you to do so. Managed databases support various kinds of databases, which make them more flexible than self-managed database servers. So, for instance, if you have a managed database that can support various kinds of databases, and it's more flexible for you to use them than use separately managing the servers yourself. So again, depends on the use case, depends on the kind of control and flexibility that you want in your systems. If you want full control, then maybe creating your own server, adding your own software that you want to add, and then exposing it yourself is a choice to go with. However, if you want to be a little more pragmatic and you don't want the servers to work on their own, then maybe using a managed database service is a better option. It really depends on your use case. Finally, there's orchestration. Orchestration basically means when you're spinning up and managing cloud computing resources, it can get really, really difficult when you're doing it manually. For few services, it's fine, but for let's say that you have laid out an entire artificial structure there. You want to add three servers, you want to connect them using a virtual infrastructure or a virtual networking server. Then you want to connect all three of them through a load balancer, and I want to add a fourth server that is database that is connected to all three servers but is not accessible via the load balancer. This is a complicated structure, and you have to then go to dashboard, create the three servers, add them to a pool, then add a load balancer, connect them, add a database server, connect them. This is a lot of work. And we have only added three servers and one database server and one load balancer. Many real world applications have much more complicated servers, much more complicated layouts. And this is not even considering the fact that you also have to manage these servers, that in login, check the logs, figure out if something's wrong, so on and so forth. Cloud orchestration allows us to automate the workflow of creating managing cloud environments. Here you can specify I want three servers to be running all the time and four servers to be added at most when the traffic spikes. This will be done automatically by the cloud computing services, so you don't have to worry about it. Using cloud orchestration, we can quickly and easily create cloud resources, shift operations between environments, and perform various other administrative tasks. And we can automate a lot of these tasks ourselves. This is what makes it so important and so useful. So these are the five cloud building blocks that we have covered thus far. It is important to note that these are not the only services offered by cloud computing platforms. You can, however, build other services out of them. So that is to say that all the other services that are offered by cloud computing services are usually built on top of these services. So for instance, when you get another managed service, that is going to be an abstraction over how you can use these services. And that's really useful. Cloud reference architecture. Architecture is an important concept in cloud, but how do you architect an infrastructure or an application in cloud? Well, there are several reference architectures that you can take a look at in order to understand what are the good ways and the bad ways, what separate the good cloud architectures from bad architectures. So the International Organization for Standardization, also called ISO, publishes a cloud reference architecture in the document. The document name is ISO 17789. This document lays out common terminologies and frameworks that assists different parts of communication about their roles and responsibilities. So for instance, if you are a cloud broker, what are your responsibilities? If you're a cloud provider, what are your responsibilities? And if you're a cloud customer, what are your responsibilities? The contents of this document can be broken into distinct topics. These are the topics which include cloud computing activities, cloud service capabilities, deployment models, service categories, shared considerations, and emerging technologies. Let us take a look at them one by one and understand the basics of cloud reference architecture so that you can architect your own solutions when the need be. The first thing that we have to take a look at is cloud computing activities. So there are several kinds of activities which can be performed in the cloud computing environment, which are broken into 5 layers or 4 layers, but plus a set of functions that span across the layers. So these layers are user layer, access layer, service layer, resource layer, and then comes the multi-layer functions. This is the set of technologies that span across the layer and can be used by any layers out of the 4 that we have discussed thus far. Let's take a look at them one by one. The first one is the user layer. The user layer is the user interface through which a customer or cloud computing service customer interacts with the cloud services provided by the cloud computing service provider. Uh, Performs customer-related administrative tasks and monitors cloud services. So these includes dashboards, buttons, administrative interfaces where you can add and remove clusters, add them to create a new cluster group, add new servers, spin up new servers, all of that. That's the user layer. You can also think of it as the layer that your user interacts with. Any layer beneath that layer is not the concern of the user, and they shouldn't have access to that as well. Then comes the access layer. Access layer is actually one of the most important layers in the entire cloud computing activity stack. That's mainly because the access layer provides common interfaces for both manual and automated access to the capabilities available in the service layer. So what kind of user should be able to set the policies that tell it that tell the access layer how the entire system should function, what user should have access to what resources inside the service layer, and what services should be available to what user using the service layer. Access layer determines whether a user is authenticated and authorized to do a particular task or not. This is really an important task because in cloud, the access layer is very complicated. You not only just have username and password or roles, you also have permissions, responsibilities, how a particular permission can be added and removed. You have user roles, you have user groups. There's just a whole lot of things that you need to consider. So the access layer is actually very important in cloud computing. They provide the authorization needed for the users to access services inside the service layer. Then comes the service layer. The service layer contains the implementation of the services provided by a cloud service provider. The service layer contains the controls of these and the software components that implement the services. So, for instance, things such as Elastic Compute Cloud, which is the Amazon Web Services way of creating new servers, users can interact with the user interface to create and dispatch commands to create new servers. Then the entire process of finding a idle server, connecting the user to it, spinning up a virtualized server, adding things on top of that server, and then providing user access with that. All of that is done using the service layer. Service layer contains all the policies and the code that is needed for spinning up new services and assigning assigning accesses to the users. These services are not restricted to just spinning up servers. You can also spin up managed databases, deployment pipelines, and many other kinds of services available by a cloud service provider. Then comes the resource layer. This is where the resources or the bare metal resources reside. These include hardware such as servers, networking switches, routers, storage devices, software that runs on the hardware such as host operating systems, hypervisors, etc. So this is the lowest layer that you can go to. This is the actual data center where the entire servers are hosted. These data centers have a lot of resources that need to be connected in a specific way for the systems to work. The software also comes under the resource layer because it is managed by the people at the data center. Things such as operating systems, hypervisors, patches, so on and so forth. So this is what the four layers that we need to be need to be aware of are. There's also another group of technologies that spans across the layer called the multi-layer functions. Multi-layer functions include functional components that interact with functional components of all the above four layers. They provide supporting capabilities such as integration capabilities, development support capabilities, so on and so forth. These are mainly used by the layers in themselves. So for instance, if one layer wants to integrate with another layer or a third party plugin, multi-layer functions contain all the services and code that needs to perform the tasks. Integration, development support, so on and so forth, all is done using multi-layer functions, and they can be accessed by any layer, any of the four layers that we have discussed thus far. Now comes cloud service capabilities. What are the different kinds of services that cloud can tender to? Let's take a look at them one by one. There are different types of capabilities that we can acquire using cloud computing services, such as application capability types, platform capability types, and infrastructure capability types. Let's understand them one by one. The first one is application capability types. There are several applications that are offered to be used by cloud service providers, such as the Outlook Mail, Google Drive, Gmail. These are all applications that are running in the cloud that use cloud technologies that are served to you via the internet. So these are the application capability types that you can use for your own benefit. Then comes platform capability types. These are the cloud services that offer us pre-configured platforms to deploy and manage our own applications, such as AWS Elastic Beanstalk. If you have ever used AWS EBS, EBS stands for Elastic Beanstalk. The reason why it is so popular is because it provides a pre-configured hosting environment. All you have to do is specify the requirements that you need to have for a platform, such as the software, the operating system, the version of the software that you want to be installed, the configuration that you need for that software, and that's about it. You can also specify the deployment steps, such as firstly copy all the code in one particular directory, then run these tests. If the tests pass, then run the application and deploy it. And after deploying, send an email to me saying that the deployment was successful, so on and so forth. Finally comes infrastructure capability types. These are cloud services that offer us basic infrastructure tools such as servers, storage drives, and so on and so forth, which we can configure and use according to our own needs. A thing to understand here is that even though these capability types are really, really useful, it can be a bit cumbersome to just use them given the fact that higher level technologies are available. So for example, if you're trying to deploy an application, you shouldn't be meddling with creating servers, creating database servers, installing database softwares, connecting them using virtual environments, and so on and so forth. You can do it, but it's just an exercise in futility, mainly because there are already platforms available for you to do so, such as the ones that we have discussed thus far, which include an AWS Elastic Beanstalk. Similarly, if you want to create an application that can handle your emails and storage capabilities, then Google Drive, Gmail, Outlook, Mail, so on and so forth, OneDrive, they're all available for you to use. So instead of buying infrastructure such as the servers, storage systems, and so on and so forth, and creating your own services, it's just not something you should do unless you need certain capabilities that are not provided by any of the above mentioned services. Now comes deployment models. There are different ways of deploying different kinds of applications. What are they and what do they mean? Let's take a look at them. So there are four cloud deployment models. These are the four kinds of cloud that is available for you to deploy your applications on: private cloud, public cloud, hybrid cloud, and community cloud. Let's take a look at them one by one. First comes private cloud. As the name entails, it is the cloud computing infrastructure created for an organization and created by or for an organization for their own use. So it could be that the organization has the experience and have created the environment for themselves, cloud computing infrastructure for themselves, by buying server and setting up an on-premise cloud computing net environment. Or it could be that they have hired some cloud computing consultants who bought the resources and were given the budget to do so, and then they created the entire cloud computing facility for the organization. In either case, it's only the people of the organization and specific people of the organization that have access to these software and hardware components. And you can use it yourself only if you're part of that organization. Then comes public cloud. Organizations build massive infrastructure in their data centers and allow users to pay for and use the resources they need using virtualization. This is the easiest one to understand, mainly because this is the one that people use most of the time. Uh, Services such as Amazon Web Services, Azure Cloud Services, Google Cloud Platform, IBM Cloud, Oracle Cloud, so on and so forth, are all just extensions of this. They fall under the public cloud category because they allow you to acquire resources and then pay for the resources that you have acquired and for the time that you use. Then comes hybrid cloud. Organizations may end up using private cloud for data sensitive operations and public cloud for operations that do not have these concerns. So it could be a mixture of both public and private cloud. Some data that's very, very sensitive to the organization and they do not want it to be exposed in the public cloud platform. Even though it may be secure, they just don't want it to be accessible over the public internet. They just want it to be inside the privacy of their own premises. In cases like this, they can choose to store the data that they have in the private cloud that they have created, and in the public cloud, they can host the applications that access the data, and that's about it. Then comes community cloud. Creating a cloud computing environment or cloud computing infrastructure can be a bit expensive. To overcome this challenge, what happens is many organizations form a consortium or a group basically to build the cloud computing infrastructure, which will then be available and be used only by the members of that consortium. So if, for instance, 3 or 4 companies come together and pool some money to build a cloud computing infrastructure, then they can all have their share of services inside the cloud computing infrastructure that they have created. Also, managing that infrastructure is going to be their own responsibility, but it's going to be their own private cloud, but not essentially just their own. It's going to be the private cloud for the entire consortium or group of organizations who have paid for it. Then comes service categories. Let's take a look at them one by one. There are 3 service categories that are available for us. First one is SaaS. SaaS stands for Software as a Service. Software as a Service basically means that using cloud computing environment, you are being given a software that you can use for your own use cases, such as Gmail, Google Drive, Outlook Mail, Yahoo Mail, OneDrive, and Dropbox, so on and so forth. These are called software as a service because you are being given a software over the internet. Even things such as Google Docs and other services such as that are software as a service, where they are providing you services over the internet that are backed by cloud computing resources. They are very popular and they are used mainly by people who just want access to some resources and don't want to fiddle with the application code. Then comes platform as a service. Users can get managed platforms where they can deploy and run their applications without developers worrying about server management. If you're an application developer and you want to deploy your application but don't want to deal with the uh, entire server management issues, such as installing new software, setting up patches, setting up cron jobs to delete the files that are no longer needed, setting up firewalls, policies, so on and so forth, Platform as a Service provides this capability. Heroku is by far one of the most popular platform as a service providers, where you just specify the application based platform that you'll be developing on, such as if you're developing a Ruby on Rails application, PHP application, Node.js application, then you can specify the build steps, which essentially just let you determine how exactly do you get from the code that you have to the deployed production ready application. What steps are there? Do you need to remove certain files? Do you need to remove certain do you need to add certain environment variables, so on and so forth? This is all done using platform as a service, an example of which is Heroku. Then there's infrastructure as a service, or IaaS, which is essentially just services that the users can purchase use basic cloud computing resources for their own needs, such as the servers using EC2, databases using RDS, orchestration using any of the orchestration tools that are available in the cloud, and so on and so forth. Um, these are used to essentially just work with the bare bones infrastructure services to set up your own infrastructure. Maybe you just need to do a couple of things on a particular machine and you need access to that. Infrastructure as a service is a great way of doing that. Then comes shared considerations. What are the things that are that different cloud computing providers, consumers, brokers, and all need to be considering when they are working with the cloud? There are several cross-cutting or shared considerations that are addressed in the cloud reference architectures. These are as mentioned below. Let us take a look at them one by one. First one is interoperability. Interoperability is the ability of two or more cloud services to work well with each other and exchange information. If you have a web server connected to a database managed database server, you want an application to be running on the web server, but you want that web server's application to have access to the database running in the database server. If they don't have that access, then the application that you're running will have to do some tricks in order to get data from the database server, and that won't be scalable. So interoperability is that multiple services working well with each other so that you can create an entire cloud computing application or infrastructure stack. Then comes portability. It is the ability to move data and operations from one cloud service provider to another using minimal disruption. To give you an example, if you are using Azure Cloud Services and you certainly determine that this is no longer working for you, the price is too high, or maybe the services are not as good as they were promised.
Just a quick info, guys. Intellipaat provides CISSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
You should be able to move your virtual machines, your data, and your applications or the processes to another cloud computing provider such as Google Cloud Platform or Amazon Web Services, so on and so forth. Reversibility is the extent to which cloud-based applications are designed so that they can be moved to other cloud providers or environments. This is really one of the most useful things to understand when you are working with cloud computing environments.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Reversibility is basically how much of the data that can you move from one cloud provider to other cloud provider or one environment to another environment. Then comes availability, that determines how much uptime can be provided by a cloud service. Basically, how much during an entire year, let's say 365 days, how much of the time is how much for how long is the service going to be down, so that you can essentially notify your users saying that there's going to be some maintenance in our infrastructure, our services are going to be halted in that time period. We are extremely sorry about that, but that needs to be done. How much of that is tolerated? That is what availability means. Security is also something that's very important. Cloud security involves concepts such as confidentiality, integrity, and availability. The reason why security is so important is because when you're using cloud computing security protocols, you need to maintain the data integrity, data confidentiality, and the availability of resources, as we have discussed thus far. Confidentiality basically means that the data is not accessed by anyone who should not have access to it, who are unauthorized. Integrity means that the data that was stored in your cloud computing environment doesn't automatically get changed because of some issue in the data centers or unauthorized access. Availability means that even if the servers go down, there should still be other servers running as backup servers so that I can access the data anytime I want. Then comes privacy. Privacy refers to the protection of data and activities from unauthorized access. This is a shared consideration because there are several things that the cloud computing provider can do to make your data private. Similarly, you can do several steps to improve the privacy of your applications. Resiliency is the ability of cloud services to recover from failures and errors. What if an entire data center goes down? How is your application going to manage if an entire data center goes down? Many times, what people do is that they have several servers running in a pool of servers, and these servers are running in geographically independent location. One is running in a data center in US, other one is running in India. So, for instance, if the US data center goes completely down, the data center in India is still running, so the traffic will be moved to that one. Then comes performance. Performance is the volume of demand for resources that can be handled. If I give you some load of traffic, can you handle it? What is the performance metric for that? What is the throughput that you can provide? So on and so forth. Several things that many of the people in several roles can do in order to increase the performance or decrease the performance, such as use caching, use databases with low latencies, use cloud content delivery networks, so on and so forth. Then there's governance, which ensures effective oversight of cloud usage. When you are providing a cloud, when you are an organization who have signed up for cloud services, you need to be able to govern the entire application stack and understand how the governance is affecting your applications, how you are creating applications, how that is going to be affected by the governance. Then comes maintenance. Maintenance in cloud refers to the activities such as installing patches, upgrading systems, which may lead to some downtime. So how do you maintain the systems? Who has the distinction of maintaining the systems? How do you upgrade your systems? Is this automated? Is this automated but triggered by some user interaction, or is it manual? And how do you do this? All of this needs to be understood by the cloud computing providers as well as the customers, and so on and so forth. Then comes versioning, which is done to keep older versions of data available in the cloud to determine the stream of changes that led to the current state. It could be that some data does not need versioning. For instance, database systems, unless they are temporal databases, you may not need how the data changed from one step to another. However, things such as files and sheets and so on and so forth need this versioning capability. It basically means that if tomorrow one user logs in, makes some changes, and then leaves, the other user should be able to see what the data was before the change, what the data is after that change. Then there's service levels, which determines the values of the metrics that the cloud service needs to provide, such as availability, performance, etc. Cloud service providers need to understand what are the requirements of a user, how much availability, how much uptime, what performance are they expecting. SLA, which also stands for Service Level Agreements, is an agreement or a bond for performance negotiated between cloud service providers and the client, where you determine these are the parameters that we want in our application or in our infrastructure, and can your services determine these, or can your services provide us these requirements? If so, then the agreement is signed, and then the cloud computing provider is bound to follow those metrics and provide the services. Auditability is used to verify the cloud service providers are fulfilling their obligations that were determined in the SLA. For instance, what was the uptime? How many times did the servers go down? How many times was there a data breach or data loss? What was the performance metrics? What was the uptime? So on and so forth. Finally comes regulations. It provides, if cloud service providers are serving customers that are under certain regulations, then their services need to be met with these regulations. For instance, governmental data access regulations in certain countries. Countries such as China have regulations which provides them access to all kind of data that is stored inside servers or data centers that are inside China. So these regulations need to be taken care of. If you're trying to deploy an application and you deploy to a governmentally regulated data center location, then your data can be accessed by the government of that country. Now let's take a look at certain emerging technologies. There are several emerging technologies in the cloud, such as mentioned below. Let us take a look at them one by one. Hopefully you have heard of some of these, but you may not know what they are and how they are used. The first one is machine learning. It is a technique that allows machines to gain new abilities by learning from the already existing datasets. Machine learning is very popular nowadays, and many applications use machine learning. Even your mobile phones have applications that use machine learning, such as Google Lens, and so on and so forth. Machine learning is heavily used in recommendation engines as well, such as Netflix, Amazon, Flipkart, and so on. Then there's blockchain. Blockchain is a distributed data store that is used as a decentralized ledger, which cannot be tampered with and provides high level of integrity. This is especially useful for financial applications where records are kept about the transmission of data from one person to another person, transmission of money from one person to another person. People should not be able to essentially work with it and make any changes. So, for instance, if John sends his friend Brian $1,000, then that should not be tampered with, and there are several policies that are inside the blockchain consumer systems. One of the most famous uses of blockchain is in cryptocurrencies, since it's a distributed ledger, issuing new cryptocurrencies to new people, and then transmission of those cryptocurrencies from one person to another is done on blockchain, such as Bitcoin. Then there's IoT. IoT is a fairly new technology. It is a technique that is used for connecting non-traditional devices in networking, data collection, analysis, monitoring, and control of these devices. IoT stands for Internet of Things. There are several smart devices that use IoT, such as Amazon Echo, Google Home, smart fridges, so on and so forth. Then comes containers. Before containers and before virtualization was anything that we could have used, we had to create an entire server, use all the resources of that server instead of breaking even though our application may not require those resources, we still had to use them. When virtualization came along, you can break a server, a very powerful server, into simple, smaller logical servers that are using the capabilities that are inside that server. So, for instance, if a server has, let's say, 500 exabytes of data storage capabilities, then that will be something that you need to use entirely. With virtualization, you can break that up into 5 different applications. All of them use 100 exabytes of data. So containers are essentially just a step forward in this direction, in which we create lightweight ways of packaging up our entire application so that it is portable across hardware platforms. If I have an application that needs to be deployed on a Linux system, I just specify the steps that need to be followed. And once those steps are followed, then whatever environment I have deployed it on, these steps will be followed and my application will be running. Containers are very popular in microservice-based architectures and are used heavily by companies such as Netflix. Finally, there's cloud computing. Cloud computing is an emerging technology that allows substituting a traditional bits or binary digits with quantum bits or qubits as they're called for faster processing. Cloud computing is usually used only for research purposes, mainly because the technology is still being worked on. Although Google and Amazon Web Services have shown how cloud computing of quantum computing is quite superior to traditional ways of computing, but it could be a little difficult to understand how quantum computing works in general unless you have a good understanding of quantum physics as well. So just keep that in mind when you try using quantum computing. This is why usually researchers use quantum computing, because they have a deep understanding of the concepts. Cloud computing security concepts. So there are 6 key security concepts relevant to cloud computing. These are cryptography, access control, data and media sanitization, network security, virtualization security, and then there are certain common threats that we need to be aware of. Let's take a look at them one by one. First one is cryptography. Cryptography is a very famous concept, not just in cloud, but any kind of security that you are into. In cloud computing, cryptography plays a major role in data security. Some important aspects to consider are encryption, key management, data in motion, and at rest. Let's take a look at them one by one. Encryption is the process of encoding information to make it impossible to understand the encoded text. This text is encoded using a special data key called key, which is what is used to convert it back from the original to the original information, which is called decryption. Basically, imagine you have some sensitive information and you want it to be sent to a person, let's say your friend, but you do not want the people who are in the process of transmitting the data from one place to another to be able to open it and then view the information. In cases like this, what you do is you use encryption, in which you use a process to convert the data that is understandable into some format that is ununderstandable, that you can't understand what it's inside, it's completely gibberish. That process is called encryption, and there's a special finite bit of data called key that is used inside for that process. If the user if the person on the other end has access to that key, only then can they decipher the data. Deciphering basically means converting the encrypted data to its original format. So if your user has the access to the key, if your friend has access to the key, then they can take a look at the gibberish that was sent by you and convert it back to the original data and understand its meaning. Key management refers to managing of cryptographic keys within the system that uses cryptography. It deals with generating, exchanging, storing, and replacing keys at the user level. Essentially, key management allows you to generate new keys and use them, or replace old keys and if they are no longer needed. This is a complicated process, and there are several systems that do it for you. Then there is data in motion and at rest. Depending on how the data is being used, different cloud computing providers determine different security policies. Data in motion basically means data that is being transmitted over the internet or is being moved from one server to another. Data at rest basically means it is stored and is not being used by anyone. Both of them have different ways of being intercepted, and unauthorized access can be gained. So you need to understand how to encrypt and then send the data. Data at rest is not really that important or not really that complicated, mainly because you can just encrypt the data, manage the key in some way or the other, and then keep the encrypted data on the disks. Data at rest, however, is a little special because even though the data is encrypted, when it is being transmitted from one location to another over the internet, some people can eavesdrop or intercept the data and understand and take a look at what it actually entails. To overcome this, using HTTPS and SSL based connections that are encrypted over the network are going to be really useful. Let's take a look at security concept called access control. Access control is a major source of security flaws in cloud computing. Access control refers to granting and revoking user authorizations over some data or services. In cloud computing, access control can be managed in several ways. However, in real-world practice, organizations tend to manage access control locally due to its importance to organizational informational security. This is done so that the organizations have full control over granting and revoking access to cloud computing services and data. To give you an example, let's say that you are an organization who have bought services from Amazon Web Services. You now have the access of creating new cloud computing credentials, giving it to the users, and then essentially adding and removing permissions. So if you're giving some cloud computing credentials to a database administrator, all they should be able to do is they should have full access over the database. They should not have full access over any other cloud computing services such as servers or distributed environments, so on and so forth. Similarly, an application developer should only have read access and write access to a database, and thus should not have access to the database in the way that they can delete the data that they should not have access to, and so on and so forth. So these are kind of the ways that you can take a look at access control. Usually organizations like to have the access control management at their own level so that they can add and remove permissions from a particular user, they can apply permissions to a particular user group, so on and so forth. And there are dedicated services on cloud computing platforms such as identity and access management services that allow you to do so. Now let's take a look at data and media sanitization. Data and media sanitization refers to dealing with encrypted data when being erased, changed, or overwritten. When dealing with secure and encrypted data, there are several concerns that we need to be aware of. For example, we may have to delete or overwrite a small piece of data that is encrypted using a key. If the key is only used for that data, then it can be removed quite easily and there won't be much hassle about it. But for security purposes, all cryptographically secure data should be deleted or overwritten in such a way that it cannot be recovered successfully. Cloud computing providers need to take a special care for that. For instance, if you're using a virtual disk, for example, and you have stored some sensitive information, then you delete the data and then you delete the disk. It is recommended that you always delete a virtual disk once you are done with the sensitive data that you have, and you also delete the data for security purposes. After deleting the disk, there should be no way of recovering it. Make sure that you have not taken any backups or snapshots that you do forget to delete. And that's the things that you need to do on your end. On cloud computer or providers, and they should be deleting the data as they're getting it. They should not be storing it and then telling that that was deleted. Then there's network security, which is another concept in cloud computing. Network security allows us to impose restrictions on incoming and outgoing traffic in a virtual or real network. Cloud computing allows us to create our own networks using virtual networks. So many cloud services provide several tools which can be used to better protect our virtual networks in the cloud. For example, we can use network security groups for applying specific security rules on a group of resources. Firewalls should be properly used to prevent unauthorized access to our networks. Firewalls are really underused in many of the cloud computing networks that people create. So you can set up rules that these are the services that should have access to this particular server. These are the network or the IP ranges that should have access, and these are the IP addresses that should not have access to it. You should also set security rules only to grant networking access to resources that need them. That is also called granting the minimal required access. Only grant access that is absolutely needed. So for instance, if an application developer only needs access to read the data from a database and not be able to write to it, do not provide access to write to the database, only provide access to read from the database. Now let's take a look at virtualization security. Virtualization comes with its own set of security concerns, as virtualization deals with hypervisors and operating systems, host operating systems, as well as we need to be cognizant of several flaws in their security as well. A virtual machine attached to a hypervisor is affected when the host hypervisor has been compromised. So for instance, if I have a virtual machine running on a Windows system, if the Windows system that I am using is compromised, then the person who has access to that operating system may also have access to data and resources running inside my operating system in the virtual environment. So that needs to be understood correctly. Even when we are using containers, you have to be cognizant of the security concerns. It is not that since containers are a little lightweight version of virtualized environment, we should be able to understand that we are not completely letting go of security concerns there as well. Common virtualization security threats include denial of service attacks, which are also called DOS, host traffic interception, and VM jumping. Now let's take a look at certain common threats in cloud computing. The Cloud Security Alliance has defined 9 of the most common security threats in cloud computing. They are also called the Notorious 9 by the CSA. These are the ones that we have mentioned below. Let's take a look at them one by one. The first one is data breach. In simple terms, data breach refers to the situation where a user or a person gains access to unauthorized information that they should not have access to. So for instance, when the data is leaked on the internet, such as some records, some Excel file, some database files, so on and so forth, and people who should not have access to the information gain access to it, that's what's not useful and is called data breach. Then there's data loss, which means that people end up losing their personal or valuable data on the cloud computing platforms because various reasons. And if you have not created any backup for the data, then the permanent loss of your data is imminent. So to overcome this, usually create good backup strategies, backup every 10 hours, every 12 hours, every day, so on and so forth. Then comes insecure interfaces. We may expose several APIs to allow integration with customers on-premise system, and therefore we need to have proper authentication and authorization mechanism in place. If we have certain APIs that are interacting with some off-site servers or off-site systems, then proper policies should be set up and how the authorization and authentication systems are going to intervene if unauthorized access takes place. Account and service hijack. Attack methods such as phishing, fraud, exploitation are used for gaining access to user credentials, and therefore their accounts become compromised. there should be proper policies in place to determine the authentication of a user, such as two-factor authentication or multi-factor authentication, so that when the user tries to log into their system, they need to have access to a certain device from which they can give us some code and determine whether they are who they are. And the hacker should not be able to use their account even though he or she may have their username and password. Then comes DDoS and DOS attacks. They stand for denial of service and distributed denial of service attacks. Basically, a large volume of traffic is sent to your resources, so in order to get them congested and freeze them, and other legitimate users are not going to be able to access these resources. Give you an example. Let's say that you have a website that is running on a web server, and a large volume of users start requesting your web server can't handle and becomes overwhelmed with the number of response requests, and the people who should be able to access the resources are not gaining access to that. DOS stands for denial of service, in which one particular server or one particular network of computers are sending the request. The distributed denial of service means not just one person or one network, but people from different geographical location are sending those requests, and the large volume of requests is being received by a server. Many technologies have come to determine whether a denial of service attack or distributed denial of service attack is taking place by analyzing the IP address, geographical location of the networks that are requests that are coming in, so on and so forth. Then comes malicious insiders. A malicious insider is a current or former employee who has or had authorized access to organization's network, system, or data and intentionally uses or misuses that access to negatively affect its security. If you are working on a private cloud system and an organization lets go of an employee who still has access to the information, that they can log into your system and can perform certain tasks that they shouldn't really be able to. Then there's abuse of cloud-based services. Many malicious users can end up using cloud-based services, spin up their own servers, create a cluster of servers, and launch a denial of service or distributed denial of service attacks to some other user, or can use brute force attacks to guess someone else's user credentials or password. Then there's shared technology vulnerability. Since cloud providers use virtualization, if any host system becomes compromised, then multiple virtual systems become compromised as well. Good hypervisor security and host operating system security needs to be in place in order to prevent against these kinds of vulnerabilities. Finally comes insufficient due diligence. If an organization using cloud computing services does not take care of the security concerns themselves, or are not cognizant of the security concerns that they should be taking care of on their end, using techniques such as encryption, security monitoring, etc., then an attacker could easily exploit those loopholes if they are aware of it. Secure cloud computing design principles. There are 5 key principles relevant to secure cloud computing. These are security lifecycle, business continuity and disaster recovery planning, cost-benefit analysis, functional security requirements, and security considerations. Let's take a look at the first one, which is cloud secure data lifecycle. And the secure data lifecycle has 6 key stages in cloud data lifecycles. These are create, store, use, share, archive, and destroy. Let us understand them one by one. In creation, which is the first stage, the data is being created by one or many cloud services, such as log being created. When you add some data to a spreadsheet, that data is being stored somewhere, and that's what the cloud security lifecycle is talking about. Then comes store, which allows you to store the data that is that after the data is created. So once the data is created and the user clicks submit or some action takes place, that data is sent to a web server that stores it in some place. The storage can be taken place at a database, a file system, an object store, wherever it can be. It is in this stage, data is at rest and is stored in cloud computing platform. Then there's the use stage, in which the stored data is then accessed once again by the user, such as a to-do list that was saved is now being retrieved by a cloud computing service provider. Then comes share. Many times data is shared among different people with different levels of authorization. For instance, when you're using Google Drive, you can share the files with different people in your own organization with a specific email, or with everyone that has access to it. You are the person who sets the authorization levels and the policies that need to be done with that. So that's basically what share means. Different people should have different authorization policies attached to different files. Then comes archiving. In this stage, the data is used or accessed very few times, and latency can be tolerated for lower cost. So if you are storing some data that you are going to access once a year or twice a year, then you don't really need to store it in the hot tier of the data store, mainly because it's going to cost you a lot more and you're not accessing it that much. The times that you do access it, the access is going to be a little slower than the usual time that it takes to access the data, but that should be okay. Then comes destroy. Finally, data is destroyed and should not be recoverable from these operations where data is stored. So once the data is destroyed, it should be removed completely and should not be recoverable from any of the places where the data was stored. Preferably, we could, if it's stored inside a virtual environment, that virtual environment should be destroyed and no backups should be kept of that virtual environment to reduce or remove the chances of recovering the data. Then comes disaster recovery and business continuity planning. In cloud computing, two major design concerns with respect to data are disaster recovery and business continuity.
Just a quick info, guys. Test your knowledge of cybersecurity. Which one of the following is a type of antivirus program? A. Quick Heal. B. Kaspersky. C. McAfee. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Disaster recovery is essentially the plan of action that needs to be implemented when a disaster strikes, such as a loss of data, data integrity violation, someone deletes the data, someone changes the data, data center goes down. Could be multiple reasons, could be a lot of reasons that these uh, disasters strike. So what exactly do we do when something like this happens? There's also business continuity, which basically means that once the data is lost, how do our applications, how do our business processes keep on functioning? It is the objective of disaster recovery systems to ensure that business continuity and prevents organization from suffering substantial damage in the forms of losses of revenue, reputation, market share, etc. An example of this would be, let's say that you have a large database with thousands or millions of records and you delete it and the database gets deleted somehow. What steps can we take, because this kind of database takes time to restore and in that time we may be suffering huge losses? Are there any backups that are a little outdated and may not have some of the information but can keep the application running for majority of the people? Then that should be done. These kinds of processes need to be determined in this stage. For business continuity, there are two major success factors. Firstly is understanding what responsibilities are yours and which are the responsibility of cloud service providers, such as backing up the data can be your responsibility, setting up the backing up policies can be your responsibility, but the actual process of backing up and dealing with failures is the capability, it determines the capability of a cloud service provider and it's the responsibility of a cloud service provider. And we need to clearly state and prove the cloud service level agreement components are covered and their depth coverage. So, for instance, if you have a particular backup policy set and that was not something that was run by the cloud service provider. For instance, you want the data to be backed up every 8 hours, but the data was not backed up for 2 days, then that's a violation of service level agreement, and the cloud service provider is liable then to pay you some kind of a damage recovery fee. But that's all covered in a service level agreement that you have signed with the cloud computing provider. Then there's cost benefit analysis. Cost benefit analysis plays a major role in deciding the security concerns and the solution. Cost benefit analysis allows us to compare different platforms on the basis of expenditure needed for a service that with the value provided by the service. Cost has often been called the key driver for whether an organization will adopt a cloud computing technology in some capacity. Think of it this way. If you want to protect your systems from certain cloud computing threats, you need to have certain capital with you in order to ensure those things. For instance, backing up data takes some time and money. Buying server softwares and patches that prevent certain security loopholes also take some money. And if you don't have that kind of money, then maybe you won't invest in all of those. Then you need to weigh the systems, the pros and cons, and understand what kind of threats are more imminent to you and pay for reducing those threats or removing those threats. Different cloud computing solutions provide different services at different price rates, and they need to be thought of thoroughly before we choose the best option. Then comes the functional security requirements. Functional security requirements in clouds are the portability, interoperability, and vendor lock-in. Portability, as we have already discussed, is the easy and secure moving of data from one service to another service. If I have a server and a database and both need to have access to each other, then are they able to do it? That's essentially portability. If I want to move my data from one server to another server of another service provider, such as from AWS to Google Cloud Platform, am I able to do it, and with how much effort is it doable? Then comes interoperability, which basically means multiple services are being able to access and manipulate data securely. I have 3 servers and 2 database servers. Application servers are able to take a look at the data inside an database server and are able to access it and modify it if they need to. Finally, vendor lock-in, moving encrypted data from one cloud service provider to another cloud service provider securely. Now, if vendor lock-in is not taken care of, then you get locked into a vendor's services, and now you are not able to move data from one service provider to another. So this kills the portability and interoperability of the entire server, and you can only store data in a particular service, and that service only can use it. That is going to be really, really difficult and really problematic. So you need to understand how to deal with that as well. Now comes cloud categories for security considerations. These are the 3 kinds of security considerations that you need to be aware of. Depending on the service models that you have, which are the ones that we have discussed below, you have different security concerns. The software as a service, the security concerns that we have mentioned are: is data being encrypted and when it is being transmitted over the network? Are we protecting our applications from common attacks such as SQL injection, cross-site scripting, cross-site request forgery, so on and so forth? Are proper measures in place in case of application security being compromised? All of these things need to be thought of when we're building a software as a service for our users to be able to use. For platform as a service, are we using the latest version of a platform service? Are the softwares that are being used by the deployment system updated, and are they containing the latest security patches? And is the deployment process using the latest security standards such as HTTPS and so on and so forth? It is to be noted that these are not the only security concerns that you need to be worried about, but these are the most prevalent ones. You can take a look at more security concerns and how to mitigate them at your own pace. Then comes infrastructure as a service. Are all the networks properly configured? Are proper backup and replication strategies in place? And do the host machines have the latest operating systems and security patches installed in them? These are some of the things that you need to be worried about. Network configuration for infrastructure services, software patches for platform services, and security threats for software as a service are some of the things that you should be aware of when you're trying to build these kinds of systems. These are the kind of security requirements that you need to take a look at. These are only just pointing you in the correct direction, because depending on your security environment and depending on your requirements, you may have different security concerns as well. But these are the ones that you should be aware of in any case. Finally, let us take a look at evaluating cloud service providers. There are 3 major ways that you can evaluate cloud service providers. These are not the only ways. These are ISO 27017, PCI DSS, and government security standards. Now, these evaluation criteria are from a cloud security and compliance perspective. There may be other criteria such as price, etc., that you need to be considering when you're evaluating the cloud service provider. But we are evaluating the security concerns. So the ISO 27017 is a document that was published by the International Standards of Organization, in International Organization of Standardization, and provides standard guidance for implementing security concerns in the cloud. Many cloud computing providers offer services that comply with these standards. If you wish to know which services providers are compliant with these services, then you need to take a look at the offerings and the descriptions. For example, the Google Cloud Platform, also called GCP, offers several services that comply to the standards. So for instance, if you are someone who wants to gain access to cloud computing service that is complying to the standards laid out in ISO 27017, in Google Cloud Platform, there are several services that are certified by ISO as they are being following these guidelines. You can also take a look at other cloud service providers and whether they follow these standards or not. Then there's PCI DSS. It stands for Payment Card Industry Data Security Standard that needs to be adhered to by any organization involved in storage, processing, and transmission of credit card information. If you're someone who is dealing with credit card information or sensitive financial information about a person, then that needs to be handled by you. If you handle the credit card system and payment system, if you do not handle the credit card system and payment system on your own, then you do not need to adhere to these standards. Then a large fine can be levied against you. So if you do handle the credit card payments and security standards are not being followed, a huge fine is going to be paid by you once that gets discovered. The standard is only needed if you are involved in the processing of credit card payments. To give you an example, if you are someone who do not use these services, for instance, your application has nothing to do with credit card services, then maybe these services are not for you to adhere to. Most services differ to the other services for this, such as PayPal, Stripe, etc. PayPal and Stripe and other services, they deal with the managing and processing of data and information related to credit card, UPI payments, internet service provider, internet banking credentials, so on and so forth. So you don't have to be worried about how these things are being handled in the backend. All you have to do is send a request describing the money amount that you need, the user that needs to send this amount, and the account that it needs to be sent to. Then there are government and security standards. Different government agencies are subject to different security standards which need to be adhered to by a cloud provider. For example, if you're involved in any project dealing with the US government, then there are several standards that you need to adhere to and certifications that you need to get. The most common one is the CC certification, called the Common Criteria Certification. It is to be adhered to and gotten by all the hardware and software products. And Federal Information Processing 1402, which is also called FIPS 1402, is another certification that certifies the cryptographic security in government services. So if you're trying to build some software or work with some agencies that build software for the US government, then these are two of the certifications that you need to gain in order to essentially consider your application secure by their standards. Cloud data concepts. Here we'll try and understand what are the important basic concepts that we need to understand when we are trying to talk about cloud data. So in cloud data, there are two main concepts you should understand. These are the data lifecycle and data dispersion. Both of them hold special meaning across cloud data, and they are especially useful when we're trying to discuss security in cloud of data. So let's try and understand them one by one. The first one is the data lifecycle. The Cloud Security Alliance conceptualizes data lifecycle as having 6 states in the cloud. Obviously, there are many other organizations that may describe cloud data as being having cloud data having multiple stages. Some would have 5 stages, some would have 7 stages, and anything in between. The point here is that the Cloud Security Alliance has created these 6 steps so that it's easy for you to determine policies for data security in each one of them. Let us understand them one by one. The first one is create. The create data security stage is, I think, one of the most intuitive one, mainly because the name itself maps onto the concept that we're trying to tackle, which is in the state, an organization generates data either directly on the cloud or in an on-premise system, which can then be moved to the cloud. So think about a scenario where you're using a cloud software such as Google Docs or Outlook or any other kind of service that you are using in order to create some data, such as using a spreadsheet, creating a document, which could be a Word document, a presentation, whatever it might be.
Just a quick info, guys. Intellipaat provides CISSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
There you are generating data. Now, in the case that we have discussed just now, using cloud software, you're creating data on the cloud itself. On the other hand, it could be that you're using an offline software such as Microsoft Word, Office, you have created some spreadsheets and all of that. And now you want that to be imported into the cloud, either on the Google Drive or into the Google Docs. In any case, what you do is you get the data and you import it on the cloud. The data is created on premise, but you want that to be uploaded to the cloud, and that's one way of doing it. Depending on the volume of the data, there are several other options available. There are data that's in terabytes, so uploading it over the internet could take a long time. In cases like these, new technologies have come up, such as boxes of data moving devices that are transported to your location, from where you can copy the data and then send it back to be uploaded onto the cloud. The important thing to understand here is that if the data is being moved from on-premise to the cloud system, it needed to be moved securely, because until it reaches the cloud platform, security is on you. So make sure that you are using an HTTPS connection. Make sure that you are not using it on a public public internet service, such as a public Wi-Fi or something like that. Do not use on public networks, because there is a chance that someone could listen to or essentially intercept the data that is being transmitted from your end to the other end. But in any case, it's a good way to think about security in the creation phase. Then comes storing. Data is moved to a storage repository for retention and later use. Now, it has happened to all of us that we have created data and then we want to store it, either temporarily or for a long period of time. In cases like this, cloud services provide multiple storage options, and we'll take a look at that later in the presentation. But here what we have to understand is that during the storage phase, the data needs to be secured. Cloud computing providers take numerous steps to do so, but in our case, we could also do a bit of due diligence and set up encryption policies, so that when the data is, even if the data breach is there and some malicious user gets access to the data, they don't know what the data stands for. They can't intercept it, they can't unencrypt it, they can't decrypt it, they don't have any idea of what the information that is held inside the data is all about. It could only be accessed by people who have a valid key to decrypt the data. So that's on your part, but that's the storage stage. Then comes the use stage. Data in this stage is in active use and is being used and viewed and processed by systems. Again, there needs to be proper encryption and decryption systems in place. When the data is being accessed and being modified by the users, it should be decrypted, and once the decryption is complete and then the processes are complete, data is modified, new data is added, old data is removed, whatever the case might be, then that data needs to be decrypted again. Then there's sharing of data. Sharing is a peculiar option here, mainly because when you're setting the policies for sharing, it all happens usually inside the cloud. So you don't really have to worry about encryption, decryption policies there, but you do have to worry about how the authorization systems are working, which people have you given what permissions to do with what data. So if you're sharing some data with some person, you need to be sure that the data that you are sharing is only supposed to be viewed by the person, so the person only has the permissions to view the data. They cannot access the data, they cannot essentially delete the data or cause some sort of a change to the data. Similarly, if you are trying to give change permissions to some data, make sure that you are giving the minimum necessary permissions. These permissions include deleting the data, modifying the data, so on and so forth. Then comes archiving the data. Archiving basically means moving it from hot tier to cold tier. Or to give you a basic understanding, data usually stored in locations and redundant systems, mainly because they provide faster access, but they cost a lot more. If you have some data that you don't need to access that often, then you can move it into the archived state, in which it will be stored in locations where it's not accessed in that much of a speed. Latency is going to be there during access. However, there's not going to be that much cost for storing the data. Since it's archived, it's not used that much. You are free to use it once or twice a week, once or twice a month, once or twice a year, depending on how frequent your data usage schemes are. In any case, you need to make sure that the data is archived so that it doesn't cost you a whole lot to store the data that you rarely use. Latency is going to be there, but if the data is only used once or twice a month, then a little bit of latency is not really that big of an issue. Another thing to understand is that when the data is archived, that data is already encrypted, because if you have stored the data in an encrypted format, then the data being archived is going to be encrypted as well. Finally, there's the destroy phase, in which we delete the data which is no longer needed in a way that it cannot be recovered. An important prospect here to understand is that even when the data is deleted, there are ways to recover some bits of information. So again, only destroy data once it's encrypted, so that even when the person who gains access to the information cannot understand the data. And a better way of doing it is to, on cloud, use virtual disks to store data, and when all the data stored inside the virtual disk is removed, then delete that virtual disk as well, so as to create better security concerns. Also, one thing to understand is that there are specific software systems that can do this for you, where they essentially delete the data and shred it in such a way that it becomes unrecoverable. So make sure to look into that as well once you are dealing with some ultra sensitive data. Now let's take a look at data dispersion. Data dispersion is used to store multiple copies of data at multiple locations. In cloud, there are two ways of doing it. First is called bit splitting, second is called erasure codes. Both of them are quite popularly used in storage systems. They both have their own pros and cons, and they both have their own special way of working. Essentially, what we try to do with these is that we create some sort of redundancy. So once the data is stored in multiple locations, if one location goes down, other locations can be used to rebuild the data, or other locations can be used to provide some backup. In any case, let's take a look at them one by one. So first comes bit splitting. Bit splitting is like adding encryption to RAID. RAID stands for Redundant Array of Independent Disks. Here we store data in an array of disks, and it allows us to store data in a more secure way. Similarly, bit splitting works much more like that, but with encryption added to it. The data is first encrypted, then separated into pieces, and the pieces are distributed across several storage areas. This is so that even if one of the storage locations gets compromised, the person who has the compromised storage location cannot access the complete data. He can only access a chunk of data, which may not be something useful for them. Bit splitting carries the following disadvantages, however. Processing is CPU intensive. So once you have uploaded the data, if the data is of huge volume, splitting it and performing bit splitting on it, which includes processing intensive tasks such as encryption and chunking the data and then spreading it across multiple locations. All of this is a CPU intensive task, so it cannot be done for a lot of devices, for a large volume of data, for a lot of users. Availability concerns are all part that the data needs to be decrypted before you use the information that is contained inside the data. So you need to be able to understand that all parts of the data are available, so that when you decrypt the data, it is completely decrypted and the entire information is presented in front of you. Storage requirements and costs are higher than other systems because it takes time, it takes effort, and you need to store multiple shreds of the data in multiple storage locations. You need to have multiple storage devices all attached to each other, maybe, or maybe in separate geographic location. That's completely up to you, but that's one way of doing it. Now, here's how bit splitting works. These are the steps. First things first, we encrypt the data. This is done to make sure that the data that is sensitive is becoming data that is incomprehensible. So encryption basically uses a key and converts plain text to ciphertext. Plain text is the data we have, ciphertext is the data that we want. That's something that people can't comprehend, and it becomes something that people cannot understand. Then we split the encrypted data into chunks. Chunks are basically small pieces of same size of the data, so that we don't have to worry about how we go about splitting the data and how we distribute it. Then the data is distributed to different locations based on the chunks. If we have 8 chunks and 4 locations, two chunks are displayed on all locations. Preferably one chunk on one location is a good strategy. Then comes encryption data at new location. Once the data is put on the new location, it needs to be encrypted there as well. That is the responsibility of the local systems, or you could encrypt it on your own. That depends totally up to you. This is done for enhancing security, so that even if one person gets access to the encrypted data, it has another layer of encryption added on top of it, so that once the person breaks that encryption, even if the person breaks that encryption, it's not going to work for other pieces of data. Now, to recover the original data, the reverse of the above mentioned steps need to be taken into consideration. For example, the data chunk that was stored in a new location that was encrypted needs to be decrypted first. All of the chunks need to be decrypted. All of the chunks need to be collected in the correct order. They need to be put back together, and then the final decryption needs to happen before we can access the data. On the other hand, we have erasure coding. Erasure coding is like using parity bits for RAID stripping. In RAID, parity bits help you recover missing data if one stripped drive gets lost. So essentially, parity bits work like this. Suppose I have 4 bits I'm storing. All of them can either contain 1 or 0. Parity allows us to determine whether or not parity allows us to determine whether or not how many number of ones are there, how many number of set bits are there. If there are even number of bits, then the parity is 0, and if there are odd number of bits, then the parity is 1. There are options to reverse this so that even number of bits get a parity of 1 and odd number of bits get parity of 0. That completely depends up to you, but you have to understand the differences between them. Once that's done, even if one of the bits gets lost or corrupted, we can just take a look at the number of bits that are set, and then we can add the data. So for instance, out of the 4 bits, I have 2 ones and 2 zeros. So there are even number of bits that are set, parity is going to be 0. Once one of the data is lost, I check again how many number of bits are there. If for instance I have 4 bits, and out of those 4 bits 1 bit is lost, so I still have 2 ones. That means I have even number of data, and only one piece of data can be added there. That means the missing chunk was 0, so you replace it with 0. That's essentially how RAID works. That's something that is taught to us using in storage systems. But the basic method in erasure coding of data protection is which data is broken into fragments and then expanded and encoded with configurable number of redundant pieces and data and stored across different locations. So that's essentially how it works, very similar to how RAID and parity stripping works. Erasure coding helps you recover missing data in the cloud if the place where the data was stored becomes unavailable or the data gets lost while you disperse your data. In cloud, erasure coding is only used for cold data storage. Cold data is, as far as you are aware, is the archival storage systems. So storage systems that have low latency for high latency for lower costs. And this is because it gets very compute intensive than simple replication across geographical regions. One way to protect your data from being lost when one data center goes down or one server goes down is by copying the same bit of data across multiple regions, so that if one of the data centers completely go down, the data can be recovered from other places. Erasure code like RAID creates parity bits along with chunk data to make it easy to recover the data. A common erasure code configuration is 4 plus 2 erasure code, which means that the data is split into 4 chunks and 2 parity chunks are created out of that 4 chunked data for data recovery. This configuration can tolerate up to 2 node failures. Both of them can either be parity bits or both of them can be data bits, but both of them cannot be parity and data bits. Now, more than if there's more than 2 node failure, then there's no way of recovering the data. Now, this is what the process looks like. Firstly, we create the chunk. Data is chunked into 4 parts. Then we encode the data. Encoding the data is a mathematical process in which we keep the 4 chunked pieces that we have as it is, but we create parity bits out of it as well. Parity bits let us take a look at how many ones and zeros are there so that we can understand how the ones and zeros work. Then we write to the disks. Writing to the disks basically allow us to have 6 chunks and we have them be written to 6 different disks so that the failure of one disk does not affect the other one. Now, in case of failure or corruption of data in these disks, we can use mathematical operations to rebuild the missing data. This only works if the number of lost chunks is less than or equal to 2. If it's more than that, then the data is unrecoverable and essentially our entire data is corrupted. This is why it's stored on multiple locations so that even in when worst of worst comes, only 2 of the places where data was stored can go down. Other places might not go down. There's a good chance that that's not going to happen. This is because if the lost chunks had one data chunk and one parity chunk, data can be recovered. If both the parity chunks are lost, then also they can be rebuilt using the existing data. We can just pass it through the encoding process and rebuild the parity chunks. But if both parity chunks and a data chunk is lost, then there is no way of knowing how to recover the data, and we have essentially lost the data that we needed to recover. So that's basically how data dispersion works in a nutshell. Design and implementing cloud data storage architectures. In this, we'll try and understand the individual components of cloud data storage architectures, and we'll try to understand what are the security components that we need to take into consideration when we're using these architectural components. Let's take a look at them one by one. So in cloud data, there are several ways of storing data to cater to different use cases. Using these, you can build your own architectures to satisfy your own use cases. Now, there are also several threats that you need to be aware of. which is what we'll be covering right now. So firstly, let's take a look at storage types. There are 6 main storage types available in the cloud: raw storage, ephemeral storage, volume storage, object storage, CDNs or content delivery networks, and long-term storage. Let us try and understand them one by one. First one is raw storage. It is permanently allocated disk storage that stores data and exists independently, that is, without this running server instances. Basically, you can store some data and then forget about it. You don't need to run a server and attach the disk to that server, so on and so forth. So it works completely fine. It is used to persistently store data such as logs, files, etc. So if you have some data that you need to be stored for a long period of time, raw storage is the best option for you there. Now comes ephemeral storage. Often used to swap files and other temporary storage needs, this storage type is used with infrastructure as a service instances. Basically, it is used with the raw servers, whether they're virtualized servers or real-world servers. And when the instance is terminated, that is either we shut it down or we delete the instance, the our instance of the ephemeral storage gets removed with that as well. So it's only for temporary storage purposes. It's really fast, it's really cheap, and it's for temporary storage. Now they are also used as caches and temporary storage locations, which will store data as long as the server is running. So for instance, server logs and all of this kind of stuff, you can run inside, you can have them be stored inside an ephemeral storage. Now, most often a virtual hard drive is something that is attached to a virtual machine or a host. That's what a volume storage allows us to do. Basically, a volume storage is if you have some drive and that drive needs to be partitioned into separate volumes. For instance, when you are working on a Windows system or Linux system or Mac system, you have a disk drive that is much bigger for your need. So you logically partition the drive, that is create 3 separate spaces for those drives. In Windows, it's usually the C drive, the D drive, the E drive, and so on and so forth. Depends on how you have partitioned the system. So this is one of those partitions could be considered a volume, and a volume storage is often referred to as a virtual hard drive, which is attached to virtual machines and host systems. It is used to persistently store data and can be attached and detached from already running server instances. Think of it as a virtual USB drive or a virtual SSD drive. Basically, you create some data, you attach a virtual storage or volume storage to that, then you copy the data to that volume, and then you detach the volume, and now it's stored in there. Now, if the server gets deleted, also the data is remaining in the volume storage and you can use it later on. Then there's object storage. File shares accessed via the web interface or real world APIs. Real world examples include Rackspace and Amazon S3. If you've ever tried to store some really unstructured data like audio, video, images, any of this kind of stuff on the internet, then on the cloud essentially, then object storage is the storage that you have used. It is not something that creates a file system for you, and how things are managed underneath is not really a concern. You just want a bucket there to be able to throw some data inside it and then forget about it. And this allows you to do that. It is used for storing massive amounts of unstructured data using such as storing photos, songs, or files, etc. Unstructured data is basically data that has no structure to it. There's no pattern. That's nothing. That's just a stream of bits rolling around, and that's what unstructured data is. And that's how you use. That's what you use an object storage for. Then there's CDNs, also called content delivery networks. They are used to store static assets which are replicated over several locations in geographically distant locations. This is done so that your static assets can be accessed by a global audience. To give an example, let's say you deploy a website. It uses certain images, style sheets, fonts, so on and so forth. These are static assets mainly because these do not get updated regularly. They are not dynamic. Different users are not going to get different versions of these files. So what happens is, if you have a server that is serving this file over the internet, and that server is in the United States, and then you are somewhere on a distant location, let's say India, then accessing that website is going to take you a longer period of time because the data needs to travel longer distances than it would take someone, let's say, in the United States. So that's a big problem. In order to overcome this, what happens is these servers are configured in such a way that they access these static resources from the nearest servers available. And these nearest servers are also called edge locations, which are referred to as content delivery servers or content delivery networks.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Many of the servers are located and spread across geographically. So one may be in the US, one may be in Africa, one may be in Europe, one may be in Asia, one may be in China, one may be in India. Depending on where you are accessing it from, the nearest server is then asked to fetch the resources so that it's delivered to you at a much greater speed. They are used to store and cache static assets such as images, CSS files, etc. in geographically distinct locations for faster access. Finally, there's the long-term storage. It is also called archival storage. It is used for storing data that is not accessed very frequently, and latency in access is tolerable for low storage cost. Think of it this way. You have some data and you don't use it very often. But since you have stored it inside cloud, you get the opportunity of accessing it really quickly. But that costs you a lot more than it should, mainly because you don't use it that much. You can have the option of moving it to an archival storage system in which this will be stored, and the time that it takes for you to access the file could be a little longer. Let's say that if it takes 1 second for it being served over the internet in the normal storage locations, then in archival it will take 2, 3, or sometimes even 4 seconds. However, that's tolerable because you only use it like once or twice a year, once or twice a month. It's not that frequently accessed, and you get a much lower cost option for storing it inside archival storage. They are used to store data at lower cost and higher lower access speed or latencies, as this data is used less frequently. Think of data such as data logs or something like that, which you use once a month to audit the security prospect of your entire network. In cases like this, these can be moved to an archival storage each year so that the previous year's logs are moved into the archival storage and the current year logs are kept so that they can be viewed at a fast speed. Then the current year, when next year comes, the current year logs are then sent to the archival storage and the new logs are recorded, so on and so forth. Now let's take a look at some threats to storage types. Storage types are an important concept in cloud computing, but there are certain threats that we need to be aware of when we're discussing these storage types. Let's take a look at them one by one. In the ISO IEC 27040 is an international standards published by the International Organization for Standardization and the International Electrotechnical Commission (IEC). The standard describes few threats to storage. These are unauthorized access, unauthorized usage, regulatory non-compliance, DOS and DDoS attacks, modification and corruption and destruction of data breaches and leakages, theft or accidental loss, malware attacks, and improper sanitization. These Let us discuss these threats into a little more detail and understand how you can prevent it. The first one is unauthorized access. As the name suggests, users gaining access or are able to view and manipulate the data that they should not have access to is called unauthorized access. To prevent this, you need to set strict authorization policies and only allow access to resources that are absolutely needed by them. So for instance, if a user requests for building an application, let's say that you are an organization and the developers want access to certain resources, you only provide access to those resources that they absolutely need. So a server, a database instance, and and a virtual server in which they can connect each other. That's about it. That's all you need for the usage of your app developers. Similarly, other users may have other needs. You need to firstly assess the needs and determine what are the minimal accesses that you can grant them that could work. And once the access is complete, they have done what they need to do, then access revocation policies should also be in place. Then comes unauthorized usage. Users are able to modify, update, or even delete data that they should not have access to. So for instance, if I have created some piece of information and I should be the only person who can access it and modify it, but another user comes in and can do so, then that's an unauthorized usage storage threat. That's a concern that we need to be thinking about. Now, to prevent this, granular permissions should be used and only the required permissions should be granted to the users. Many storage systems allow you to set granular permissions, such as if a user is allowed to just view the data, if they are allowed to manipulate the data and view the data, if they are allowed to manipulate the data, view the data, and also delete the data, and if they are allowed to, basically they become the administrator and they are allowed to share this data with other people and can revoke my own access to this as well. So you need to understand the context in which this entire application is running and how the storage systems should be utilized there. For instance, if you have some file and you have shared it to someone, you only need to share them with the permissions that they need. If I only want to view the file, then you only need to share it with me with the viewing permission. And there are options for you to specify the time period for which I can view this. So for instance, for the next 7 days, I can view the file. I can't change it, I can't delete it, but I can view it for the next 7 days. Now comes regulatory non-compliance. Several applications deal with data that is regulation bound, such as data regarding credit cards and payment systems. This data needs to be stored in compliance with the set standards. Otherwise, there is a risk of data breach and leak, and you can be levied with a heavy fine if it turns out in an audit that you are not complying to the regulations. It should be made sure that all the regulations are being properly followed through, and tests and or mock audit should be done, so that when the audits are performed, we can get access to the information that we need in order to determine whether the regulations are being followed. Then comes DOS and DDoS. Many people know these as being denial of service and distributed denial of service attacks. These are basically network attacks in which multiple requests are sent to a particular server in order to take it down. A high volume of traffic is sent to a particular resource or particular server so that it becomes either really slow or it hangs up and dies. In any case, the legitimate users are now not able to access the resource. There are ways to prevent this, such as analyzing the incoming data for patterns such as large amounts of requests coming from the same device or a same network. You can also set policies to deal with the same. Many times, many big companies, what they have done is that they have set systems in place that will determine whether or not a particular IP address or a particular network is potentially performing some DOS or DDoS attack. If that happens, then each request from that domain needs to firstly pass a CAPTCHA test, which specifies whether or not the person whether or not a human is sending the request or machines are sending the request. Do note that this is not just enough for that, mainly because you can't just expect all of this to work just by software. There are several other softwares available for you to install and use for preventing DDoS attacks as well, but strong security policies are the major beneficiaries here. Then comes modification, corruption, and destruction of data. Data in the cloud is protected against unauthorized modification, corruption, and destruction of data. This is usually remedied using data dispersion and replication. So think about it this way: if you have some data and an unauthorized access has taken place, or maybe the data center where the data was stored suddenly crashes, goes down, some natural calamity happened, fire erupted, water came down, something happened, and the servers are destroyed. So the data that you had stored in a remote location where you have no access to it needs to be secured in such a way that it can survive these attacks or survive these calamities. One of the easiest way and one of the most preferred way is using data dispersion and replication. As we have discussed, replication basically means that you store multiple. What you do is you chunk the data into smaller pieces and then you spread those pieces across multiple locations so that they can be rebuilt again. Replication, on the other hand, is just copying the same file across multiple locations so that if one location goes down, the request for gaining access to the file can be transmitted to another server or another place, another geographical location. Data breaches and leakages are quite common nowadays. Data breach and leakage lead to data being accessed by unauthorized users who can then copy and transmit and view the data. To give you an example, when some data gets leaked on the internet, then a simple Google search will reveal the data to be available and to be used. To prevent this, we need to make sure that the sensitive data remains encrypted and HTTPS is used when data is being transmitted over the internet. This prevents data leakages mainly because once the connection is secured and HTTPS systems are being followed, then the data is encrypted over the network. So even if some person is able to essentially listen to what we are sending back and forth, they are not able to decrypt the data, and it's completely up to us to take a look at that. Then comes theft or accidental loss. If a user gains unauthorized access to the data and they can delete the data after creating a private copy of it, and the user may also end up accidentally deleting their own data. It is quite common to users for deleting their own information accidentally. There are several ways of preventing this. First one is make sure that the user is only able to gain access to read-only copies of the data so that they don't accidentally delete it unless they choose to change the mode. Know that this is not enough. Sometimes users are able to change the mode and forget which mode they are on, and if they're in admin mode, then they can delete the data easily. Also make sure that the data access is revoked by the owner or the administrator once the person is done with dealing with data. There are other things that you can do as well, such as multi-factor authentication, to make sure that the user doesn't accidentally click on two buttons and gets the job done that they didn't mean to do. They need to enter some captcha. There are many things that you can do in order to make it difficult for them to delete it accidentally. Then comes malware attack. Malware stands for malicious software, which can end up corrupting data all the resources that are stored on a particular device or on a network. So malwares are quite common, especially in cloud computing. So in order to get rid of them or to overcome this hurdle, the best way is to install antivirus and anti-malware software on your systems and make sure that they are regularly being updated, and then they regularly run their system checks when they are running, so that once the system is being run and malwares do end up attacking, they can be easily caught and can be removed. Also, it is to be made sure that the resources are not exposed to unknown devices or unknown networks so that other people can access and install other software. Finally, that's improper sanitization. After data is deleted or delivered, it should be made sure that it cannot be recovered from any of the resources that the data was stored on. So for instance, once you download a archived copy of it and you delete the data, then it should not be possible for people to look at the cloud computing resources and recover bits and pieces of the data. To do this, you need to use proper policies to destroy data and destroy virtual disks on which the data is stored once the data is removed completely from them. Also make sure that both logical and physical deletion takes place. Logical deletion means that it's deleted from the file tables of the file system that is stored inside the disks, but physical deletion means that the actual bytes get wiped from the disk and it becomes completely clean, so that even if somebody wanted to, they can't recover the data from the disk on which we have performed the deletion. How we can design and apply data security technologies and strategies. In cloud computing, there are several ways of applying data security strategies, so let's take a look at them one by one. The first one is encryption and key management. Encryption is the process of using some process called algorithm to convert some data from its original form, known as the plain text form, to an alternative form known as the ciphertext form. Encryption of data is done using a special random data called the key. The key is a very important concept in encryption. Encryption essentially is a branch of cryptography. It is a cryptographical process. Basically means it hides the original meaning of data. So the contents of the ciphertext cannot be understood by anyone. It appears to be extremely random, and you can't draw any information out of this. Now, the ciphertext is converted back to plain text by using a process called decryption. Decryption is the reverse process of encryption, and and it is to be understood that for decrypting the data, the user needs to have the same key that an algorithm had used to encrypt it. There are several algorithms in which you can use a private key to encrypt the data, and then public key which could be multiple keys that person can have. So in this regard, you don't need to share the same key with the person, but in other regards, you do need to share the first key, the same key to the person, so that the process could be reversed. That really depends on you. There are several kinds of keys available for you to use, such as symmetric keys, asymmetric keys, several algorithms for you to use. There's a whole range of things that you can do. The main thing to understand here is this, that keys are important to use, but they are difficult to manage. There are key management softwares that allow this to happen for you. For instance, if you have some key and you want to manage that key, then using a key management software is a great option for you if you have multiple keys and you have multiple data files that you have encrypted. They will also take care of knowing which data was encrypted using which key, and if the data that a key belonged to is deleted, could that key be deleted as well or not? All of this is a complicated process, and there are softwares that will do it for you. Essentially, the process works like this. Plain text is passed through an algorithm and a key supplied to the algorithm. These two features are important. Then this new key that was passed in allows it to encrypt the data and convert plain text to ciphertext. Then that ciphertext, when the user wants to read the data into it, the ciphertext is again passed through the algorithm to decrypt it using the key. Now that key, along with the algorithm and ciphertext, will convert it back to the plain text. Ciphertext is some text that has no meaning. You are not going to be able to understand what it actually contains. So even if a person was able to gain access to an encrypted data, let's say that you have some data stored inside a drive, somebody steals that drive, gains access to it over the internet, whatever it could be, they are not going to be able to extract the information from it because it needs to be decrypted and it's only decryptable using a certain key, which that person does not have. Then comes hashing. Hashing is the process of converting some data of arbitrary size into a shorter fixed length value called its hash. Different hashing algorithms give you different size of hashes. Usually 64-bit strings are useful, for which there are 64 alphanumeric characters strung together one after the other. Hashing gives us the same data always as a result of the same value. So for instance, if I have some data and I hash it 4 times, I'm going to get the same hash or the same string of finite size. Now it could also be called the signature of the data. Now this is something that many people, when they first understand, find it a bit difficult to understand, mainly because it's not apparent where something like this would be used. So surely you can understand that you can get some data, pass it through an algorithm called the hashing algorithm, and it will give you a signature, if you would call it that, or a hash, if you would call it that, which is a fixed length string. And if you were to hash the data again and again and again, the same hash or the same key, same fingerprint will be given to you again and again. Now, where this is useful is something called integrity management. When you have some data and you want to verify if the data has reached you correctly, then you can use hashing algorithms. Many of the online providers of softwares do this. So for instance, if you're downloading some really big piece of software, let's say an operating system, a disk image of an operating system, what they do is that they give you a small fixed length string, also called the checksum string. That string contains is the hash of the data that they have calculated. Now, once you download the operating system's image, you can then again pass it through the hash, calculate its hash, and then check whether its hash, the hash of the file you have downloaded, matches the hash of the file that you just copied. So then, if the hash is matched, then that means that the data has not been modified and you have downloaded the uncorrupted version of the data. If, for instance, even a single bit of information, if a 0 is turned to 1 or 1 is turned to 0, even that change is going to affect the entire hash and it's going to give you a completely different result. So because of this, you need to understand that the hashes are really important and they are used to check data integrity. Now, another important thing to note is that hashes cannot be used to convert the back to the original data. So just as encryption, when you decrypt the data, you get the original data back. In hashing, there's no such concept. You can't unhash the data, just as you can't convert some large piece of information into a smaller piece and then convert it back to the larger piece. That's just not going to work. So that's how hashing works. Then comes masking. Masking is a very prominent technique. It's used by many online service providers. It is also called data obfuscation. As the name suggests, we essentially just hide some pieces of data that we want to be confidential. It is the process of hiding original data by modifying its content. If you have ever downloaded some official government documentation, then unless you are authorized to have that information, you will be able to download the document, but the data inside it will be masked using X symbols or O symbols or dashes or whatever. This is done to protect the data that can be considered commercially sensitive or even personally identifiable. So for instance, if it's a personal information or it's some commercial data such as the GST number, or could be anything that you do not want people outside your organization having access to. People who should not have access to this piece of information in some records are shown are as the masked data. Suppose you have some database and there are multiple people who can view the database information, since some of the database information is not something that is sensitive while other pieces are sensitive. So for instance, in the case here, the ID, name and email is a sensitive field. Now you can prevent access to the entire row itself. However, it is considered a better option to just hide the data that you don't want people to be able to recognize. So in cases like this, what you do is that you get the data and then you mask it. As you can see, after masking it, we, instead of getting john@example.com, we get the first and the last letter, and if the @ symbol is intact. Other than that, everything is hidden behind an X. The name and the ID field are not that sensitive, so you can just show them and it's fine. Although if you wanted to, you could mask those as well. If you want some data to be protected while others not to be protected, then masking is a good choice for you. Then comes tokenization. Now, tokenization is one of the easiest things to implement, and it is very easy to use as well. It is the process of substituting sensitive data elements with a non-sensitive equivalent, which has no exploitable meaning or value, called a token. Essentially, what happens is that this tokenized data can be mapped back to its original form or the original data stored inside a token vault, which contains the tokens and the original values they correspond to. To give an example, let's say that I have an original value in which I have the ID and name column mapping to 1 and John respectively. I create some tokens. Tokens are just randomly generated things. So now the data is 1, and when we see 1 as the ID, it should be mapped to 7. Similarly, when the name becomes John, we want to map it to Brian. Now, whenever a person gains access to this data, they will only gain access to the tokenized version, and internally we'll be using the original version. The reason why this is useful is because once you are using data replacement techniques like this, even if the person gains access or hacks the information, they're going to get access to information that is completely nonsense. There's no record in our system of someone named Brian with the ID of 7. However, they're going to get it, not realizing that it's fake information, and they won't be able to make any use of it. On the other hand, we will be able to map it back to the original data, and that original data can then be used by our internal systems. So it's a good way of securing the system, so that even if there is a data breach, no one is able to access the actual data that they need to, unless the token data vault is also leaked, in which case you have bigger problems at hand. Then comes data loss prevention, also called DLP. Data loss preventions are a set of technologies that detect potential data breaches. It's not just a single piece of software, it's a group of software. It prevents them by monitoring, detecting, blocking sensitive data while in use, in motion, and at rest. Think of it this way: if you have some data and you are using it, it could be in motion, it could be in rest, or it could be in use while it's being created. These refer to the lifecycle stages of cloud data. And all of these different stages have different security requirements. Now, instead of you having to do it on your own, monitoring the data, detecting and blocking sensitive data, this can be done by data loss prevention systems. Standard data loss prevention systems use technologies like firewall, intrusion detection systems called IDS, antivirus softwares, anti-malware softwares, etc. There are also some advanced data loss prevention systems which use machine learning algorithms, temporal reasoning algorithms, user activity monitoring, etc. These help in understanding how the data is being accessed, if there's some irregularities in the users who are accessing the data, and if so, then the data can be either put into a vault and prevented access unless a person gives some OTP. There are different security policies that can be put into effect after a suspicious activity is discovered. Then comes data de-identification. Data de-identification is also called data anonymization. So if someone is talking about data anonymization, it's the same thing. It is the process that is used to prevent someone's personal identity from being revealed from some data.
Just a quick info, guys. Intellipaat provides CISSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
There are moments when there are times in your life when you submit some data with your consent, with the understanding that the data is not going to be out for other people to use. Your participation in the data collection process and your data that you have provided are going to be completely confidential. In cases like this, we need to provide some mechanism to de-identify the data or anonymize the data. This is usually done when some sensitive data is collected and the identity of the person is irrelevant. For example, when the data is collected from the participants in a medical study. You might end up collecting more information such as the name of the person, the email, if they should be, if they can be essentially contacted, if there's some some important stuff that we found about it, and we want to call them once again for some another kind of study. Now, in any of these cases, the problem here is that when you publish the study result of the study, you need to publish certain information, and in this publishment, you need to verify and figure out that you are not leaking some personal information that you should have held back on. So, in cases like this, what you can do is you can use data de-identification techniques. Data D is de-identified after passing it through a series of steps, which uses techniques such as tokenization, masking, removal of personal data, etc. Personal data such as name, email, etc. are removed out of this. Now, several institutions and government bodies have their own rules and standards for data de-identification. So it may be that you don't have to do it on your own. Once you store the data inside some system, when you publish the results, the data that you will be given access to is going to be automatically de-identified. But in any case, it's important to understand. As the diagram shows below, a simple data de-identification pipeline in which we tokenize the data, and then we mask the data, and then we remove the data. So with that, now let's take a look at what else we can learn. How you can implement data discovery. So in cloud computing, cloud computing is a set of technologies that can play a big role in data discovery. Data discovery is the process of collection and evaluation of data from various sources. There are several concepts that we need to understand, such as types of data, data discovery techniques, and the issues that might pertain when you're trying to do data discovery. Let's take a look at them one by one. So the first thing that we have to understand is the types of data. Data can be of several types, and discovering these types of data can be different from one another. So the two kinds of data that is available is structured and unstructured.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let us discuss them briefly one by one. Data that is comprised of clearly defined data types and patterns which make it easy to search and comprehend, e.g. data stored in tables, is called structured data. Think of data stored in your databases, your SQL databases, in which you have tables, columns, foreign keys, primary keys, and all of that. That's called structured data. It has a structure to it. You can see the structure repeating in multiple columns. You can search for data quite easily. You can see a pattern. You can comprehend the data easily. Then comes unstructured data, data that has no clearly defined structure and is not easily searchable. Data such as audio, video, images, so on and so forth. At the most basic level, this is binary data. When you take a look at the binary data, there's no structure, there's no pattern that's repeating. The only pattern that you can see is a bunch of ones and zeros are there, but that's not really a pattern, that's just technology that is being used. Other than that, there's not much that you can do to understand how the things are working and how you can make searching and scrolling effective here. Now let's take a look at the different data discovery techniques that are available. So there are several techniques which you can use to perform data discovery, such as metadata, labels, and content analysis. Data discovery using metadata is really especially useful because many of the companies use this. Now, metadata is data about data, such as data when a file was created, column name was created, when the last time these things were edited, what is the last version of the file, the who created the file, when the file was created, when the file was last modified. There's a bunch of data about a file that could be considered information useful for data discovery process. It can be used to find and extract useful information, such as if the data was essentially modified in the last few weeks, that means that it is a useful piece of information. However, if it hasn't been touched in a month, then that means that it could be moved to an archive storage. Maybe we can store it into a data warehouse where this data will be worked on and we'll get some insight out of it. Then comes labels. Labels are descriptions of data, such as the description of what an image contains. These descriptions can be used to group and classify data. For instance, if you have certain images that contain a particular piece of information that is useful to you, let's say that you are trying to build a system that can determine whether or not a particular image contains a traffic light, then multiple traffic lights are going to be inside an image. They can be labeled as containing the classified information or containing the traffic light image. and the other one would be considered not containing the traffic light image. You could go even further and further classify them as when they are containing the traffic light image is one of the lights in the traffic lights on, which one is it? Is it red, green, or blue, and so on and so forth. So these are all done using labels, and labels provide very useful information so that we can then discover the data based on the labels that are provided. Then comes content analysis. Content analysis allows us to analyze the documents and artifacts of various formats such as text, pictures, audio, video, etc. This analysis allows us to examine patterns and extract features from the content, such as emotions being shown in a review, etc. If you have some online review that is written and you want to analyze the content and figure out how the content is being structured, what are the words that are used, what are the keywords that are used, does the reviewer review the piece of information favorably or unfavorably? Is he or she happy with the product? Is he or she unhappy, satisfied, unsatisfied, sad, happy, angry, so on and so forth. So this is also very useful. Now comes data discovery issues. Now, data discovery is a complicated process, and as with any complicated process, there are several issues associated with the data discovery process. Let us take a look at them one by one. The ones that we'll be taking a look at are poor quality of data, dashboards, and hidden costs. Poor quality of data basically means that the discovery of data among data that is not correctly classified, that is not correctly cleaned, that contains incorrect information, missing information, that could be a source of a lot of problems. And this could lead to a lot of misleading statistics and misleading facts that may or may not be true because the data is so poor. So poor data can be a major cause of issues. Then comes dashboards. Now, a dashboard is an important data visualization tool in data recovery. However, it can be difficult to build based on the complexity of data and the size of the data. If you have data complexity, data shape is very complex, then visualizing it is going to be really difficult considering the edge cases that you might have to consider, in which data is nested deeply within one another. Now you have to go through each of the nested places to find out whether or not some data is available there, and if there is, then you extract that data, go back up the hierarchy, and then go down. This is going to be really difficult, so it could be an issue, especially if the data comes from a source that you do not control. They can even change the data, and the shape of the data is changed, then your application needs to adapt to that as well. Then comes hidden costs. Costs associated with data discovery are difficult to estimate. These costs estimate may turn out to be underestimated, or hidden costs may emerge if the data is not analyzed properly for the estimation process. So understanding what kind of data you have, what is the complexity of the data, and how you are going to go about doing this will allow you to figure out what are the hidden costs. Cost may not only be monetary, it could also be time-based cost. For instance, if you determine that it's going to take you 3 months to create a data discovery pipeline there, but it ends up taking you 6 months or 7 months, that means more and more time is being used and more resources of the company are being used here. So it's important to understand how you're going to do that. With that, we have understood all there is to understand about data discovery in the cloud. It is a process that is very important, and these are the issues and techniques that you can use in order to do data discovery. Now let's take a look at data classification. Data classification, or how you can implement data classification in cloud computing. What are the things that you should know before you implement data classification? Now, data classification is the process of analyzing structured or unstructured data and organizing it into categories based on file types, contents, and other metadata. There are several options in data classification, such as mapping, labeling, and dealing with sensitive data, etc. Now, mapping refers to the process of creating links between features and data in a dataset. Suppose you have some dataset that contains images of famous people. The mapping is going to be the features and the data that is considered it contains in the dataset. Or another way of thinking about it is if you have some medical data, then you can create several links between several kinds of data. For instance, one kind of a feature would be if the person is old or new, or you can say old or young. And in cases like this, you can create a link between the old feature and attach it to one particular file and one particular row of data, and then the young people will be given the feature of young. This way, it's easy to categorize and group data together. So for instance, if you have some data that contains just the age of people, but you want to classify them as being old, as being senior citizens, as being young, as being teenagers, as being babies, as being adults as well. So you can generate these features, and then you can just map them to those. Then there's labeling. Labeling is the process of assigning classification labels to determine a class in which a particular row of data belongs to. So taking forward our medical information dataset, let's say that we want to determine a particular person has diabetes or not. If it turns out that a particular person has diabetes, then the data in the row in which it is existing will be labeled as positive. Positive meaning that the person has diabetes. It's a yes or no binary classification. You could also put yes or one or zero as well. A person who does not have diabetes will have zero in their row. The meaning of one and zero, yes or no, and positive and negative are already predetermined because we are checking for a person having diabetes or not. Then comes sensitive information. Whenever trying to deal with data classification with sensitive data, special needs to be taken care of data that is being used for data classification, such as the protected health information, also called PHI, personally identifiable information, PII, and cardholder data. So depending on the kind of data that you're working with, there's special kinds of care you need to take care of when you're dealing with these kinds of data. So these are the considerations that you need to take care of. These are the processes that work with data classification. Now let's see how we can design and implement information rights management systems in cloud computing environment. So information rights management are technologies and processes that protect sensitive information from unauthorized access. For IRM, we have to understand these things, the objectives and the tools. So let's firstly take a look at the information right management's objectives. Now, as with any technology, there are several objectives that are associated with the information rights management system. But the main ones are data rights, provisioning, and access models. There may be other objectives that you can tack on based on how you want to structure your applications and how you want to deal with the entire data access models. But overall, you have to understand that these are the basic tenets or the objectives that we need to understand. The first one is data rights. As the name suggests, data rights give people authority over their data. They offer the right to access, change, move, and delete their data. Essentially, this is to determine what person has what right over what data. If I create some data, do I then have the right to manage the data, change the data, basically be the administrator of the data? Or does the organization that I am working for has the administrative right and I only have the right of requesting certain permissions for that data? That is covered under data rights. Now, which one of it is for you is something that you need to determine based on the use case that you have. To give you an example, let's say that you want to essentially create a system that works only for yourself, that you're the only person who will be using it, and the data is only going to be the data that you create. So think of it such as a blogging system. In cases like this, it is a good idea to give the employee who will be working with the data complete access over the data. They can change the data, they can add the data, they can delete the data. Whether or not some information is being collected about how the data is changing, what are the changes being made, who are making these changes, when and why, that remains up for consideration, and you can do so yourself. But in any case, data rights essentially means that you determine the people and the authority that they have over the data. So if you're someone who has been using blogging platforms such as WordPress for a company, then and you move it to the cloud, then several of these facts apply to you as well. Then comes data provisioning. It is the process of creating and deleting users from a system. These users have authorization properties associated with them, such as roles, groups, permissions, etc. It may seem really easy to create and delete users, also called provision and deprovision users. However, there's a fair bit of complexity that is associated with it once you take into account the complex networks of attributes that are associated with each user. A user can have different roles such as administrator, viewer, commenter, so on and so forth. And a user can belong to several groups, such as the admin group, the managers group, the management group, and many other kinds of groups. And each person can have several permissions such as being able to access some data, being able to remove some data, being able to spin up some servers and delete some servers, being able to add new infrastructure resources such as servers, load balancers, networks, virtual networks, etc. In all of these, the important thing to understand is that all of these needs to be managed using a permission system. The permission system's primary job is to take care of whether or not you are able to create some data, delete some data, and are the permission applied to you removed once you have been deprovisioned. So if you create a user and you then deprovision that user, do you deprovision their entire identity, or do you deprovision the rights given to them for certain resources? So do you disallow the person from creating new servers, but you keep their identity in your identity management systems? All of these are things that you need to consider when you're designing the security and authorization policies. Which is why it is determined that these systems are very complicated, and they should not be given in hands of every person, because if people don't have the strong understanding of authentication and authorization policies that need to be set for a secure environment, then giving them that kind of access is going to be really problematic for the people who do give them that kind of access. Then comes access models. An access model defines what a user can do and cannot do on the data based on several factors such as their roles, permissions, and the groups that they belong to. So in provisioning, what we do is we create the user and we remove the user, and we take care of all the other aspects associated with them. As mentioned before, this gets particularly complicated because of all the values, all the attributes associated with the user, and depending on each use case, we have to determine a particular solution. Access models, on the other hand, determine which role can access which resources, which role can access which data, what permissions are given to a particular user, what groups are associated with particular permissions, so on. To give an example, if you have a cloud computing infrastructure and you're managing the rights and management of everyone, then if a person builds an application and they are the developers, then they should be given access to servers on which the application is being deployed, and the right access to the servers on which the data is being written, or treated right access. On the other hand, if a person is an administrator, then they should have full access over all of these. Preferably, only one person is given administrator access over all of the resources. If possible, don't give just one person or anyone that kind of access. Compartmentalizing these accesses can be a better option here as well. Another thing to notice is that there are several groups as well. So depending on what kind of permissions you're giving to a group or a person is going to be understandable. Suppose there's a person who belongs to the developer group and the management group, which is to say that they are a developer and a manager at the same time. And in cases like this, they should have access to users' information, they should have access to employees' information, their salary, and so on. And they should also have access to infrastructure resources so that the applications are being deployed and they can take a look at how they're being deployed. However, if the person then gets demoted from a manager to just an employee, then they should be kicked out of a group that gives them that access. Instead of just removing all the accesses for that entire group, we should kick out that person from that group. Again, this depends on the situation that you are faced with, and so on and so forth. Now let's take a look at the appropriate tools that we would have to use to implement information rights management. As we have discussed thus far, that it's not easy as it might seem to determine the rights that a person has on particular information in cloud computing environments, and how do people craft their own cloud computing information right management system depends on the tools and that are available for them. So for digital rights management, we make use of several concepts such as keys, certificates, etc. These concepts require several tools that can perform certain tasks such as issuing certificates, revoking certificate, and certificate repletion. Different tools can do these tasks, or maybe you can create just a single tool that can do all of these tasks. It is to understand that these certificates are cryptographic certificates. It's not a piece of paper that you can just randomly create and copy and paste. They have their own cryptographic signatures, and if a particular action is authorized using a particular certificate, then that person's name is associated with it. And these cryptographic certificates also come with keys in order to determine whether or not a person has given their consent for these certificates to be used. Specialized tools that use cryptography to issue cryptographic certificates with securely specifying users' identity and tasks that they need to be permitted to need to be created. Issuing these certificates is a cryptographic process. This is not extremely or lightning fast as multiplying two numbers maybe, or all the other tasks that we perform in a computer-based system maybe. Here we have to understand that these are specialized tools and they use cryptographic processes. This could take a lot of time depending on the strength of the cryptography that we're using. And so issuing the certificates is a task that is best left on tools, because tools are much better at issuing things and keeping track of things that are issued thus far. Then comes revoking certificates. Certification revocation is basically the process of revoking the certificate so that it cannot be used further. This is also a cryptographic process. Again, cryptographic processes may seem like a very easy term to use. However, cryptographic process is really important to understand. The important thing to understand here is that since these are cryptographic processes, that means that you do not get access to essentially do anything that you want with these things. They are properly secured, and that's why, to maintain the integrity and security of the certificates and the meaning of the certificates, we keep track of these certificates using specialized tools. That's why for issuing certificates and revoking certificates, we use specialized tools. Otherwise, all we would have to do is basically just delete the certificate that is inside our database, and that would be it. But since it's a cryptographic process, there's a lot more involved in it. Cryptography uses a lot of mathematics in order to maintain the integrity of a particular system. So we need to take care of that as well. So these are the two kinds of ways. Third one is certificate replication. Suppose a particular certificate needs to be issued to multiple people. In cases like this, or suppose a multiple simple key needs to be given to multiple people, maybe it's a public key and we have private key, we have generated multiple public keys and we need to be distributed to each person. This is also a cryptographic procedure and needs to be handled by a special tool. So these are the kinds of things that we need to take care of when we're dealing with the certification, using certificates, issuing certificates, revoking certificates, and certificate replication as well. These are cryptographic certificates. They are secure. You can't just automatically create the certificate. Once the certificates are created, then the tasks that these certificates are used to authorize, these certificates are then verified by a verification system, and that certificate verification system then lets go of the task if the certificates are verified correctly. If not, then this is logged inside a system which will be notified to the data administrator. So with that, we have understood all that is to be understood about information rights management. Now let's take a look at how we can plan, implement data retention, deletion, and archiving policies. So there needs to be policies that deal with several activities performed on data in cloud, such as retention policies, deletion policies, archiving policies, and legal hold policies. Let us try and understand them one by one. The first one is retention policy. As the name suggests, the retention policies are used in order to determine how a particular system is going to retain the data that is provided to us. So essentially, think about it this way: when you have a cloud data policy for retention of certain data, the thing to understand here is this: how the data is going to be retained, for how long it is going to be retained, is it going to be deleted after a while, and how is this going to affect the data's integrity. If someone gains access to a particular data server, is my data encrypted? Is the data that has been retained deleted immediately when I delete it? Is it a logical deletion? Is it a physical deletion? As you can see, there's a lot of policies that need to be taken care of. But retention specifically takes care of how the data is retained. What are the geographical locations where the data is copied? What is the uptime of these geographical locations? Is it encrypted? What level of encryption is there? And so on and so forth. Then comes deletion policies. These specify how to securely delete the data when a specific resource is assigned to a different user. They should not be able to recover the deleted data. Let's understand this using a scenario. Suppose that you are working on a cloud computing system. You have created some data and you have been creating some data on those cloud computing platforms for a long period of time. Suddenly, the application that you used to do is no longer useful and you decide to take it off the internet. Now, for doing that, first things first, you need to delete the data that your users have submitted, such as their email, passwords, mobile number, and many other kinds of things. Now, in cases like this becomes really difficult because once you understand that you have to delete the data, you first have to realize where exactly have you put the data. Is it just in the database? Are the databases storing the data or logs inside some other files as well? Are there some cache files? Are there some servers on which locally the data is stored, so on and so forth? Using this, what we end up doing is we end up creating the policies that will delete the data. So once we end up taking our application off the offline, then we delete the data that is given to us by user by firstly deleting the databases, deleting the servers, deleting the virtual hard drives, so on and so forth. Now, it is to be done in such a way that the data that was deleted could never be recovered by anyone, whether or not they gain access to the same resource. So the virtual server that you had created to host your application stored some data. You deleted that virtual server, but that data is still being stored in some ephemeral storage. When someone creates a new server and gets assigned that kind of it gets assigned the same resources that you did, then can they still recover the data? Can they still find the data or not? These are the kind of things that we need to worry about in the deletion policies of our data retention policy. Then comes archiving policy. These specify how long the data needs to be dormant before it is archived, how long the archiving process needs to store the data for. So to give you an example, archiving is the process when you store some data that is not very frequently used. The dormant data here basically means that it hasn't been used for a long time. Suppose I create some data and I store it in a file. Then I forget about the file and I don't use it for let's say 6 months. Now that you consider some data not being used for 6 months dormant? If so, then in your policy that will be specified, and every time when 6 months pass and a particular file has not been used, then that will be moved to an archived storage. That will cause it to cost less because it's not in the raw storage format, it's in archived storage. Latency of accessing and using the file is going to be more, but since you have not accessed it for 6 months, it's a good bet that it's not going to be used for another 6 months or for a long period of time. In any case, once you archive the data, then you need to understand that how long does the archive data needs to be there. Certain organizations keep some data for archived forever, while others don't like to keep the data archived for any period of time. So in cases like this, we would recommend that what you do is you specify some archiving deletion policies in which you specify if the data has been in archive for 1 year and no one has touched the data, then it's safe to delete the data with the user's permission. Now that permission could be that they send you an email that the cloud service provider, once you log into the console, tells you that this has been the case and would you like to delete the file or review the file. And in any case, these are how these things can be done. Again, you can craft your own policies, you can negotiate with the cloud provider, you can use a cloud broker to do the negotiation bit for you. The important point here to understand is that these are the ways that you can do these things. Then comes legal hold and policies. So some data is highly sensitive in a legal context, which means that some data is extremely legally sensitive, and misuse of that data, unauthorized access of that data, all of that could lead to really high fines and criminal cases against both the person who stored the data and the place where it was stored, if the place it was stored was not in-house. So within specific regions, within specified encryption policies, there are certain regulations that we must follow when we are storing this highly sensitive data. It could be governmental data, it could be medical data, it could be anything. So these regulations need to be followed. For instance, if you are storing some data that is stored inside a particular facility, let's say that you are working with the US government, they have their own specified encryption strategies and how you can encrypt the data, how you would decrypt the data. There are specific procedures that you can follow in order to encrypt and decrypt the data. There are specified regions in which that data should reside, so on and so forth. So there's a lot that we have to be cognizant about when we're learning about cloud policies for legal data. The legality of the situation could be drastic in the sense that once you are working with cloud data policies, you do not know how the cloud data policies are going to be followed. So you can also set up some audits there as well. Several government organizations also perform random audits so that they can determine whether the regulations are being followed or not. So with that, we come to the end of cloud data policies. Now let's take a look at how you can design and implement auditability, traceability, and accountability of data events. Data events are notifications caused by creation, modification, or deletion of data. There are several factors associated with data events, such as event sources, analysis, non-repudiation, and chain of custody. And we'll take a look at them one by one. First thing to understand is that data events are not a new concept. Data events are basically just some metadata that we store about the modifications or changes made to some data, such as when some new data is added to a particular folder, when the data's contents are changed, when that data is deleted, or when that data has its content is replaced by some other contents. All of that is taken care of, and these data events contain information such as the person who changed the data, time it was changed on, when the data was created, when the data was destroyed. If it was destroyed, then this kind of information will be stored. What were the changes that were made, and at what time were the changes made. Using these kinds of metrics, what we can do is we can determine whether or not a particular piece of information was was caused by unauthorized access, was some data accidentally or maliciously deleted by someone, and if so, who was that person, and how can we retrieve the data back? What are the changes that were made by the person so that we can uncorrupt the data and change it back to its original form. All of this is an important tool to understand, and that's why we have cloud data events. Many cloud computing service providers provide these capabilities out of the box, so you don't have to worry about them right out of the gate. However, you do need to understand that these tools are very powerful, and understanding what are the security challenges associated with them can be useful. The first one is event sources. This is a term that is used in software development quite a lot. Event sourcing is a particular kind of software. Event sourcing is the process of keeping track of all the information regarding changes made to some data in a system, and event sources are the software that save or log this information. If you are a software engineer, then you definitely would have worked or either heard of a system like this. It's a very popular system called Git. Git is a version control system. For those of you who are unaware, Git is how software developers manage the versions of the software that they are working on. The new changes that are made by people can be pulled down from GitHub. They can submit their own changes, and they can merge new changes to original existing files. Git also keeps track of all the changes that are made to the files, and the labels associated with it are the commits message. So if you have ever written a commit message, you need to understand that these commit messages are the description of the changes that you have made, and the changes that you have made are also kept as records in Git. So if you, for instance, determine that one of the changes that were made and were merged into the master branch are not good and you need to revert back to the original systems, in cases like this, what you can do is you can revert to an original form of the data, or you can revert to the state of the data before it was changed. This is possible in event sourced systems. So this is why event sourcing is considered such a powerful tool. Similarly, in cloud computing, when data is stored online, the data, when it was created, when it was destroyed, when was it accessed last, by whom it was accessed, who changed its content, what were the contents changed from, what were the contents changed to, and several other information can be kept track of. Again, for example, in Google Docs, you can do this. All you have to do there is essentially you create a spreadsheet and you keep track of the changes that people made and when they made them. This makes it really easy to blame for some disastrous change made by someone based on the event source data that was kept. Now, let's take a look at analysis. Data analysis is also an important aspect of software of data events. These data events need to be properly logged, stored, and analyzed. Once they are analyzed, you can also create dashboards for visualization of the data. What is important for you to understand here is this. The dashboards that are created are not for us, they are for the non-technical people. Usually the data that is stored using event sourcing systems and data events are in text format. They are logged in databases, flat files, object stores, wherever we want to and however we want to store them. And after that, once the data is analyzed, we can determine trends, we can determine people who made the changes, how the changes were made, and we can create interactive dashboards that can take you through the entire timeline of the data that was changed. In cases like this, we recommend that you take a look at data services, and for that, you need to firstly understand the shape of the data that you have logged as the event sources. Then you need to understand how you can create a dashboard. Several services provide these kind of services for you, so you can just basically plug in some data or plug in some service to your cloud service provider, integrate them, and then they will fetch the data from the event sources securely and then create the dashboard for you. Important point to understand here is that even if the dashboards are created, you need to understand that these need to be done in a secure way. So if you are using an external system, then it could be difficult. Many cloud service providers provide their own systems to visualize some kind of data, so you can use those as well. Then comes non-repudiation. Non-repudiation is actually a desirable trait in any secure system. It means that it's a situation where a customer cannot deny authorship of some data and its event. So to give you an example, suppose I have some data and I made some changes to it. Those changes lead to a devastating effect, and now my data is corrupted.
Just a quick info, guys. Test your knowledge of cybersecurity by answering this question. Which one of the following is a type of antivirus program? A. Quick Heal, B. Kaspersky, C. McAfee, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The organization that I'm a part of starts blaming cloud computing providers. They can, for instance, tell the cloud computing providers that this is your fault and you need to fix it. Now, in cases like this, what the cloud computing systems could do can take a look at the event logs and just tell that, okay, this is what the event logs say. We can't change the event logs unless it's been made by your organization. That's the policy that we had set. And it shows that one employee of your organization has changed the data. That means that you are the people who need to take care of this. In cases like this, non-repudiation is actually used to essentially specify the order in which, or specify the authorship, which is determined by the event sources. So who made what changes led to what catastrophic failures, what changes led to what successful failure, successful events, so on and so forth. In any of these cases, first thing to understand is that non-repudiation is usually used in many cryptographically secured systems. So it's not something that is new. However, it is to be understood that even if we create any kind of cloud data event system, non-repudiation is one of the key tenets that we need to make sure that we are following. And then comes chain of custody. Now, chain of custody could be a little difficult of a topic to understand right off the bat. Chain of custody refers to the documentation that establishes a record of the control of transfer and disposition of the control of data. Basic idea is this: once you have some data and some people have some access to that data, when that person's access is revoked or is transferred to another person or another ID, that also needs to be checked. And when something catastrophic happens, then this chain of custody, which is I held the custody for the data and then somebody else did and then somebody else did, this needs to be maintained so that in cases of catastrophic failure, data breaches, data leakages, we can get a proper understanding of the timeline of how the data was used, and we can also determine the culprits who might have committed these issues. This doesn't necessarily mean that chain of custody is the only saving grace. You also need to maintain all the other kinds of non-repudiation analysis, event sourcing, and so on and so forth. However, chain of custody is an important aspect. Chain of custody is such an important aspect that it's not only used in cloud data events, but also in legal withholds. So if you have ever been involved in a legal case, there are also chain of custody is something that needs to be established. And in cases like this, all of these things need to be taken into consideration. So just to recap, the things that we have taken a look at thus far is the data events. What are data events? We understood what event sources are, we understand how the analysis of event sources takes place, we understand what non-repudiation is, and we understand what chain of custody is. All of these things collect data that is then audited by auditors, and we determine who was the culprit, who were the people because of whom particular data breach or a data leakage happened. So this is how you implement auditing, traceability, and all of that in your cloud computing system. Data events are an important aspect because they allow us to understand how the data was changed and who changed the data and how we can recover the data back.
The first point in this comparison between ethical hacking and cybersecurity, let us check out the mode of working. See, what happens with ethical hacking is that ethical hacking concerns with the company people itself breaching their own security methodologies that are created by cybersecurity experts, right? So cybersecurity experts, they create certain firewalls, they create barriers and all of that. Then later the same company will hire ethical hackers to make sure to find ways on how they can, breach these barriers and break down the firewalls. So it's a game between these two guys, to be very honest with you, because as I told you, a cybersecurity professional has the capability to recognize and resolve any sort of issues that are present. But then there might be some things that are not visible to the naked eye for a cybersecurity expert, right? So there may be backdoor approaches that one can take into the company. This is where an ethical hacker comes into the picture. And then when we're talking about the end goal of ethical hacking and cybersecurity, ethical hacking is completely concerned about exploiting the company itself. See, exploiting in a good way and not a bad way. Understand that, because here we're trying to find out all the weak points, and in fact we're just demonstrating total failure in security. And if you're wondering, hey, isn't that a bad thing? No, here it's a very good thing, because a very good ethical hacker has the capability of hacking the organization and showing the failure. The victory aspect of ethical hacking is to show failure in the company. Because once you know that there is a failure, you can have cybersecurity experts fix that. So what do cybersecurity experts do? Well, this entire field in general is completely concerned about the creation of policies. First of all, after the policies have been created, you have to make sure that there is no unauthorized use of these policies or any sort of violation in these policies that will lead to the unauthorized access of other people as well. So in that particular case, cybersecurity people create the policies. Ethical hackers make sure to find ways to destroy and work their way into the company with bypassing all of these security measures. Then they report it to the cybersecurity team, and the cybersecurity team fixes it. This goes on in an iteration. Coming to the third point in the comparison, it is production environment. See, what actually happens is that, with ethical hacking, we're trying to evaluate the system based on all the policies that already exist, right? These policies have been created by cybersecurity experts that the ethical hackers use and evaluate, and to see how they can get into the system. What cybersecurity is completely doing in the case of production environment in a company is that these guys will take care of the auditing of all of the security technologies that get implemented, right? See, once you have certain technology implemented, you need to audit it, you need to keep it in check and make sure that as a cybersecurity expert, you're not leaving any room for any sort of unauthorized hacking. In that particular case, this is exactly how it works in a production environment too. A cybersecurity team involves auditing the security technologies, while ethical hacking is completely concerned with the security policies that are already existent in the company. And that's a very important difference that you have to know about, because cybersecurity experts can create new policies while ethical hacking experts cannot. They have to work with the existing ones that are there and break them. So with this, we can move on to point number 4, where we'll be talking about reporting. In both of these fields, let me tell you that reporting is very, very important, because ethical hacking actually involves the creation of very thorough documentation to show what loopholes are present in this. So ethical hacking completely involves creating very, very thorough documentation, because using those documentation is how you will explain to the company members, the people who are not into security, the people who are probably a non-technical audience, saying, hey, this is where things have went wrong. This is the thing that we picked up which could lead to a vulnerability, so get it fixed. So to do all of that, you need to have very good documentation skills, and of course ethical hackers have this skill as well. But will you require so much of documentation for cybersecurity? Well, let me tell you, cybersecurity is all about maintainability, right? So having the documentation of how things are going day to day is more important rather than having things which are not in the scope of cybersecurity there as well. So to keep your documentation in check and to keep your daily working in check, you will have documents, yes, but these documents are more concerned about maintainability rather than the daily operation as well. So in terms of reporting, ethical hacking has a bit of an advantage or an edge here because of the thorough documentation that it offers. And then when we have to talk about client usage, well, ethical hacking, as I just told you, it involves showing the weakness of a product, right? So when you have a client who comes to you saying, hack my product, you're going to take all the measures, all the tools, all the techniques, you're going to hack into the client and you're going to show, hey, this is where the weaknesses are. This is how I breached into the system. This is how people can potentially breach into the system. So make sure you protect these. A cybersecurity expert takes a very different approach, because here all we're trying to show is the latest methodologies, the latest techniques that we have, and how best we can implement them to safeguard all the technology that we have, to make sure that we don't give a chance to hackers to hack. That's the pretty simple difference that lies in between how clients approach ethical hacking experts and cybersecurity experts, and what they get at the end of it as well. Coming to point number 6, we have to talk about problem solving. See, problem solving is a very important thing, because with ethical hacking, we take an approach of an attacking stance. Because here, ethical hacking experts will show you how an attack can be launched, how it can be succeeded, against a company or an individual or whatever it is, and how data can be stolen without their permission. But with cybersecurity, what we're trying to talk about is we're trying to show if there is any violation in the policies that exist that might, lead to that as well. But then, if there are no violation in the policies, if if all of the security measures are right, if all of the policies are right, and if they're perfect, it means there is no requirement for an ethical hacker. Because if your cybersecurity methodologies and tools and techniques are bulletproof, then you would not require ethical hackers, right? But that's not the case. We are hiring more ethical hackers these days than cybersecurity experts, and there's a reason for that. No matter how good your cybersecurity methodology gets, as there's a code that says for every lock there is a key, and for every lock which is probably a cybersecurity firewall, a hacker will know how to work around the key. So in that particular case, ethical hacking is very, very important in solving the problems. Point number 7 that we have to talk about is data access. See, what happens is that with ethical hackers, right, they need to hunt for new methods, they need to hunt for novel things to hack into an already existing security system. So an ethical hacker, if he's a person who is sourced out of the company itself, he or she might not have the access to complete working of the company. So he or she is just given the task to see how you can get into the system and breach the network. But an already existing cybersecurity expert in the company will have complete access to the system, so they will know it thoroughly in and out. So this is where the expertise of an ethical hacker will come to the picture. It doesn't mean that a cybersecurity professional is not an expert, because the cybersecurity methodologies of today are almost bulletproof. I want to say that it's almost bulletproof, and at the end of the day, there's a lot of things that can be beaten, and cybersecurity systems are one of these things as well. So ethical hackers need to have the capability to work completely out of their comfort zone, while cybersecurity people, they will have all the access to the data, tools, methodologies, techniques, whatever you name it, and they'll have to work with that. Coming to point number 8, I'm sure you guys are curious about the job roles that exist in between ethical hacking and cybersecurity, right? So ethical hacking has a lot of roles as well, but the major roles that the world is hiring for right now is penetration testers and security managers. These guys, as the name suggests, a penetration tester is a person who has the capability to penetrate into a company, penetrate into a network in an unauthorized way, and work with it as well. And then when we're talking about cybersecurity professionals, we have CISO, we have SPC engineers, we have security analysts, and many other jobs as well. So if you're thinking about, hey, is there only 3 or 4 roles in each of these domains? The answer is no, because at the end of the day, if you have a product that's probably connected to the internet, you will require some sort of cybersecurity, right? So now think about the millions and millions of computers across the globe that's connected to the internet. You need the toughest cybersecurity methodologies put into place, and you need the most skilled ethical hackers to find loopholes and fix them, right? So in that particular case, there are many other job roles than just the ones that are mentioned here too. So coming to the next point, where we talk about the average salary of these developers, ethical hackers actually get a very good pay, somewhere around $122,000 per annum in the USA and around 12 lakhs per annum in India. And cybersecurity professionals get an average salary somewhere around $135,000 per annum in the USA and 13 lakhs per annum in India. These are the average salaries of both of these domains, and you do have to understand that there will always be a requirement for cybersecurity experts and ethical hackers no matter what. See, the entire world can go into a recession, but people will be still hiring for these guys because they want to keep all their data secure and not lose it just because there's a recession going on, right? So when you think about it, it's a very bulletproof job that pays a very good salary. There's always someone hiring for it. So if you have enough skills, if you are certified in ethical hacking, a lot of potential employers will be interested to hire you as well. Coming to the last point on this comparison, which one is easier to learn? Well, easier to learn is subjective, because whenever we talk about ethical hacking, you need to be creative and you need to have a lot of out-of-box thinking to be able to crack into system, right? Because see, you have to find out ways in which an actual hacker would hack into a system, and then you will have to trace the same steps as well. So you need that kind of a thinking. You need to have a third-person approach here to make sure you find ways, and of course you have to be very good with the tools that exist as well to break, let's say, a Wi-Fi password, or to break into a very secure network, anything for that matter. And then we're talking about cybersecurity actually involves detailed learning methodologies. You have to learn a lot of tools, you have to learn a lot of techniques, and the other thing is that, right, whenever we're talking about cybersecurity, there is no one solution for every problem. So each of these organizations will have their own methodologies, their own policies, their own structures, right? They have their entire cybersecurity architecture, which could be unique to their organization. So as in when you progress in your career, if you are a part of a very big company, you will understand that their architecture is very different to probably someone else's. So in that particular case, whenever we're thinking about learnability, understand that you can get started with both ethical hacking and cybersecurity in a very easy way. But as you grow into your career, you might move into tools that are unique to their organizations in the case of cybersecurity. And with ethical hacking, you need to have the capability to learn new tools, because at the end of the day, cybersecurity companies can provide very good tools, very good firewalls, which will prevent ethical hackers from hacking them. But then to allow for all of that, of course, ethical hackers will find their way to get into the systems, or actual hackers as well. So in that particular case, if I have to pick one, I would suggest ethical hacking would be a little easier and a little more fun to begin with as well. But then that's my opinion. Head to the comment section and of course do let us know yours as well. So you might have a question saying, okay, I know what ethical hacking is, I know what cybersecurity is, I understand the comparison that exists, but which is better? Now, again, this is another very, very finicky question to answer, because there is no such thing as one being better than the other, right? So, ethical hacking is a part of cybersecurity, and ethical hacking will ask you to think completely like an hacker. Because if you have the capability to think like an actual hacker, it means you can beat him or her at their own game. So, you need to play the game. You need to be either as good as the hacker, an actual hacker, or be better than he or she to make sure that you beat them at their game. That's a very important thing that you should know. And then when we're talking about cybersecurity, right? Cybersecurity is all about preparing for what comes next, right? So you'll be planning for the next attack to make sure you can stop it in a way. But you're not wasting time thinking about what happened in the past, how to fix it and all of that, because this will eventually happen. You would have fixed a lot of vulnerabilities in the past, but your focus as a cybersecurity enthusiast or an expert is to make sure that you keep your eyes wide open to check what's happening with your product in the near future, because vulnerabilities are always there. Hackers are always waiting on the edge to have unauthorized access to your machine. So in that particular case, you really need to work on the future rather than dwelling on the past in the case of cybersecurity as well. So this is the difference that lies in between ethical hacking and cybersecurity.
Who is a cybersecurity expert? We need to understand that first in order to understand how you can become a cybersecurity expert in 2021. So, as the new year is approaching, if you're looking to change career paths or get into a particular career path, cybersecurity might be the career path for you. Job roles in the cybersecurity domain. So, the first one is application security engineer, second is security engineer, third is network security engineer. Fourth is information security analyst, and the fifth is IT security specialist. So we are going to be discussing about these five job roles in very specific terms. So let us start off with application security engineer. Right. So as the name suggests, it says application, so it relates to software, right? So any software engineer who creates, implements, and maintains computer software, right, and implements the security aspect of that software is called an application security engineer. So what are the tasks that the application security engineer implements in his job role, right? So the tasks include writing code, testing code, collaborating with the development team, right? So any software that is being developed, say for instance, Amazon.com is being developed or Facebook.com is being developed, there are obviously people who are concerned with the front end and the back end and the database of that particular application. But since digital crime is such a frequent occurrence these days, it is very important to implement security in that application as well. So you need somebody from a security domain with a security expertise in development to be part of your team, and that person is the application security engineer. So this particular person will test the security features of that website. He will write code and he will test code. He will also collaborate with the development team and suggest them on how they can improve the security during their development phase and add security features to their website if something is vulnerable. So those are the tasks of the application security engineer. It deals with development, testing, and collaboration. Qualifications, you don't need much qualification to be an application security engineer. If you're interested in the field, if you have the right experience from an academic level in this particular field, you can go ahead and get a job straight away. So application security engineer is not that difficult to attain a job in that if you're interested in it. The skills obviously include a coding language such as C, C Sharp, Python, Ruby, or JavaScript. Now, according to personal experience, I would say JavaScript is a must because you're mostly going to be dealing with web applications or mobile applications, and a lot of these applications are using JavaScript both on the front end and the back end. Definitely on the front end, right? So, one would suggest you should learn one a particular coding language like Python, Ruby, C Sharp, or C, and you should 100% learn JavaScript as well alongside those. Next up is security engineer. Now, security engineer simply means the person who creates and implements solutions to ensure security in a product or a system's workflow, right? So, for instance, you're working for an organization or you're working as a security engineer in an organization's application development phase, right? So, your task is not directly involved with development, but it is more so involved with the workflow that the organization is following or the development team is following. So the security engineer basically deals with ensuring secure standards and protocols in organizational workflow and delivery to avoid loose ends, right? So essentially, the task of the security engineer is to see whether the procedure that is being followed by the development team or the organization is safe or not, and the product that is being developed is safe or not. So, the other task that the security engineer has to deal with is unexpected security incidents or software changes. So, there might be an update in the software, sudden update, or a sudden security incident that might have arisen at the end user's end, right? So, the job of the security engineer is to basically manage and adapt according to that situation and come up with a solution for that. So, the qualifications are minimal. It is just a bachelor's in an IT related subject, and the skills would include experience and domain related knowledge. Now, depending on where this person is a security engineer, he needs to have knowledge of that domain and the security aspects of that domain. He needs to know how to manage tasks really well, and he needs to know frequent troubleshooting aspects of technology. This person also needs to be aware about the safe standards of development and the workflows that output the safest product possible. Next up, we have the network security engineer. Now, as the name suggests, network security engineers ensure secure deployment, configuration, and administration of the organizational computer network, right? So, any organization that you would work for, whether it is a business related organization or a development related organization, they are digital and they are using a computer network within their office premises or for their workflow, right? The job of the network security engineer is to essentially deal with security related hardware and software installation in that network, dealing with firewalls, VPNs, monitoring that network, and configuring the routers in a safe and secure way. This is to essentially prevent any third person from being able to access that network or any security breaches in that network or any suspicious packet that is flowing through that network that can be apprehended, right? So these are the sort of tasks that this network security engineer has to ensure. So the qualifications for this is firstly a bachelor's in an IT related subject, and next up it's also sort of recommended that you have a certification in the CISSP to get a good package and a higher chance of getting hired in this particular job role. So we'll talk about the CISSP in a moment. The skills that are required to become a network security engineer solely include strong knowledge of computer networking because that is what you're going to be dealing with, right? You should know how to safely ensure the proper working of a computer network, right? And you should know how packet monitoring is done, how firewalls, VPNs, and all of these things operate, and how network architectures behave in general. So you need to have strong knowledge about computer networking. So a quick briefing about the CISSP certification. CISSP stands for Certified Information System Security Professional. So the certification is an independent information security certification granted by the International Information System Security Certification Consortium, also known as ISC squared. So the prerequisite to be part or to get the certification to appear for the certification include 5 years of experience in any of the two following domains, whether it's security and risk management, asset security, security engineering, communications and network security, identity and access management, security assessment and testing, security operations, software development, security. So if you have 5 years of experience in any of these two domains, that basically means that you're experienced. Essentially, you're at a job role that has dealt with some of these domains. It's not exactly, you don't have to be exactly accurate about it, but it's a rough 5 years of experience that you need in it in order for you to appear for this examination, right? So if you're experienced individual in this particular job domain, Intellipaat has an offer for you. We do offer CISSP certification training. So if you're interested in that certification, you can go on to alpha.intellipaat.com/CISSP hyphen certification hyphen training. You can go over to that website and look over what we are offering for you. Okay, so moving on, information security analyst. So information security analyst is an analyst that is tasked with examining and solving security problems, right? So essentially, this is the thick of the job role that is there. This is the most vague job description that is, right? So the analyst basically deals with researching, finding security threats, developing strategies to counter, and penetration testing, right? So this is what a hacker does. Basically, this is what the job role of an ethical hacker is, right? So this is the version of the job that is dealing with ethical hacking, right? So the person has to keep up to date with the latest hacks, keep up to date with the latest technologies, and the person has to basically see whether in an organization or a product that has been developed by that organization has any security vulnerabilities. So this person has to basically attack that software or that organization's network or whatever we're dealing with essentially. He has to attack that and see if he's able to attack it, and he has to document the process of how that person basically attacked that network. Next up, IT security specialist. Now, the job of this person is to examine the cybersecurity free architecture and history of an organization. So basically, any application or organizational framework that the organization is based on, this person has to examine the history of it. So essentially, the past breaches that may have happened, in order to implement preventive measures for any such breaches in the future. Right. So the tasks include basically a broad range of tasks. It depends on the domain in which this person is an IT security specialist. So it could depend on if the organization is working on web applications, or if it simply means that this person is an IT security specialist for the network that the organization is using, right? So the qualifications are straightforward, a bachelor's in an IT related subject, and since this person is a specialist, so whatever exams that need person needs to give in whatever domain to become a specialist in that security domain. So specialist qualifications are necessary in order to be termed as a specialist, and the skills are same as an analyst, except here you need an in-depth sort of knowledge about the domain that you're specializing in, right? So you don't need to know all of it, but whatever you're specializing in, whether it's Linux or whether it's networks or whether it's programming, you need to have the appropriate amount of skills for it.
Just a quick info, guys. Intellipaat provides CISSP certification training, mentored by industry experts, the course link of which is given in the description below.